you should be at this particular GitHub repo. Also, yeah, Ansha, can you talk a little bit about the book?
Yes, sure. So Chris and myself, we're actually honored to be also O'Reilly book authors. So we're currently writing a book about data science on Amazon Web Services. And Chris is currently showing here the website. So you can actually go to datascienceonaws.com to find that information. And yeah, we're both writing about really kind of the end-to-end workflow, how to run data science on AWS. So we're starting really on how to get the data in ingest and then exploration. And it's pretty much what we're going to show you also today with a hands-on part actually. And then all of that will come in a form of a book targeted release early next year. So we're super excited about that.
Yeah, and so we actually do have a survey also. At some point you could fill that out and that will help influence the book. We actually ran this, a version of this workshop 1 month ago, and we actually made quite a lot of changes to the book because of the feedback that we heard. So we're about halfway done in writing. We've got most of the material and the code samples built. Now it's just filling in the narrative. But based on what we hear and the questions that are asked and the feedback that we get from these workshops, we actually do incorporate this into the book. So yes, in some ways you're all, like helping this out. Okay, so people are starting to ask what's the next thing to do here. So team dashboard. So you'll see this thing is the team dashboard. So make sure again that you're following the README, the docs here. And that's exactly where I'm at here. Let me resume my share. You should be at team dashboard here. And these are the two things in green are the two things that you have to click. So click on AWS console on one screen and go open AWS console on the other. Note that you must be logged out of any AWS console in any browser tab anywhere on your machine. Otherwise, you will be asked to log out, and which you should log out of your. Okay, so just know that make sure that you're logged out. Please try to get through this here in the next couple minutes. And don't worry about these credentials. Don't do anything with these credentials. You should not be using any AWS access key or secret key from anywhere. Do not try to connect to this environment from your laptop. It will cause you pain later. Just stick with these instructions. Some people ask, why can't we do this workshop in our Amazon account? And you certainly can, but we cannot support you today. The only thing that we could support due to the number of people and the pace that we're going is this environment. So yeah, Ansha, can you take care of someone's asking that they missed the first slides? There have been no first slides. All you need to do is, this is the link, and Ansha, can you send Stuart the link to the allocator so he can get to the...
Yes.
All right. And do not try to do this today in your own Amazon account. You might not have all the permissions set up. You might not have access to all the services. Today, if I show you here the agenda, you'll see we're going to cover a lot of ground. And we cannot guarantee that your Amazon account has been authorized for all of these services and the type. So this environment is purely on Rails, and this is how we have to move forward, or else if we try to do this with people's separate accounts, we just spend the whole day debugging, permissions issues and, corporate corporate accounts, and also keep in mind too that we're paying for all this. So this is Amazon. We are giving you guys this free environment, and you should please just accept that we're going to pay for this. You can certainly, after the fact, you could certainly reproduce this in your own account. We have no problem there. You'll have to work, with your corporate security to make sure you have access to SageMaker and have access to EMR and access to, Kinesis and step functions. But today we've already pre-configured all that. We're going to be running tens of thousands of GPUs, tens of thousands of CPUs, terabytes of disk. We're, hundreds of thousands of gigabytes of RAM. So lots and lots of fun stuff today. Just stick with us and know that all of this stuff is open source. You can pull this workshop down anytime and run it on your own. Just not today, please. We get a lot of questions about the cost. We actually haven't kept track of that. And I don't think you have access to the billing tab in this. I would estimate, here's the thing. So we can go the very thrifty, sort of inexpensive route with you guys, or we can open this up and use GPUs and have fun. And I would rather not focus on cost today. I want to show you what's available. If I were to estimate just kind of loosely, because we do use pretty beefy GPUs and pretty large instances, I'd say it might be $100 for the whole day, for 6 to 8 hours. You can certainly get by and spend $10 or spend $5, but it's not as fun and it takes a little bit longer. And we want to actually push this thing to the limit and show what the Amazon cloud is all about and how to use KubeFlow and how to use all these things. Okay. Okay. Ansha, there's some people asking here. I'm assuming you can help out. Yeah, and please help each other out here. Okay, so Ansha's helping out Waikiki. You should be getting responses there. Okay, and for the most part, actually, so I've got one survey here. So while we've got a couple extra minutes here, let me end this poll and take a look at what we have here. So lots of people are comfortable with command line. That's good. That's actually really good. We don't do we do a fair amount of command line. Sometimes it's just easier just to bang out a quick, call to the Amazon CLI or out to the KubeFlow like CLI. So that's good. Python, good. Linear algebra looks pretty good. Definitely over half of people. Statistics, same kind of thing. Docker, it's a pretty hardcore group here. Kubernetes, pretty good, 40%. Jupyter Notebooks, 80%, that's good. Keras, 37, TensorFlow, 40, 20% PyTorch. How about roles? So it looks like we got 35%. And we've made these multiple choice because we know people don't just play one role and they don't just use, just TensorFlow or just PyTorch. Got a couple founders, CEOs, bunch of ML engineers, about 35% ML engineer. So we've got a good split between data engineer, ML engineer, application developer, a couple sales engineers, always good to see, data analyst, 16%, product managers, good to see, we got about 10%. And let's see, CIO, CTOs, 5%, DevOps, infrastructure, 20%, good. And then data scientists. So we've got about a third data science, a third data engineer, and a third ML engineer, almost exactly what we were hoping for here. So very good. How likely are you to use Amazon for AI and machine learning? So, this is us just kind of getting a pulse on what are people using today, and how likely are you to use AWS for AI and machine learning. So it looks like over half are very likely to use it, somewhat likely, about 25, not sure, 16, and then a few no's. So those are the folks I assume using Google. That's totally fine. This workshop actually used to be on Google Cloud up until I joined Amazon about 6 months ago. So And I guess we should probably do like a quick intro. I think it was on this thing here. Let me scroll back up. But Ansha and I work for AWS. We're both developer advocates for machine learning and AI. So I think, yeah, this was already up there. So I'm not going to spend too much time. When I moved to the Bay Area about 10 years ago from Chicago, I went straight to the highest scale, highest throughput, highest, like most difficult challenges. I went straight to Netflix. From there, I migrated to Databricks, got a lot of Spark experience, big data, machine learning experience. And I've been doing conferences with O'Reilly. We have a current like online training happening right now that is pure. It's pure KubeFlow, pure open source. So if you want to go to Safari and search, I think the next one is going to be in June. We just did one, I think, last week, 2 weeks ago. That was really successful. We're using Katacoda for all that. And yeah, currently AWS, and I live here in San Francisco. Ansha has a similar role, comes from MapR. So she came from Cisco and then joined MapR. So she's been working for Bay Area companies out of Germany for the last 10, 12 years. So yeah, anything else, Ansha?
No, that's about the short version. Yeah, exactly. So yeah, a lot of like infrastructure background, big data background, and most recently, really working a lot in machine learning and AI, and yeah, covering the Europe region basically.
Cool. And I just quickly glanced, a couple people asked, why did I move this from Google to AWS? It's because I work for AWS. Previously, I was running a startup, and I had credits from both AWS and Google. And I was just going back and forth, basically, when I had money in my Google bucket. The cool thing about KubeFlow, as we all know, is this stuff is portable between clouds. And so, literally most of my scripts, I just lifted and shifted over to Amazon. I'd make some changes over there to talk to S3 or to like integrate with IAM roles. And then when I needed to, I would move back to Google. Also, prior to here, I started this company, Pipeline AI, that was doing multi-cloud. We were really focused on like multi-cloud. And since then, I've joined Amazon, and I'm pretty much laser focused on Amazon. All recordings are at youtube.pipeline.ai. This includes all of my past recordings, including a similar workshop on Google Cloud. Okay, and just keep in mind, Amazon is paying for this, so just at least tip your hat to them and say thank you for like offering these things. But yeah, okay. So I guess let's see how the last question. How likely are you to use KubeFlow? And okay, so 30% are very likely to use KubeFlow in the future. They're somewhat likely to use it. It's probably a little bit higher, so 35%. Not sure, 30%. So, about a third aren't really sure how to use or aren't really sure if they're going to use KubeFlow for AI and machine learning. So I guess that's why you guys are here, and we'll continue on here and hopefully maybe change your minds. Yes, Amazon rocks. Funny. Okay. Yeah, now Ansha, a couple people asking. So the way this is going to work is I think I'm going to do the beginning part. Or no, actually, what's on the agenda here? The agenda is, yeah, Ansha, you're going to do so this is considered the intro. Ansha's going to do the next few sections. I'm going to come back in at the end of 04 on the agenda up here. And I'm going to carry us through 04, 05, I think 06 and 07. We actually deferred 08 and 09. Didn't feel that the content was up to the bar that we like for the other sections. So we will point you, the code is still there. You could certainly look at it, but it's not quite workshop ready. So 8 and 9 we will pass. And actually, also due to time, when we did this last time, the first few sections, basically by the end of the workshop, people were like pretty exhausted. So we want to get you to the KubeFlow stuff as quickly as possible. So we'll stop with the SageMaker stuff around 07 and then jump right into KubeFlow and spend the rest of the day doing KubeFlow. So thank you much, Ansha. I'll take over the questions. And if you can update me also on Slack, if there's anything I need to look at, then I can bounce over there also.
Yes, I'm just double checking here. A couple of people joined a couple of minutes late. So let me just quickly clean up here my screen, and then I'll walk you again here through the instructions.
Yeah, and just to set the expectations here, we will not be covering Airflow today. We've covered Airflow in the past. You can look at youtube.pipeline.ai and also slideshare.pipeline.ai. I don't have specific links. I would have to go back there and take a look. But we do have Airflow in some of those materials. You know, we love Airflow. We've just also found some other ways to do it. You know, KubeFlow really, as some of you might know, is really a kind of a competitor. It's an open source competitor to Airflow. And what we found was when we did both Airflow and KubeFlow, people were then like, well, which one should I use? I don't really understand. Why am I working in Airflow? And then all of a sudden I go and I see this super slick KubeFlow. So yeah, today, just to manage expectations, no Airflow. We will be doing a bit of TFX, but we'll primarily be focused on KubeFlow pipelines.
All right, and you have to stop your screen share so I can take over. Zoom is very restrictive here. All right. Let me see. All right, so hopefully you should be able to see my screen and hear me okay now. Just a quick recap. So we provided you in the chat window with a link to an allocator script. If you hit that link once, you get a JSON response, and in here is a URL. So you grab that URL. Don't grab mine here, please. And it takes you to this dashboard environment. If you click that link, it already populates the team hash. Otherwise, you can just grab it out of that link. And then it opens up a console like this. And if you follow the instructions on that Git repo side, just ignore all the rest on this side. Just click the Open AWS console. And that takes you to a completely freshly provisioned AWS account for you to play around with for the duration of this workshop. So in case that didn't work for you, make sure you're signed out of all other potentially AWS accounts if you had any open before. But everyone should come to this site. And then basically on the Git repo, we have the instructions. So let me just quickly scroll up here. So if you missed those steps or you want to like replay later, really follow those steps here. And it shows you exactly what you need to do. So let me just pull this actually here side by side. Hope that doesn't mess your screen here too much. All right, so just to have the instructions. So all I did here is splitting my browser window to have the instructions on the left and my account now on the right. So I'll try to make a little bit more space here. All right, so the first thing we do, and I think a couple of you already started doing that, is we're going to Amazon SageMaker. So let me click here on the right on Amazon SageMaker. SageMaker, for those of you who are not familiar with, is a fully managed machine learning service from AWS, which gives us a lot of functionality capabilities to basically build, train, and deploy models. And what we're doing here as a first step is provisioning a notebook instance. So in the left menu, you see here notebook instances. And this is basically a managed hosted Jupyter environment that we can also leverage through this service. So I'm going to click here on create notebook instance. I have to do this right now as I have been answering questions before. So if you're a couple of steps ahead, just bear with me here for a little bit. So as you can see here on the left, there are all the instructions. So the notebook name, I call it, or the instance, better said, the notebook instance, I call it workshop. Make sure a couple of you, I think, selected the default here, the notebook instance types. Make sure you follow the instructions. It should potentially work with a smaller instance, but we're pulling down some data later in the workshop. So if you're provisioned instance that is maybe too small, like the T2, maybe feel free to just provision a second notebook instance server here right now. So those are the instance families here from AWS. The T's are actually smaller instances. So if you're just poking around, exploring, those are totally fine. For our purpose, as we're really doing a lot of code here and also a little bit of like in the notebook training later on, we need a little bit of a more beefy one. So we're selecting here the C5 to X large, which is a compute optimized notebook instance. And also, if you're open here, the additional configuration, per default, the attached volume would only be 5 GB in size. And we also want to increase that. So I put in here, as shown in the instructions on the left, to 250 GB, just to have a little bit of headroom if we're pulling down some data sets later, not to run out of storage here in the volume. All right, that is in here. And then we need to set permissions. So this demo environment has already an IAM role provisioned. You can double check, by the way, on the top right of this screen that you see here, you're logged in with team role master key. If you see something else, you might have ended up in a different AWS environment. So make sure you're also seeing on the top here that you're using the team role. So we can actually stick to that one. That is fine. And if I scroll down, the next settings we have to do is basically for the networking part. So here, select the VPC. You just have one default VPC here available. The number here might differ in your case per account, obviously, but just select the default VPC you're seeing in here, and then select the subnet. So I'm going for the US West 2A. And then there's also just one default security group. So also make sure you're selecting that one. So those are the settings where the notebook instance gets created in. So make sure you have selected that. And then you can click here on Create Notebook Instance. And this takes just a couple of minutes here to provision. In the meantime, also, if you click on that name of the instance workshop, you can do that while it's provisioning, that's fine. We're also adding another policy to that role. So if you're scrolling down here until you see IAM role, we're clicking on here, this is the team role, basically, the identifier. So if you click on that one, it takes you to the identity and access management service in the AWS console. And here actually, I saw some questions before. Somebody asked like which IAM roles we pre-provisioned. This is actually where you can see the team role, which capabilities and which policies are already attached. So in our case, we actually need to attach one more. And this is definitely recommended always to do the least privilege. So whenever you've been working with AWS before, you've probably heard that. Obviously, only give out the permissions that you really need to do a specific task. So in our case here, we click on Attach Policies, and you can search here in the search window, and we're looking for Amazon S3 full access, because we're actually reading and writing a lot of data to and from S3. So we're just giving this one here full access, and make sure, might have need to maximize here, otherwise I don't see the button here, attach policy to select that one. And then you should see here that in the team role profile, we have the Amazon S3 full access attached. All right. I hope everyone could follow. If you're a little bit behind, don't worry. Really follow the instructions on GitHub. It's really here shown step by step Basically, create the notebook instance as the settings here are outlined, and then go to the IAM role that you see here. If you click on the name of your instance, and inside that IAM, click on Attach Policies and look for the Amazon S3 Full Access, and checkbox and make sure you're attaching the policy. All right, and with that, let me close this one here and go back to my SageMaker instance. All right, this one is still pending, so I just give it a second here.
Hey, so should we do a quick poll? I think most people are caught up, but I think there's a few people that aren't. So let me send out a quick poll here. And this is just like a pulse check, we call it, to see how everyone's doing. If you're a little bit behind, but you're okay. If you're totally lost, tell us that. If you're totally lost, shoot me or shoot the panelists a direct link. If we get to about 75% good, we have to keep moving ahead. Okay, so it looks like about 75% are good, 20% are just a little bit behind, so that's good. Lost, please send me a direct. Okay, yeah, and there's people that are already at Jupyter Lab and want to keep going here. Okay, so I think we're in a good place. Yeah, okay, we're good. So for those, there's a couple percent. Please shoot me a note here.
All right, perfect. And appreciate the ones that are going ahead. All right, so everyone should hopefully, I just refreshed here my console window. So once the instance is provisioned, you see here the status change to in service. And then you basically have the option here to open Jupyter or open Jupyter Lab, whichever you prefer. We really find that especially when we're doing visualizations, that Jupyter basically shows them in more cases. So I'll open Jupyter, and then this takes you straight into the Jupyter environment. And this will be our home ground here for the next couple of hours. So let me just quickly, I'll grab here in the instructions, basically this Git repo, because we're cloning this in just a second. So I'm copying this from the instructions, and then I'm maximizing my window here. All right, so when you follow those steps, you should then end up in a Jupyter environment. Given that I assume most of you have been working with machine learning, data science, AI before, you're probably familiar with Jupyter. For those of you who haven't seen it yet, no worries. You can think of Jupyter as just kind of an easy development environment. It's really super intuitive, so hopefully you will find it easy to use as well. So what we're doing here, I'm click on new in the top right, and let me zoom in here a little bit so you can actually read it a little bit better. And then open a new terminal window. And we're using the terminal now to just git clone our repo. So with the code instructions that I just copied from the GitHub instructions, we're switching into the SageMaker directory here, and then we're doing a git clone on our Data Science on AWS workshop Git repo. So once you have seen that successfully done, you should then see, zoom a little bit out here, the workshop folder popping up. So you can click in here, and you can see here now basically our outline for today. So you see here the 0, 1 for the setup, then AutoML, ingest, explore, prepare, train, optimize, and then KubeFlow. And this is kind of the agenda for today. So really just follow with me like step after step here. And you can always revisit if you want to have a look at the detailed notebooks in there. So let's just get started here. So I'll open up the 0-1 setup. It's a pretty short one, pretty easy one. So in most of those subfolders, we do have a quick overview notebook, which gives us a little bit of of outline for that particular part. So here it's really just saying hi to you again. And also kind of fun to see that you can actually also embed HTML code in Jupyter. Not sure if everyone knows that. So you can actually show an iframe here. So we're just basically showing our book website in here. Kind of fun, just a little bit playing around with Jupyter here. So nothing too complicated here in this notebook. More important is the next one. So please open also the 01 create S3 bucket. And basically throughout this workshop today, we're going to reuse an S3 bucket. So we need to make sure this one is actually correctly assigned. So just really execute those cells. So if you haven't done that before in Jupyter, you can click into a cell and then do Shift Enter. And this executes the code that is shown in here. You can also do cell run all. In some notebooks, we have to take care because we need to have some other jobs being finished. So it doesn't work in all of the notebooks, but feel free to give it a run all, especially if we walk through and explain a lot and you find it difficult to do it yourself and listen to what Chris and I might talk you through. So a good practice later on, you could do a run all, then just watch us explaining and then revisit your notebook. All right, so we're executing the cells here. Basically, I'm importing Bodo 3, which is an AWS Python SDK. So we can interact with the AWS services through Python. And then also we're pulling in SageMaker. This is the SageMaker Python SDK. And this gives us really the capabilities to interact with the AWS services out of our notebook here. We're defining the session we're currently working in and the region. And then, as you can see here, SageMaker also sets up and works with a default bucket. And this is the bucket we're trying to pull out here. And if you run those cells, you should see here your default bucket. So this will be another number for you as it's tied to those account numbers here. But you should see a similar output to this one. And then you can also actually, if you're doing this %% bash, you can run bash commands out of the notebook cells. And here we're actually using the pre-installed AWS CLI command. And we're communicating with the S3 service and do an ls, a show command on our bucket. So we can actually also see the bucket is there. Not much content in there yet, but definitely that worked. All right, that was an easy first notebook really to make sure we all have our S3 default buckets set. Hopefully that is pretty straightforward for most of you. I'm closing my tabs here as well. If you want, you can also shut down the kernels of those notebooks, not to keep like probably the 50 notebooks up and running. So once you're done with notebooks, feel free to also, as a little bit of housekeeping, shut down those notebooks. All right. Hopefully everyone is following. That was really kind of an easy setup task. And if Chris doesn't like stop me here, I'll move.
So let me stop you a sec.
Yeah.
A couple things. So we've reached the maximum index. We do have other, a completely separate other pool of instances that we will pull from here in a sec. So I will address those. The other thing, please do not go into SageMaker Studio. This workshop does not support SageMaker Studio. There's some differences there. I see a lot of people getting excited and going over there, and I see some questions about it. If you do go into Studio, you will not be able to complete this workshop today. So please don't do that. Go back into US West and do that. And please follow those instructions. Okay. Let me get to the other folks here that are looking for the allocations. Okay, thanks.
All right, sure. Let me resume my share. Okay, so while Chris is working on allocating a couple of more resources here, let's go to 02. So in 0.2, we have a little bit of more things going on. Let's open the 0.0 overview. And what we're doing in this first part of the workshop here is showing you actually what we call a one-click auto ML example. So some of you might be familiar, especially the ones who have been working with AWS before. Maybe it's new for a couple of you as well. But basically, Amazon has been launching a new service at the last reInvent called Autopilot. And what Autopilot gives us is really kind of a nice white box approach to automated machine learning. Meaning you might have cases where you just want to throw in your data and have kind of, the magic service figuring out all of the best model algorithm to use and the settings, the hyperparameters to use, and basically make your life as a data scientist, machine learning engineer a little bit easier, right? Normally you spend probably a lot of hours developing your models and then figuring out which framework, which algorithm to use, which settings to use. So recently, automated machine learning has become really popular, right? So why not let the machine solve this problem, right? And Autopilot has been launched, as I said, last reInvent, and is really a really cool example on how you can use this AutoML with just really a couple of clicks. So we're going to show you this in the first chapter here, and also to show you what we're using here. Let me just a couple of typos here. It doesn't matter. As a data set. So throughout this workshop, we're gonna use the Amazon customer reviews data set. So if you've been shopping on Amazon.com before, you've probably seen the review section. So at least if I want to buy a product, I always check, if other customers like that product before. So it's a really, really great data set, which Amazon.com actually released to the open. So if you're looking for Amazon customer reviews, you can find this data set. It's hosted in S3. So you can just pull it down. And it consists of over 130 million customer reviews since 1995, and I think up to 2015 in here. So you can pull that data set down and then do all kind of machine learning exercises with it. And we basically decided to use that. It's kind of a fun data set to use. And also, as we're showing a lot of NLP, natural language processing in the workshop today, it's a really good example. So we're using this one here. So jumping back here, and what you basically do is now we have a smaller subset of the data set, and we're feeding that in this exercise into SageMaker Autopilot. And then in a second step, we'll also show you a fully managed NLP service, which you could use if you don't even want to bother with Amazon SageMaker and playing around with those clicks, and you just want to have a service that's giving you all the answers. But yeah, let's have a look. So let's actually open the next notebook here. So 01, prepare the data set. So as I said, we're using the Amazon customer reviews data set. And here's also the link again, where there are more instructions on exactly how you can pull the data set down, for example. Basically, if you look at the schema, it contains the marketplace. So in our case, we just use the US, that is English reviews. There's also a couple of examples, I think with French and German reviews and others. So in our case, we're really just using the English ones from the US marketplace. It has a random identifier to represent the customer ID. It also has a unique ID for the reviews, the product ID of the products that's been reviewed, product parent, the title, and the category. Then the star rating. So there's basically the text and then also which rating the reviewer gave. 1 to 5 stars, whether it's been helpful. So there's a number of helpful votes for this review, the number of total votes, whether this review was written as part of this Vine program that Amazon offers, and also is it a verified purchase, the headline of the review, the actual text, and the date. So it's pretty comprehensive what you can pull out of that data set. All right, so let's start again. I actually do here a run all cells to get that started. Feel free to do that as well in your case. We're pulling in again our SDK, so Bodo, SageMaker. We're also using pandas here, setting the environment up with the session, bucket, the role we're operating in, and the region. And then we're using again here the CLI command. So we do an AWS F3 copy command. And you can see here, we're pulling down one category. So as I said before, the reviews dataset is pretty extensive. And actually they have 43 product categories, from books, ebooks to, as you can see here, digital software, digital video. And the dataset is shared in TSV and also in Parquet. So in this case, because Autopilot needs to have the input data in CSV format, we're actually pulling down here the TSV file for all the reviews that fall into the category of digital software. And also we're saving this here locally to do a little bit of processing. So in with pandas, we can read then the CSV file. So we're giving that the file, we can do a shape. So we see how much data is in here. We do a quick head. And here we can actually have a sneak peek. So marketplace, US, customer ID, which is a random number, review ID, product parent is a number, title. So what do we have here? Norton Internet Security. Wow, it's been a while since I used that one. Product category, digital software. And here you can see star rating that actually got a 5 in that review. No Vine program, verified purchase. The headline works as expected, and also the review text. So this reviewer was a little bit lazy, just copy pasting. And the review was from 2015. All right, so I think you got a good understanding of the data set. I think it's pretty self-explanatory. And we can also do some first visualizations here. So actually pull in Matplotlib, which helps us to do some nice data processing and visualizations here together with pandas. So basically, we're grabbing our data frame. We're grouping it by the star rating, doing a count. And then we're plotting that as a bar chart. And as you can see here, we get a breakdown now by star rating for the reviews. So you see star rating of 5 really has the most reviews, which is close to probably 50,000 in here. And followed by the 1s, and then 4, 3, 2, meaning most people actually who gave a rating, gave a really good rating with 5. And second, they gave rating of 1. So it kind of seems like you're either really super excited about a product or you really hate the product. 2, 3 is less given here. 4, yeah, maybe. All right, so in terms of data science, this is a really unbalanced data set, right? So a first step we're doing here, back to our day job, we're balancing the data set here. We're making just a couple of here resample calls, and then per category, so 5-star, 4-star, 3-star, we're basically just resampling and making sure we're cutting it down to the lowest number. So if you're visualizing after those, you can see that we're cut down all of the reviews to the same number of reviews, just to have a balanced data set. And this is really a simple way to do it, but in our case, it's good enough, right? We just want to make sure we're not putting in bias by having, like 10 times the number of 5-star reviews than maybe 2-star reviews. All right, now all the categories have the same number of reviews. We can double check here on the shape. And we also cut down on the actual columns. So here you can see that we're training basically with a star rating and the review body. And what we want to do basically is being able with our model to predict the star rating. So I want to give the model later my review text, and then I want to have a prediction or a classification, better said, which star rating this would be. All right, this is kind of the exercise I want to do. And as I said, Autopilot wants to have some CSV as data input. So basically, we're setting here the path to write a CSV with a header. So Autopilot also needs kind of the column headers. So we're making sure to write that CSV file here. And then we're uploading this training data CSV file again to F3 to make it available to Autopilot. So in this command here, we're just really doing a session upload from this local training path and putting it into our F3 bucket. So here you can see that the CSV file got exported and uploaded into F3 again. We can do make a quick show command here, and we see the file is in our bucket. So as I said, later on, we also do a quick exercise on Comprehend. Comprehend is a high-level AI service from AWS, which basically implements NLP. So here we don't even have to care much about settings. We're really feeding it with the data. So just for Comprehend, we need to make a slight change, as basically Comprehend wants to have the input data without a header. So here we're just doing the same exercise, but we're making sure not to write the column header out into the CSV. And then again, we're uploading the training file here to F3, making sure it got written. And because we're like jumping from notebook to notebook, we are storing that information. It's basically just storing some variables here, quick and dirty, in this instance here. So with this store command, you can actually write out a variable, and then we can retrieve and read that in the next notebook. So here we're just saving really the string where our files reside in F3. All right, this was a quick and dirty data preparation for our Autopilot. Hope you're all following here. And let's open the train reviews and let's kick those jobs. Let's get them started because they will run for a little bit, and then we can actually have a quick break here and see how everyone is doing. But I just want to make sure to kick this off, and then we can probably have a ton of questions already here and make sure everyone is on track. So let's actually train a model now with Autopilot. And again, I can probably, let me have a look. Yeah, I can probably do a run all or just do it manually. You can just shift enter through this notebook, and that's also jumping from cell to cell. So in the first step here, again, we're setting up the notebook environment, nothing too fancy here. And here you can see how you can retrieve that information again from the previous notebook. So I'm doing the store and then the R for retrieve, that information where my training data is stored. You can see here, that's just the path I've been storing from the previous notebook. And then here we have the CSV file. So for Autopilot now to get started, I actually define where it's gonna store the output. So I'm gonna do a path here in my F3 called a prefix models/autopilot. And this is really where Autopilot dumps then all the results. And I'm gonna explain what's happening here in just a bit. So basically for Autopilot, we provided with a data set, and we can define a couple of input settings here. So for example, we want to have Autopilot in this case give us the 3 best candidates to solve this machine learning problem, right? And you can basically put in any number here. In our case, we're trying to keep the execution time here a little bit limited. So I'm saying I want to have like 3 best candidates. And what does that mean, right? So the jobs for Autopilot contain a couple of settings here. So for one, the completion criteria, which is not yet really machine learning related, but it's a way to give it a maximum runtime per training job in seconds. The maximum candidates I set to 3 here. and then the max AutoML job runtime overall in seconds. So what happens then, as soon as I give Autopilot my input data, which I'm doing here, input data config, I'm pointing now to this CSV file, and I'm telling Autopilot that I wanna target on this attribute, which is star rating, meaning I wanna predict that data column in that CSV, right? The target attribute. And this is basically, as you can see, all pretty much I'm giving Autopilot. So I'm giving it a CSV file with data, and I'm saying which is my target column, target attribute I want to basically predict. And all the rest, Autopilot is supposed to figure out itself. So let me run this cell. And then I can kick off the job, right? So I'm just creating the job name. I'm adding a timestamp here to be able to track it if I run more of them. And then I create the job. So within SageMaker, I can call here the create AutoML job right out of my notebook, give it that name, give it the input config, give it a place where to store the output config. I could, if I want to, give it a problem type. So I could say this is a classification problem, but basically I don't have to. So this is why this one is commented out here, because we want to see how Autopilot performs if I'm not giving it this, this information, right? So execute this one here, and you can see that now the Autopilot job got created. And this will take a while. Here is basically another cell to make sure we're keeping track of what's happening. So this will run for a little bit, right? So as you can see here, this is looping over the progress of this job. So whenever you see this little star next to a cell, this means the cell is still executing. When you see the number, it's finished. So this is where we have to stop right now to give it a little bit of time. Think of it, it's a data scientist in a box, right? So the little data scientist needs time to do the job. And you can see here, so first, what's happening, Autopilot now takes the CSV file and has a look at the data. So this is meant here with analyzing data. So it tries to figure out, okay, what is my data set, right? How many columns? Is the data clean? Are there missing values? Do I need to do any data pre-processing? And this is happening right now. So data is being analyzed. And then in the next step, Autopilot will do the pre-processing of the data, and then it will start training a model. So as you can imagine, this will probably take, I'd say, 15 minutes to run. So just make sure this cell is started, and you see here that the in progress is running. And with that, we can basically go ahead, leave that open, don't close it. But in the meantime, we can also kick off comprehend. And let me quickly go back here into the console window and to show you comprehend. So if you're looking here, and you can just watch me, you don't have to do it yourself right now. You can really just watch my screen for a little bit. So Amazon Comprehend is what AWS calls the high-level AI services. It's one of those that offers us natural language processing and text analytics out of the box. So this is even simpler. If you're familiar with that overview slide that AWS shows sometimes with the high-level AI services, the idea here is really that you don't have to have much understanding of machine learning to use them, right? So as it's shown here, you basically just provide the service with your input data, and then you can select from a range of use cases that are implemented: entity recognition, sentiment analysis, key phrase detection, language translation, etc. Basically, typical NLP tasks, document classification you want to do without really having to know how to do it. So really kind of a fun and a great service to use. So this is, I'm zoom out here a little bit again. This is what we're going to do here in the next exercise. So I'm going to open the 03 notebook, train reviews. And once we kick them off, we then go for a little break and make sure all of your questions are answered and you have time to to go through those notebooks and read up a little bit. So you can obviously use comprehend through CLI or also through the console. We're actually in this notebook really just executing this notebook code. So what we're doing now, we're just executing those cells. So let's actually go through here. We're pulling in again a couple of informations again. So where's our data stored? And then as you've seen here on the top, there was a requirement that we actually have given now SageMaker, because we're operating outside of SageMaker. We need to give it the permission to talk and interact with comprehend. So here we're actually showing you quick, for those who are interested in how you could create those policies and attach them also programmatically through a Jupyter notebook. If that's too much detail for you, don't worry, just really execute the cells. But it's kind of fun to see how you can create a policy. So this is what we're saying here. We're creating a policy document in JSON format saying the service comprehend, and we want to allow to use the service and actually to assume the role. So we're creating this policy document. We're creating a role name called DSO AWS, Data Science on AWS Comprehend. And we're trying to create the role here. And we're creating the policy document, which also gives access to F3 here. So this is comprehend to F3 access. And then we're attaching this policy to the role. So this is really a little bit how IIM works. And if you want to do that through programmatic ways, you can obviously also do that through the UI, through the console, if that's easier, but it's also kind of nice to show how you do that in a notebook. All right, so with that, we should be set up. So we also specify here an output. So in this case, we're saying comprehend/output as our target folder. And we're making sure we have the role ready. And then here we're basically doing a custom classifier. So what we can do, we could just give our input data to comprehend. But in this case, we're actually optimizing comprehend to our data set. So we're basically kind of fine-tuning, if you will, the NLP model to really fit our data set. So we're actually doing here, as you can see, create a document classifier, which is a custom one. And we're providing it with our training data with the reviews to really be like super specific here on our input data. So this is what we're doing here. So we're defining this training job. And then again, we're keeping track of the classifier. So you can see here the custom classifier is submitted. And this one you can actually see also in the UI here. So if I go here to comprehend and on the left on custom classifier, I can click in here and scroll down, and this should show me here down in the bottom the classifier that I just submitted. So both of the jobs, autopilot and the comprehend custom classifier, are now training. And again, this will take a couple of minutes. And once this one is done here, we can show the results here in the rest of the notebook. But this is a good time, I think, here to stop and check on you if everyone is following, and maybe also answer some questions here. So Chris, how are we doing?
Yeah, lots of questions as expected on autopilot. So let me just go one by one here. I think these are really good questions, and I think there's even some overlap. Okay. Also, a couple of people got errors. I think, Ancha, they're jumping ahead and running. Can you just kind of scroll down and show on your screen, like if they do? So if you do run a couple of these before either autopilot is finished or comprehend is finished, you'll see errors. So these are all meant to run, and where possible, we say, please wait until the thing before it completes. So you will potentially see errors depending on how fast you go through these notebooks. Let me see. Let me start. I'll give this 5 minutes, so it's 9:15. At 9:20, I will cut it. But I think these are very good questions. Is AutoML AutoML exploring different model types in parallel or serially one by one? AutoML does this in parallel. There is a strategy of AutoML called Bayesian, and Bayesian will build upon previous runs. So you have total control. If you want to do 2 batches of 3 each and do the first 3 and then the second 3 and learn from the first 3 because you're using Bayesian, then that's fine. If you want to do all 6 in parallel and not learn from previous runs, then that's fine too. So you could do grid search, random search, you could do all kinds of search. That's actually also applies. So there's AutoML and there's hyperparameter tuning. We're showing you guys the latest and greatest AutoML. You can also do just straight up hyperparameter tuning, which we cover later in section 07. We have lots of examples there. AutoML is give it a data set and figure out what is the right algorithm. Is it XGBoost? Is it linear regression? Is it logistic regression? Just looking at the data set, it will try a bunch of things. It's obviously using experience that like Amazon.com has and other, all of the modeling that's happening within Amazon Web Services. All of that knowledge over the last 20 years is buried behind things like AutoML or this like autopilot service, Comprehend, all these services are using all that experience. Let me quickly, okay. Let's see, for large data sets, can AutoML cache the data, read the data? Yeah, so questions about, specific implementation detail of how is data cached within Autopilot. As far as I know, it's doing it in the cheapest and fastest way. I don't know specific details. I know it's essentially built upon the hyperparameter tuning feature, and but if your concern there is cost and reading data, S3, it will be minimal cost. Okay, can we have more QA? Okay. Let's see, is Autopilot perform feature normalization, transformation, feature interaction, cross-validation? So Autopilot does some of this. Autopilot, for example, with text, as we'll see here, it will end up generating TF-IDF vectors. And so, that's a form of feature engineering, feature transformation. Some of the feature interactions, it's not doing, all of the different feature interactions. It will perform PCA and, figure out what are the principal components. We can, dive deep into some of this later when we actually crack open some of these notebooks that it generates. I think you guys will see more of the white box approach that Autopilot takes. Autopilot in GCP is, I believe they just call it AutoML. Okay, I posted kind of the product detail page on Autopilot, and from there you can get to the documentation. Can we nudge Autopilot to pick a particular algorithm? You wouldn't necessarily do that. You would look at what Autopilot finds best, and then you could just choose. So Autopilot's not going to just pick one. In fact, you can configure it to say either I want 3, I want 16, I want 24. But really, the power of Autopilot is to basically factor out human sort of intuition and just let the data shine through, and let Autopilot figure out what is a good algorithm. And you'd be surprised. In most cases, yes, it will return something similar to your intuition because you've been doing this a long time and you have the experience. But there's times when Autopilot finds something that you wouldn't necessarily have thought of. Right now, for full disclosure, Autopilot is, this is its first release was back in December, and there's lots of new features coming into it. There's gonna be lots of like new stuff coming soon. And so right now, not all of these types of feature engineering things are in there, but they are going in very actively. So yes, that is a common ask, and I will send this back to the SageMaker team and ask them to make sure that they address your feature requests here about being able to do feature crossing and all that. Certainly, it's doing hyperparameter tuning, absolutely, based on multiple runs. Yes, it can do grid search, it could do random search, it could do all the different. Okay, so I think we're at 9:20, and I want to give the mic back to Ansha. Ansha, someone's asking, I don't understand how Comprehend knows what dimension to train for. So yeah, Comprehend is one of those higher level AI services. I think someone even asked if it's using BERT. I don't know for sure. I'm pretty sure, and I think it's public anyway, that Kendra, which is another like high level service, is using BERT, like beneath the covers. I could say, from personal experience, the people I've worked with here at like AWS, and then also other customers that are using AWS, there is a lot of BERT. We'll be doing BERT here in a few minutes as well. That'll be like my sections 05, 06, 07. Some people's autopilot finished, that's nice. And okay, a couple errors. I think we might have to just keep moving ahead. Can we find the costs associated with autopilot? One thing, you can go into the Amazon console the same way that you got to the notebook, and you can go to SageMaker, and on the left, you'll see hyperparameter tuning jobs. And that's what autopilot is spinning up. And each of those jobs, I believe, has a quote unquote billing time. So the amount of time that the job is actually being billed for. And then you have to figure out the instance type. Or I think you have to wait, 1 day to look at the actual billing, which we're not going to keep these instances up. So that's very important to mention, by the way. We will be tearing down these accounts at the end of this workshop. All materials are in this GitHub repo for you to reproduce. But we do have to tear these down because there are so many, and we're using quite a lot of resources. So the short answer is I can't give you a specific on autopilot cost. You would have to calculate that based on the runs. Virtual machine, past data. Okay, I think let's keep going, Anja.
All right, let's resume here. So yeah, they're still training. So let's give it some time here. Keep the notebooks open. I suggest they might need like each, I guess, around 15 minutes. So there's really no way to cut it down to a shorter time. Otherwise, you wouldn't have like any benefit from seeing here feeding in the data set, right? We already cut down the data set, but yeah. The job of a data scientist isn't really done in 5 minutes, so let's appreciate that. Let's keep the two notebooks open. You can peek in now and then and see once they're completed. Comprehend is still training, and I see that autopilot now finished the analyzing data, and it's now starting the feature engineering part. So that one means part one is done, and feature engineering is now kicking off. So let's just see.
One other quick thing, and I do want to make clear that autopilot is white box, which differs from Google Cloud and yes, other providers, meaning we actually generate the notebooks and the code that's been used. And so what you could do then is tweak it and change it to only look at certain algorithms, like someone's asking, or tweak it and only explore a couple more hyperparameter tuning settings, right, like hyperparameters. You can also take, so keep in mind that like autopilot is not just finding the best model, it's finding the feature engineering steps that are needed for that model. And when it does that, it's literally creating Python snippets of code. And so for example, TF-IDF, it's you know, it's taking text, it is converting it to the raw TF-IDF. That code is then can be reused inside of your predictions, because you're likely taking in raw text from a mobile phone or web application, and then you have to convert it into TF-IDF or whatever you know, is powering the model. So yes, Autopilot generates not just the best model, but also all of the code that is required to transform the features to get it into a form that can be used by that model. All right, I'll go back on mute.
Yeah, no, thanks. Thanks for adding. Yeah. And we're actually going to see that in just a bit. So my data analysis finished and it's doing feature engineering, so I could run a couple of more cells. We basically split that apart to just track for one, so we can see when the next is starting. So if the one cell is finished, you can see here I went down to feature engineering. So that one is now happening. And once that is done, it starts the model tuning. So now you can see why it's taking a little bit of time. And then what Chris just mentioned, the white box approach that is Autopilot that is doing will generate 2 notebooks. So we will pull them down as soon as the process here is finished. And then there's going to be 1 notebook generated that documents all the stuff that Autopilot has seen in the data exploration phase. And also it shows that code snippets that Chris mentioned in the candidate definition notebook. And you can pull them down and then you can actually execute them or, you know, do changes. So this is really kind of the difference here in Autopilot versus other AutoML systems, that it's really a white box model and it documents everything. And you can take that either as a baseline and then, you know, do your customizations from there, or really use this as a first shot at the best model. All right, so let's give it some time. As I said, it's doing feature engineering, and after that, it's still doing model tuning, so that will run for a little bit. I'm checking on my comprehend. Yeah, this is taking some big steps here, still training. So let's keep those notebooks running for now. They will finish once we're through the next section, then we revisit and see the results. All right, let's move on to Theory of 3 ingest. So with this AutoML chapter, we really wanted to show you some simple ways to get started, right? Some what we called one-click machine learning services. Let's now really do the manual way, right? Let's start from ingesting data into the cloud. And I'm opening up here the 0.0 overview to just give you a kind of a quick introduction here. So in this scenario here, we want to show you some tools you can leverage when you ingest data, how you can actually do also some quick exploration. So chapter 3 and folders 3 and 4 go kind of hand in hand in here. So in 3, in ingest, what we're going to show you is how you can actually use TSV files or CSV files, which we have in our data set right now, and then basically use a service called Amazon Athena to do some interactive SQL queries right on the data that sits in the S3 bucket. And in our case, we do have the TSV files here given from the data set, but this can be also, for example, an application that is writing log data to S3. So anything really that imports data or writes data to your S3 data lake or bucket. So with Athena, you can basically query the data right away in S3. You don't have to worry about, you know, preparing a schema for the data and put it into a database or data warehouse system. If you're interested, I guess for the sake of time for the workshop, I'm not going to talk too much about Redshift. We do have the full notebooks in here, so if you're actually interested, have definitely a look. I'm just going to quickly show it later. So we can also obviously take the TSV file information data and import them into Redshift. Redshift is Amazon's cloud data warehouse solution. And this is basically probably how the business intelligence teams, data analysts, you know, would access data. They probably also just pull in, you know, a fraction, maybe the last 1 year of data. Let's say our customer reviews data, and maybe do some, you know, analysis there, maybe customer review trends, sentiment trends that are more important to like the current business and forecasting. Whereas as a machine learning engineer, data scientist, you would want to have access to, you know, all the 20 years of data that are stored in the data lake, and obviously the raw data to then build models, right? So this is kind of two different approaches. We're showing one way for the typical more machine learning, data science focus on how you would access the data. And also if we have maybe some BI members, data analysts here in the session, they would probably more work with data warehousing. So those are the two ways. Both actually offer similar functionality to query data right away in S3. So also with the data warehouse, you can actually query data straight in S3 without actually moving it, which is really cool. So this is done via a functionality called Redshift Spectrum. So this is really kind of the outline. Here's a little bit more text if you want to read through after the workshop. Let's actually open up the first notebook here, 01. So again, I'm in 03 data ingest, and I'm now starting with the 01 notebook. So first of all, again, we're writing, let me just run the cells here, run all. So first of all, we're pulling down the data set again. And here I'm showing you all of the data files that are available in the public bucket. So as I said, Amazon also provides some multilingual data sets here. So we have German reviews, French, Japanese, from the UK, and then from the US marketplace. We're basically just for this workshop pulling down 2 category files. Otherwise, all of the trainings would take probably times 10. But you can see here all of the categories actually that are available. So from apparel, books, cameras, ebooks, groceries, you name it. So in total, 43 categories. Also, the data set is available in Parquet file format. So Parquet is a column oriented file format optimized really for queries. So especially if you're running SQL queries, you can then do like a work clause and say, select all the reviews given some criteria where the category is digital software, for example, right? So this is really Parquet's power to optimize on a column base. So those are also available. We're just assuming right now, we're working off the plain TSV data. So what we're doing in the first step here, we're pulling down actually 2 categories from this public bucket into our default bucket that we're using here within our VPC. So again, we're setting up the environment here, pulling in the SDKs. We're giving it a path in our S3 buckets where we're going to store the data. And then basically, we're copying the data, as you can see here, recursively into our path. And we're only including here, that's the include 2 categories. We're working with digital software for the rest of the workshop and digital video games, not to kind of overload our examples here with too much data. So 2 categories, and then we're making sure they're pulled down and available. Here is the LS show on the S3 bucket. All right, this was really just copying data to S3. Let's move on and see Athena in action. So as I said, Amazon Athena is an interactive query service, which you can use to run standard SQL queries right on the data that is in S3. And as you will see here in a little bit, it's serverless, so we don't actually have to set up any infrastructure. You don't have to worry whether you need a T2, a C5 instance or anything. It's truly serverless. So we just have to do some basic setup with Athena, and then we can run SQL queries on the data. And for those of you curious, Athena is actually based on Presto. So Presto is an open source distributed SQL query engine, especially designed for that task to run analytics against data of any size. And you don't have to move the data. You can just, query the data where it's stored. So really, really cool setup. Yeah, let me just also run this here. I always start talking. Run all cells and see this in action. So again, we're pulling in the SDKs. We're setting a database name. So we still have to organize everything in kind of a database. So we're just giving it a name. Let's call it DSO AWS. And then to interact with Athena, we're installing PyAthena, which is a Python DB client. So we're pulling in here pip install PyAthena. And then Athena works with connectors and cursors. So we're also pulling in those. And what we need to do here, the only setup we need to do to use Athena is basically create the concept of a database and a table. And this basically stores the meta information. And to store the metadata, Athena needs a data catalog service. And natively, it supports another AWS service, the Glue data catalog. So this is really kind of, you can poke around in the console if you want to. This is kind of cataloging all of our data and can be used across services. So when we're setting up here the environment, we're basically giving it the database name and the table meta information that is going to be stored across the account in this Glue data catalog in the backend. So for now, we just need to set up kind of a temporary directory here where Athena is basically staging the query results. So we're just giving it another path here in the S3 bucket. And then we're starting to fire up the first SQL query. So we're doing a create database and giving it our name. So you can see here, create database, if not exists, DSO AWS. And then we're using this cursor object. And the cursor really first connects to into the region here and sets up this staging directory and gives us a cursor to iterate over the data. So we're setting this up here and then giving it this statement. And then we're doing a show databases next. And as you can see here, the database got created. And I can also in the console, you can just watch here. You don't have to jump around if you like. We can go into Glue, which is the data catalog, if you remember. And this one basically shows us then the database and then in the next step, the tables that get created. So here we are. So let's actually get started and have a look at the databases. And here you can see in the data catalog section that we just created this, this database. There's no tables in there yet, but we've just set up the database information. All right, so let's actually open up the next one and let's create the tables. So let me also run all cells here and then walk you through. All right, so we set up the database. Again, we're pulling in all the information here in preparation. Now we're also setting a table name. So let's just call it Amazon Reviews TSV because we're gonna read and query the data basically in the TSV path. We're pulling in PyAthena here again. And what we're doing now is basically we're creating a table based on our data set. So as a quick recap, those are the data set columns in the reviews data set. And again, we're telling the staging directory. And everyone who is familiar with SQL shouldn't be any surprise here. It's really a standard SQL command. Let me scroll out here to the printed one. So we're doing a create external table. If not exists, we're calling it Amazon Reviews TSV. It's going to be part of the database DSO AWS. And here we're providing it with the data columns from our data set. And we're also saying its row format is delimited. It's a TSV, tab separated file, so terminated by tabs. The lines are terminated by line breaks. And here we're giving it the location. So as you can see here, we're pointing that table to our S3 location where we drop the TSV data. So our SageMaker default bucket and the path we just gave it before when we pulled down the data, Amazon Reviews PDS/TSV. It's also compressed. So we're mentioning it here. It's a gzip compressed. and it can skip the header line. All right, again, we're firing up the command through our cursor object here. That's just the way PyAthena works. And then we're doing a show tables to see if the table got created. And here we go. Table is created. We can do a first sample query. So let's actually see if we can query the data. And now you can see I'm putting in a sample SQL query, select star, the one that everyone is always using for demos, from this table where product category is digital software. Let's limit it to 100. And then we can also pull the cursor result into a pandas data frame. So super convenient, that's what I'm doing here. And then let's have a look. And you can see here, we just ran a SQL query on the TSV data that is still stored in S3 through Athena. Pretty nice. If I go back to Glue, you can see here that now in the database, this table has appeared. And it's exactly that SQL query that we just fired up. It has all of the table's metadata stored here. So which columns and data types. All right, so obviously we're doing everything here from the notebook, but you can definitely also go to Athena here from the console and poke around. For our workshop, we're trying to keep it all in the notebooks, but definitely you can have a look here. So here you should also see our database popping up, and you can see here our table. And you could also do, if you want to, preview table here, and then it's running here. It just says, I think I don't have here the right role or something attached through the UI. Oh no, it's the S3 bucket. I need to give it here the S3 staging location, a bucket as well. But definitely it's running the same command here, right? So let's just not spend time in doing that setup through the UI, but here you could see we're running the query here from the notebook, and it's giving us here the results. All right, that was basically the Athena setup. Let's have a quick look here, 04. A nice thing, let's assume we would not have the Parquet data available. So you can also basically use Athena to convert data from one format to the other. Let's say we want to read that TSV data, but we actually want to convert it to Parquet. So let me run those cells in here quick. So again, we're setting up everything as before. I'm now creating another table name called Parquet, Amazon Reviews Parquet. And I'm going to show you how you can actually also leverage Athena to create those Parquet files. So again, pulling in PyAthena here, staging directory. And let me show you this command. So what I'm doing now is also a create table command, if not exists, for my Parquet data. And I'm telling it with format Parquet from the external location here, partitioned by, and I'm telling it how it should partition. I'm telling it to partition by product category, as I think those will be the most queries later on. And then I'm also, again, telling here the columns. And I'm also doing a little bit of casting here. So we had a review date of our reviews, but we didn't have the actual year. So I'm actually also transforming the review date and casting out the year, and then saving the year here as an integer and storing it in an extra new column called year. So I can also do some fancy SQL manipulation right here. But basically that's a create table statement here, create table as statement, which is pretty powerful. And then we're running the command. And then one thing we have to do is load the partitions. And this is done through this msck repair table command. So we're just running that command that loads the partitions. And then I'm running a SQL show partitions here. And as you can see here, we just had the two product categories pulled in, but it basically converted the TSV data into Parquet, and it's now available in a separate table we could query. So now I could also use Athena again to do a select star from the parquet table where product category equals, and it's pulling us, giving us the information again. So if we're running this on a really large data set, you would notice that this query is even faster because it's column optimized in Parquet. All right, so this was a little bit of fun with Athena. Let's maybe have a quick look. I'm just going to look quickly on my autopilot. So the feature engineering finished. Let me have a look. Model training and tuning finished in the meantime. So I'm just running those commands here in the autopilot one. You can do this now or later as you like. Just want to make sure I kick off the deploy model as a REST endpoint. This takes a little bit of extra time again. So I'm going to make sure that I kick this off. But actually, let's have a quick look here what happened. So in the meantime here, back in autopilot, the training, the feature engineering stopped. It did run a model tuning, a hyperparameter tuning afterwards to find the best settings. And it generated those two notebooks, and we should actually be able to see them if I go back here in the 02 folder. Let me see where we're pulling them down. Have we copied them in already?
I think they have to be copied. Not sure if they were, it's copied in the next step there, I think.
Notebooks. Yeah, let me see where they ended up. I copied them somewhere, I think here.
Oh, yeah. Where did they go?
Let me refresh here. They ended up somewhere.
Can you run those again? The 13.
Yeah, maybe I was too quick here. Yeah, now it's like deploying. Okay, I'll revisit. We have them somewhere. I have to check where I saved them here.
They're under O2 AutoML notebooks. Okay.
Yeah, we will find them. So what you can definitely do here, so that command actually should pull them down. I have to check where they ended up. So we can run a command here to actually view the candidates. So you have the names here, the tuning jobs that took place, and you also see the objective metric. So in this case, we could optimize for 40% accuracy. So it's not the best, but then again, we really use kind of, only a few training steps here and a small data set. But still, for a first quick and dirty run, not too bad. We can also sneak in. So there's actually some analytics, experiment analytics capabilities. So you can also have a look here in the different trial runs that happen. So you can list them here. This is what we're printing here. So you can see 3 tuning jobs that took place. Those DPP are actually this data pre-processing that took place before. So you can sneak in here. And yeah, a lot of things that happened. You also see here, for example, which instance types autopilot used. So it used the ML-M5, 4x or 3x large. So yeah, you can peek in here and see what happened. And what I'm doing now, and that is running as a next step. So for the best candidate that we found, actually give us the information. This is the name, validation accuracy, 40%, the description. And what I've done now here is basically deploy. And when we deploy, it's actually using a concept of an inference pipeline. And this means that it's also deploying a couple of containers, as you can see here, that is not only the model, but also a container that does the data pre-processing that is needed, which it learned from the autopilot job overall. So it's kind of an inference pipeline that gets set up. So when live data comes in, the data gets pre-processed and then given to the model and then returned with the predictions. So in this case, actually, yeah, autopilot shows XGBoost. I think we can see it here if we look in the containers. Yeah, here you can see XGBoost. So that one was the best candidate. So I've kicked off here the rest of the cells, and basically we're deploying the model now as a REST endpoint. This will probably take a couple of minutes here as well, and then we can run a prediction and see how the autopilot model performs. Let me have a look here at comprehend. That should be finished now, hopefully. Let me see, is the cell finished? Nope, comprehend is still training, okay. Comprehend must be really, really good accuracy afterwards.
Yeah, a couple people asking about break time. Maybe, how far did we get in the 04?
So I've done the Athena with the data ingest. I haven't run yet. I can run a sample visualization notebook, and then you can probably take over.
Yeah, so let's do that, and then I'll start the data, the DQ stuff. Yeah, the data quality,
Okay.
and then we'll take a break. Perfect.
So, all right, just not to confuse here everyone, because we're jumping a little bit across the notebooks. So in between, feel free to sneak into your autopilot and comprehend notebooks and see if the cells that we're executing finished. But basically what I've just shown you in the meantime here was how you can ingest data into the cloud. Because we have so much content today to cover, I won't show all the way to set up Redshift and do the same thing with Redshift. But you can go into, let me go back here in the Theora 3. We do have a couple of more notebooks here, how you can set up Redshift and also ingest data and query in Redshift with this service called, or functionality called Redshift Spectrum. So feel free, if that's the part that's really exciting for you, to have a look at those notebooks. For the sake of time, because we have so much really, really good things to come, I'll just going to show you the Athena one, as I guess most of you will probably come from the data science machine learning space. And what I want to show next in the Explore, so I'm going to go for 04 Explore here, is how you can visualize. And we're just going to visualize a couple of fun facts. And then Chris takes over for data pre-processing and then training the models. So again, for the Explore data, I will pretty much limit it to the Athena queries and visualizations right now. And then later on, Chris will take over for the pre-processing, showing some Spark in action. So let's open the 01 visualize reviews. So let's actually, again, here's a quick recap of the data set, pull in a couple of libraries. So in here, I'm actually pulling in pandas, numpy, matplotlib, seaborn, and PyAthena again. So those are all libraries basically to do data manipulation and visualization. So working with numpy a lot. So setting up the environment here, my PyAthena, that's what I use to do the queries. Also, I'm setting up seaborn. That's basically really for the visualization. So which layout, font style, figure size, etc. So I just pull those in as kind of a overall settings. And then I'm also having a little bit of a helper code here to plot some values on a bar plot here later on. So let's actually have some fun, and let's look into our data set. So let's first do a query, which product categories are the highest rated when we look at an average rating. So I'm doing the SQL query here, if anyone is interested, as they get more complex later on. So that's the SQL query I'm firing up. I'm also showing the output here in the data frame. So we calculated now the average star rating per category. And in our case, it's just the two. So you see digital video games had an average star rating of 3.8, digital software 3.5. We have two categories, not surprising. And let's actually visualize that. And this shows up first really, really big. You just have, I don't know why, run this a second time. Then it's showing up a little bit nicer. It's just one of the weird visualization things with Jupyter sometimes. So basically, we're kind of creating a bar plot here. I'm doing a little bit of some logic here, because if we're pulling in the whole data set, it looks very different, which I'll show you in a bit, setting the labels here. So it's just an easy way, to plot the average star rating. And if you're interested how that looks, if you're pulling in the whole data set, so I've added just a graphic here. I ran this yesterday on the whole data set, so across all the 43 categories and 150 million reviews. And this is how this chart looks like for all the categories. So you can see here, overall, gift cards actually have the highest rating, 4.7 stars. So nothing wrong with gift cards, right? I think everyone is happy to receive them. And the least valued category is actually digital software, 3.5. Kind of fun thing to see. All right, let's do the next one here. Just really to have a couple of little bit fun with the data set. Which product categories have the most reviews? So here we're just doing really a count on the star rating, and video games has 145,000, digital software a little bit more than 100,000. Let's also visualize, not giving away too much here. So we can see here the two charts again. And again, if you're interested in seeing across the whole categories, here's the output from my queries yesterday. So actually the books category has like close to 20 million reviews in the data set. And you can see here the huge imbalance of data, right? Books actually followed by ebook, Kindle book reviews, pretty close. And then it's dropping dramatically, right? And I mean, this can be explained as, Amazon.com started out to be an online bookstore. So obviously collecting reviews since 1995 over time, books just, still have the most reviews in here, but followed closely with the ebooks, which, I don't know when they got introduced in which year, but we might have a query for that later on. And the rest, personal care appliances, really few. Major appliances, digital software, again, just around 100,000 reviews here. So kind of a fun thing to see. All right, I'm just executing the next one here. So when did each product category become available? So that was the question really, right? Is it related because nobody wants to rate those categories, that we just have maybe a low number of reviews? Or is it just because it recently got introduced? And we thought, well, we might have a first indication when we pull for the first review per category, right? So that's kind of probably roundabout when it got introduced, plus minus a couple of weeks. So let's actually do a query here and select the earliest review per category. And you see here, for the digital video games, the first review came in 2006. And for digital software, the first review came in 2008. So we could roughly assume the categories got introduced around that time. So we're actually slicing, dicing the data here a little bit, pulling out the year so we can visualize that. And what we can do here is basically calculate the number of first reviews per year to see how many categories got introduced in which year. And in this case, it's just, two categories, and one got introduced in 2006, one in 2008. So the graphic is not super exciting. But again, if you want to see how this looks for the whole data set, we can actually see a spike here. So in 2000, what is it now? Actually, in 1999, we had 13 first customer reviews. So roundabout, I assume this equals to 13 product categories being added in that year. So kind of a fun chart to see, and actually no new category was added since 2010, at least in this data set. This is really just, input and data insights given by this data set. So not a general statement here, but kind of fun to poke around in this data set. So what else can we do? What is the breakdown of ratings per product category? And we're actually building up a pretty complex chart here. If we do have some experts in Matplotlib and you find easier ways to do, feel free to share with me. I actually wanted to pull in the category, the star ratings, count the reviews, and I want to do kind of a stacked percentage horizontal bar plotting. And I figured out this takes a little bit of pre-processing here of my pandas data frame. So first of all, I'm getting the count reviews per star, per category. So this is what you see here. So how many 5-star, how many 4 stars, etc. And then I'm grouping a little bit crazy here. I'm building distributions. Again, a little bit crazy here. And then I'm building an array across all stars. So I'm actually stacking them. And then what I want to build is basically this visualization. And here again is the visualization for all categories. And it's just a nice way to visualize how many, percentage the 5-star ratings have, the 4-star ratings, and also colored from green to red here. Gift cards, again, were the highest rated. And you can see here, digital software still has around probably 44% here of 5 stars, but yeah, big portion of red, of 1-star ratings. For our little data set here, the graphic looks like this. All right, yeah, this was a heavy visualization here. The next ones are a little bit easier. So how many reviews per star rating? So we're just doing a count here. And the results across all categories. So the majority of ratings overall given the majority really has 9-star ratings, followed by 4, and then followed by 1, as we saw before already. How did star ratings change over time? So let's run this, if there's a trend. So I'm actually generating the average rating per year across all of the categories we have. So in this example, we only have the 2 categories, so it's across a subset. But you can see the average star rating in 2008 dropped dramatically from like 4 to, what is it, 3, probably 3, no, 2.5 right here, and went up and then kind of, yeah, stayed straight here. But those are kind of 2 low rated categories. So if we're running this across all categories over time, the curve, the line looks like this. So again, it went down overall from 4.6 to 4.0 maybe in 2004, improved a little bit, went down and kept climbing again. So those could be really cool business insights for you to visualize. And let's see the average star rating per product category across time. And if you run this, yeah, so you can plot like the 2 per category now. So the 2 categories we have. So you see like the average was influenced by digital video games, which dropped dramatically. So there must have been something happening there. And if we visualize that across all categories, that's a super crazy chart here, but probably kind of fun to see. So there's a mainstream of categories all doing okay. And then there's a couple of categories that really dropped. So if I were the business, obviously this would be an indicator for me to really dive deep. If it's right now, I don't know if this is, just a data set bias here that we have, or if it's like the real deal, real business impact that actually something happened. Could be just in our case here, some data set bias. All right, which star ratings are the most helpful? Just going quickly through here, running a couple of more visualizations. So the helpfulness of star ratings, many people said a 1-star rating is super helpful. probably given, you know, a warning that the product might not be exactly what it promises to be. And then across all categories, it's a similar. So many people say, yeah, the 1-star rating gives me actually a good information. It's helpful. And then which products have the most helpful reviews and how long? So you can actually also just pull it, you know, into a data frame and actually look in the output here. So TurboTax, yeah, this data is definitely collected from since 1995, I guess. It's been some time. SimCity, wow. So some of you might recall those. So here we can see the helpful votes, star rating 1. Ooh, that's tough on SimCity. And the review body length, so if you want to see if that has an implication. And also you can have a substring here if you want to see what happened. And if you're running this across all categories, by the way, the most helpful votes had a Kindle review. Actually here with a 5-star rating. So overall, it's not just the 1-star ratings that get the most helpful reviews. The kind of interesting to see. You can do some ratios here, like what's the ratio from positive, let's say 5.4 to negative reviews. And yeah, that's kind of a also like big difference from across all categories in our 2 categories, but yeah, they're in general pretty low rated. So that explains. And then you can, as a fun last exercise, do actually try to see if some customers are kind of abusing the review system. And we're kind of trying to figure that out by looking at which reviews have been repeatedly reviewed by the same customer. So same customer, same product, and more than 1 review. So why would you rate the same product like, you know, maybe 2 times, but it's definitely suspicious if it's 100 times. So if we're looking at our data set, we can see here that the customer with this ID reviewed Call of Duty Black Ops 2 10 times, and it's still giving a 5.0. So that's a hardcore fan of Call of Duty, apparently. After playing it 10 times, still giving it a 5. Not so sure about that Sims fan here. If we run this across all categories, this is even more exciting. You can see here that 1 customer reviewed Pearl Harbor 130 times. And I must admit, I watched Pearl Harbor, I guess, personally, I think probably 6 times, you know, including movie theater and TV, but I mean, 130 times. And still giving a review of 4.2, that's quite impressive. And also another customer reviewed Shania Twain live in Chicago 110 times, also giving still a 5. So it's kind of a fun thing to see what happens here with your data set. But yeah, that's just a quick run through here, a little bit of fun to visualize and how to, you know, see how to run those SQL queries using Athena on our data set. If you're running this maybe afterwards on the full data set, feel free. There's quite some good surprises in there. All right. And with that, I would keep it here for the visualization. I have another notebook here that does similar things using Redshift. So if you're setting up Redshift in the Theora 3 notebook, that needs to pre-run, and then you can also execute those visualizations. So if you want to see how to do that, feel free to peek in there after the workshop or in the breaks. For now, I would stop here and give actually Chris some time. Let's just see quickly if Comprehend is now happy. Comprehend has now trained. So I can kick off here the rest of the Comprehend. We also need to deploy. I think that hasn't been done. You can pull the confusion metrics here. Yeah, so you see the outcome from the Comprehend training here, the confusion metrics. And I'm also going to deploy the endpoint. It's going to take a little bit of time, but we can revisit maybe after lunch and fire up some responses here. And with that, endpoint creating, yeah, that is in creation. So with that, I would hand over to Chris, and maybe we want to do a quick 10-minute break for everyone. I think we kind of went through a lot of content right now quickly. Shall we do a 10-minute break? And then I'm handing over to Chris, who will start with the analyzing data quality process, introducing the SageMaker processing jobs here.
Yeah, so I'll just explain this real quick, and then we will take a break, because this actually does take 5 or 10 minutes to run. So I know it's definitely time for a break. And also, we should go over those generated notebooks also. So we'll do that after the break as well too. Let me grab the screen share. Okay, go back to, I have a million tabs open here. I've been answering questions. Okay, I think this is the, okay, hopefully you can see my screen there. So we're still under Explore. So Ansha went through Visualize, Explore. Let's click on this one. So really what this is about data quality. And this is one thing that can make or break your data science projects. I've seen many projects fizzle away and people get frustrated with AI and frustrated with machine learning, when really the core issue is data quality, and really, trying to get a handle on this. This is something at Netflix. Back when I was there, we spent a lot of time dealing with, of course, Databricks when we were onboarding customers. They'd get frustrated with our product, and then we would work with them to unblock and to clean up their data so that then we can then analyze it with Spark. So this is actually based on Spark. We are surfacing a Amazon open source project that is not very well known, but is actually used throughout Autopilot. It's used later on during model monitoring for when we deploy models. And so this project is called DQ. Let me zoom in here. DEEQU. You can, if you click through that, you'll see the open source. There's also this really good blog post that described it. Now, this is one of those subtle projects that I had never heard of before joining Amazon, and it totally fits many use cases. And the reason, and so there's professional services people that are using this. There's also within our own products, within SageMaker products, are using it. So the idea is we can continuously analyze the quality of our data. If we had something like this at Netflix back when I was there, this would have been a complete game changer. Instead, we were really doing this by hand. We were building the streaming product at the time. This was 2010, and we were always, so we were logging things about the streams, about the stream quality, about these devices, about what's going on, and we were constantly throwing off the downstream data science teams and BI teams, business intelligence teams, by messing up their data and logging it nulls and changing types from string or from floats to strings and all kinds of stuff. So with something like DQ, and we're actually going to deploy this with Spark, and also we're going to introduce something called a SageMaker processing job. SageMaker processing jobs were actually announced just a couple months ago at the 2019 reInvent. They're used heavily within the product itself, and of course Amazon tends to do this. This is where Kinesis came from, right? Amazon was using Kinesis sort of internally and then decided to make it a service and then offer it to the public. So SageMaker processing jobs are pretty lightweight. You can just do simple scikit-learn Python scripts and just do simple feature transformations. Or you could actually set up an entire Spark cluster and then tear it down in sort of a serverless manner, where you're only paying for just the Spark job that you are running. And so that's exactly what we'll do here. So DQ uses Spark beneath the covers. We've got the latest Spark 2.4.5 installed. And let's just give it a run here. So let's do a run all. That's going to run all these cells. These bottom ones will error out. This is one of those cases where I just do this in documentation. I say, please wait until this processing job completes. So if you do a run all like I just did, these bottom 4 or 5 will all fail. This is what we'll do. We'll go take a break and then come back and then look. But really, let me see if let me just kind of highlight what's going on here. So you can actually basically do anything with Spark processing jobs. I just happen to have a sample Spark Docker container here. So of course you would build this one time. This has Spark installed 2.45. It's got Hadoop here. Yeah. So don't get confused by Hadoop. This is using Spark. It's just that Spark uses a lot of Hadoop libraries because Spark builds upon Hadoop. And just building this Docker image, you just do this once, pull in those libraries, and then from there we can run our job. So we're doing some ECR. This is Elastic Container Registry. Don't really worry too much about this. All this is, this is like Docker Hub, but it's a private Docker Hub for your specific like Amazon account. So just showing that this thing gets built. Here's the actual file. Not quite sure what's going on here. Something got stuck. This finished building. Maybe it's not done building. Still building. But once this builds, we'll actually show the code here. Note that DQ right now only supports Scala. We are working with the team here at Amazon to, they have already started working on the Python version of DQ, and hopefully that will be released here soon. But this is really just doing a quick adapter between PySpark and then Scala Spark. And when this Docker image is done building, we'll see it. Actually, I could pull up the code here. Let me just go in here. If you are familiar with Scala, if not, don't worry about it. I don't use much Scala anymore, which is why I was pushing for them to release the PySpark version. But really, this is our schema, the same exact schema that Ansha was showing you during the analysis phase. What we're doing is just setting up constraints. So the use case here is there's new data coming into our system all the time. Me as a former Netflix engineer, I was always adding new things to the logs, right? So, or we were always getting more and more user data, right? Like more clicks, more streams watched. And I wanted to make sure that my data, before I even start running my machine learning jobs, that data was relatively clean or relatively what I expected. And so, so constraints, you could say, make sure there's a particular correlation. If we see some strange correlation between total votes and star rating, then something's wrong. So there's some pretty advanced sort of statistical analytics that you can apply. You could do these approximate count distincts that are similar to just a regular count distinct, but they're a little bit faster. You can look at the mean star rating. And if there's any sort of, if there's things that you're not expecting, this particular Spark job will identify it. So we have it in here as part of the pipeline because before you even start training, which we're going to do in the next couple of sections, after the break, you want to just check, is my minimum star rating 1.0? Is my maximum 5.0? If all of a sudden I start getting star ratings of 6 and 10 and 12, well, I don't even want to start my model training. This means there's an upstream data issue. Right now we have 200,000 rows. When we turn this on the full data set, this is actually 150 million. If all of a sudden the size of my data set drops down to 5,000, something's wrong. Maybe my query didn't finish. Maybe there was something going on. If all of a sudden I start seeing these reviews showing up in different marketplaces that I was not expecting, this is something I want to know early. So all of this is just setting up a Spark job. Again, there will be a PySpark version of this, very, very heavily requested. Okay, so let me bounce back and see. I'm going to stop this and restart, clear the output. I'm just going to run it again and see if it'll come back here. Okay, so do a run all there and let's take a quick break. I will answer questions. Just know when we come back from break, we'll take a look at this. We'll take a look at the generated Jupyter notebooks and all of the results of all of this. And hopefully our data quality is good. It should be because we've been really cleaning it and we're in full control of it right now. But as new data comes in the future, we want to constantly run this particular analysis and raise any flags. And like we could actually stop the pipeline, send an SNS notification, get a like data engineer on the line or a data scientist on the line and figure out what's going on with our pipeline. So with that, I'm going to put it on mute here and see it's 10:20. Let's come back at, let's say 10:40 PT. And we'll see you in a bit. Please run this O3 and we'll answer questions as well. So see you in about 20 minutes. Thanks. Okay, we're back. Saw a couple of people had some errors, so I want to clear some things up here. And actually, my DQ job failed because I forgot. I jumped into this. I was answering questions and forgot to actually copy the data. So I have not been following the previous notebooks. So mine failed because I had no data, and I found that by tracking down, looking at the CloudWatch logs. So in this analysis, the data quality processing job, you can click and look at logs and output data, and that'll and keep, rerun this cell right here, and this will tell you if it failed or succeeded. Mine failed because I didn't actually have the data in the bucket that I told it. And then uh, not until this succeeds, this stuff will not work, which is why this says, please wait until the processing job completes above before continuing. Then these will work. So if you're seeing the errors about no objects to concatenate, either something failed up above, which it shouldn't for you guys if you actually copied the data and ran the previous things. So, oh, let me resume. Okay. So yeah, this particular job, so this is the DQ Spark job. If you keep running this particular cell, so mine failed, yours either says in progress or should have completed. Mine failed because I forgot to copy the data. I didn't run the previous notebooks. I was answering questions. And then if you don't see any data here, then these won't work. So you have to wait until the data is complete. So I'm actually backing up and copying all the data over. Okay, so let me run through these. I haven't even set up Athena yet, so let me run through that. By the way, lots of questions on when to use Athena, when to use Redshift. Always use Redshift for data warehouse type stuff, for BI use cases, business intelligence use cases, for reporting. Use Athena wherever you would use Spark, basically. That's not exactly true. You still may need to use Spark, but with Athena, it's based on Presto. Presto is very, very high memory, will like utilize memory. People think Spark is the in-memory processing engine. That's actually not quite true. It's more memory utilization than the previous generation, Hadoop, but a purely completely optimized for memory solution is Presto, and that's what Athena is based on. What that gives you is really, really, really fast queries. But now these are typically meant to be ad hoc queries. So Spark actually does do quite a bit of writing data to disk. It can recover from failures if a node dies. With Athena, you aren't quite given that guarantee. So stick with Athena, not for anything super critical like a hourly dashboard or minutely dashboard. Use Athena when you're exploring data, when you need to move data, when you need to convert it from TSV into Parquet. Sort of data engineering type tasks. It's a really, really good tool. I remember at Netflix, we were using Hadoop, we were using Hive, and then we actually switched over to use Presto. And we were using Presto for a very long time, even before Spark got popular. So Presto really, really was fitting our needs. There's still quite a bit of Spark at Netflix these days, but you could get very, very far with Athena. And then, so like with Athena also, it's serverless, and it's managed. So you don't even have to worry about instance types. If you execute a really large query behind the scenes, it'll scale up. And then scale down, and you will only pay for what you use. So let me just keep running through here because I realize I'm not going to get very far if I don't run these. Okay, convert S3. And I'm waiting for autopilot to complete. I might be able to look at, let me actually stop this current thing and I can try to pull down. Okay, so I just pulled down the generated resources, so I have enough. I'll take this part, Ansha. Let me go back to here. I don't think I have to set up Redshift, so I'm going to hold off on that. AutoML, you should now see two new folders here, generated module and then notebooks. So let's start with notebooks. Okay, so stepping back here, and actually let me rerun this analysis while I'm doing this. So for the sake of time, we have to keep moving forward and then backing up to things that complete. This is just the nature of big data processing. This is, this isn't as interactive, sort of real-time interactive as like we would like. It's just the state of where things are at. So I'm going to wait. So I've just restarted my analysis job. I should have the data where it needs to be. And I'm just going to keep hitting refresh here when we come back. And when this says complete, then you can actually look at the quality. So let's back up here. So, okay, 2 notebooks get generated. So there's like lots of other Python scripts that get generated, but there's 2 notebooks that you want to pay attention to. The first one is the sort of data summary. So we pointed Autopilot at let's see, it looks like 34,000 rows of data. We pruned it so that we only passed in the text and the star rating. So, and so this has all been dynamically generated, by the way. This is the white box part of Autopilot. So this data set has 2 columns. The first one was the review body. The second is a categorical, and this is star rating. So there's 5 categories, 1, 2, 3, 4, 5. We're not treating this like a regression problem. So because our data is not really regression type data. We have 5 categories. Just because those categories are numeric shouldn't matter, right? These are 5 categories. These are discrete values. These aren't 1.2, 3.9, 4.1. The user can only select 1, 2, 3, 4, or 5. When we do summary statistics and look at correlations and like averages and like standard deviations, those end up being 3.5 or 4.7, right? And those end up being continuous or float values. But here it's just 5 categories. So this is called multi-class classification, which is different than multi-label classification. So I can talk about that at some point. But multi-class classification means there is more than just 2 classes. If you have binary classification, it'll either be one or the other, either a 0 typically or a 1, like yes or a no, true or false, on or off. Multi-class, we have more than 2, and so Autopilot detects this, and then Autopilot can see, and it's kind of showing some 10 sample rows here. Just ignore that first column is really like a pandas kind of internal index number. The second column is the star rating. Third column is the actual text. And the star rating is what we specify as the target column. So target column means something to Autopilot. You have to specify it when you tell Autopilot, when you tell Autopilot about your data set. You have to give it the S3 bucket that has this data set and which column is the target column. This also means that this data set has to have a header. Okay, and so this is all Autopilot. This analyzed, it actually looked at the % of missing values. Could do some other statistics here. It can tell you, things that you should keep an eye on. Descriptive statistics. So of the values that it saw, it found the mean to be 3.0. Okay, so this view, like this notebook, becomes really, really interesting, super interesting, when you give it more columns. We kept it simple and just gave it so that we can compare apples to apples with comprehend and with BERT and things later. But for right now, yeah, this is the case here. So it's just these 2 values. Let's go look at the other notebook. Here's the really interesting one. This is the candidate definition notebook. So, so again, this recognized that this is multi-class classification. It's using star rating as the target column, and there's a total potential of 5 classes. And this is an actual notebook that is runnable, by the way. You can run it, you could change values, you could change the knobs. So if you wanted to read here, but here it says the data set has been randomly split into training and validation. So you didn't even have to split this data. Yes, AutoML does it for you. Yes, Autopilot does it for you. This detected and chose these particular versions of Jupyter. It's pinning things. This is always good to see that it's actually pinning these to specific Python SDKs. If you don't pin these dependencies, you will have nightmares later. So always, 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 don't just put a naked like pip install. You will have problems. So here, pip install v1.43.4, things like that. Okay, and let's see. This is just so that you could rerun this notebook, but I'm going to just quickly show the highlights here. And so keep in mind that, yes, Autopilot has been designed to generate pipelines. And so you'll see this word pipeline. Most of us think in terms of just a model, but really a model is useless unless you can transform the data into the format that's needed by that model, both during training and during prediction. So all of the things that SageMaker generates are pipelines, even down to the inference pipelines that like Ansha mentioned earlier, right? We asked to keep things somewhat simple and relatively fast. We asked Autopilot to only generate 3 candidate pipelines. Okay, and so here's, I think the 3 it chose, in this case, it actually chose XGBoost for all 3. If we did more than 3, we would see linear regression, so we would see logistic regression. Yeah, we'd see other variants here. So this also shows it's using TF-IDF. I'm not going to get too much into the details of TF-IDF, but just know that when you see TF-IDF, term frequency, inverse document frequency, it's taking raw text and it's converting it into some vector space. It's creating this vector space and it's basically taking words and converting them to numbers. These machine learning algorithms need numbers. It's doing some scaling, always a good idea to scale just to kind of squash any outliers or any dominating features. So in all 3 cases, it chose XGBoost, it chose TF-IDF, and the first one, it did not choose PCA. The second one, it did choose PCA. PCA is principal components. It's finding the top most representative features that help contribute to the learning of this data set. Okay, so yeah, you could dive into like PCA and see what's going on there. XGBoost, and also keep in mind, so one hyperparameter basically is the model type. A second hyperparameter is what are the actual hyperparameters for this model. So we could show that here in a bit though, but for right now, just know that it's chosen XGBoost, it's chosen PCA, and I believe 1 or 2 of these, and then we can drill in to look at the specific hyperparameters that it chose here. We'll actually see it in the code. We see here, num class is 5. This should look familiar if you've done any XGBoost hyperparameter tuning. This is the hyperparameter ranges that were explored. And again, this is based on empirical experience, by the Amazon team, by jobs that like we run internally. Yeah, but obviously each data set is different. And what we've gotten lots of questions for today and from customers is, how do I actually hint and change what's explored? Well, one thing you could do is go in here and say, I want to go from 8 to 128. So like you could physically override it once these have been generated. Oh, and yeah, I should also mention, you can generate these and not even run the AutoML job. So like said differently, you don't even have to do AutoML to get to see what like AutoML thinks it should run. So this would be totally free. You would pay no money for this. It'll just look at your data set and then generate these. And then you could take these, and if you wanted to, you could go to Google Cloud and then run these. Yes, I wouldn't recommend it. I shouldn't really like highlight that. But that's the coolness about the white box approach here, right? That's the flexibility. Yes, obviously, we would love for you to run these jobs, on our clusters. But just know that like this code is yours, and you could have paid no money for this. We did them at the same time. We actually generated these, and we ran the jobs as well. So if you wanted to override these, you certainly can. We'll talk about hyperparameter tuning here in probably about 30 minutes or so, maybe 45 minutes. And so this has all been generated. Here it's telling you which strategies it is using Bayesian and then random search, saying what's the objective. Oh, and so you could change this. I could say I want to use random search. And instead of maximizing accuracy, I actually want to minimize loss or something else. Okay. Max jobs 250. This is why it actually takes so long. We could have actually just changed this to 10. I thought I might have done that, but apparently I didn't. But if you like only just wanted to run 5 jobs and then only do, let's say this is kind of what I was saying before. We have 3 jobs, or we have 3 jobs in parallel and 2 runs. That would work really well with the Bayesian. But this is nice. This is all built for you. All this code's been tested. It all runs. Like you're not going to get any, compiler interpreter errors. Okay, so I think I'll probably skip all this. It handles some of the role stuff for you. And then here's how to actually deploy this pipeline. So again, we're deploying a pipeline. We're not just deploying the model that was trained. We're actually deploying the feature engineering steps that were found to be the best for the model or for the particular algorithm that was chosen. So PCA was here in some, it's not in the others. So let me crack open, I think it was, let's see, generated module has the, so those are the 3 runs, DPP0, DPP2. You can click, let's pick the DPP1. I think this was the one that had PCA in it. Yeah, it's right here. So this is the actual code. You could take this code, you could run it on your local laptop, run it anywhere. If you had more columns that you had told like AutoML about, it would have them here. And it's, so these are hyperparameters that were chosen. This is specific to TF-IDF. Maximum document frequency, minimum document frequency, type of like analyzer. And it's building just a regular scikit-learn pipeline. And if you're not familiar with scikit-learn pipelines, these are actually the basis of the Spark pipelines. I remember being at Databricks when we were trying to figure out how to, or which API to use for Spark pipelines, Spark ML pipelines. And we went back and forth, and it became very clear talking with customers that they're used to using scikit-learn and they want scikit-learn semantics. So now there's a Spark ML pipeline, and it follows the same kind of like naming and design as scikit-learn. So pipelines just let you concatenate steps and makes it really easy. Take the output of one, pass it into the other. This is another hyperparameter tuner. Or this is, yeah, so this is another hyperparameter, which is number of components. So give me the top 5 most like sort of influential features here. So this is going to look different from DPP0 between DPP1, 0, and so these are slightly different values here. This is using a word analyzer, not a character analyzer. And so right now, text, yes, I have to be fully like honest. My experience doing text with AutoML, with like Autopilot, it's not really the best right now for text. And this is well known, yeah, this is not a secret, but right now, AutoML does really well with categorical and like numeric, sort of tabular type of data sets, like an Excel spreadsheet kind of thing. With text, this is getting better. I don't have any dates or anything as to when this is going to get better, but just know that we are hearing from customers that they do want to use AutoML, that they do want to use WordDevec, they do want to use BERT. This is all going into the roadmap. We're listening, and certainly this stuff will be coming out soon. Okay, so here is the labels. 1, 2, 3, 4, 5. So this code, this DPP2 or DPP0 or 1, whichever you choose, can be pulled into your own custom code. So someone was asking, can I pull this into my own application? If I have a C++ app or like a Java app, sure, just you'll have to get over the like language differences, or just take what's happening here conceptually and import it into your Java code. But if you do have current Python code, you just pull it in as a library, and you're good to go. So this is the white box stuff. We plan to go very deep into this in the book. We don't have that kind of material prepared for today. I think it's a little too much depth for this section for this early, but we will dive into all that's happening with autopilot and certainly keep the book updated on the newer algorithms that are being supported. All right, I'm sure that probably generated a lot more questions than answers, so I will circle back later. So let me just take a quick peek here. The analyze. So let me check our progress. So progress here is completed. So this is back to the data quality. These are the files that were generated from Spark. You'll see the familiar part files. Part files are kind of a like Hadoop legacy thing that Spark has to support because Spark supports those kind of workloads. So here, all of our constraints that we set up have passed. So here's a reminder, the constraint, we were looking to make sure it was more than 200,000. I could probably pull these up side by side. Get back to Explore. So these constraints here, for example, if I do it side by side, we'll see constraint is greater than 200,000, yes. Is the minimum 1.0? Yes, successful. If there were any failures, yeah, in fact, last night, me and Ansha were like preparing for this. We actually hit a failure and found an error with our data. We went and fixed it upstream, changed the constraint to make sure everything matched, and now we're passing 100% here. But this is where we'll see continuously, as new data is coming in, we will constantly be checking. And if there's any new things, we will not be surprised downstream. So really nice to have. Some people, I think the blog post even calls this like unit tests for your data. So yeah, kind of fun way to look at it. The other sort of lesser known feature about DQ, and this is used internally, not just within Amazon, but also as part of SageMaker. So when you go to deploy a model, which I'll touch on, that's section 08, I think. I'll just talk about it, but not actually do it. You can set up what's called baselines and constantly be checking, if your model starts to degrade, we will check and can notify you. And that's all implemented like using DQ. And it's like literally running Spark jobs in the background on your behalf and constantly checking this, it's checking your like predictions. So we're, basically we can tap in and sample your predictions. Of course, like this is with your permission. This is you setting it up. This is you checking the box to do it. And we will then like monitor those predictions. And if there are any anomalies, we will then notify you. And that like anomaly detection is happening with DQ on a Spark, on sort of a serverless Spark cluster that's like totally hidden from you behind a service. But yeah, this is what we're doing. So I thought it was really cool to bring this to the surface of something I didn't realize was happening. And yeah, I always like to kind of go like one level deeper and see what's really happening. So one very interesting part of DQ, besides just the unit test part of it, is we can actually suggest based on what on the data that we've seen. Like we'll say, we think you should have a check to make sure that the review ID is not null. And oh, by the way, here's the Scala code. Of course, this will be Python code when they release the PySpark version or the like Python version. But I could like literally take this exact code and put it over here if I copied and pasted properly. Boom. And now I have a check. Looks like they're missing the beginning. And so now I'm checking for is this review ID not null? Because when like DQ ran and like analyzed all of our data, it noticed that this review ID was not null. And that's probably something that we should, like constantly be checking. Something like more interesting is maybe customer ID is not negative. If we do see negative customer ID, there's likely an upstream application bug. You could also do more advanced things here. Make sure product category is within this big list of product categories that we currently know about. Make sure that the review body has less than 1% missing values. That's currently what it is. If it goes above 1%, we would want to be notified. This also realized that Vine is only yes or no, or yeah, actually no for most cases. And verify purchase, yeah, this is either yes or no. So I could literally take this code and copy it over there. All right, so let's see. So that explains that, or demonstrates that anyway. Let me go back to here. All right, so we finished off 04. Yeah, and like congrats to like Ansha for doing all those visualizations. She spent a lot of time doing all that matplotlib stuff and making it look good. Let's jump into preparing our data. So we're at the point now where we've sort of unit tested our data, we've validated, we've checked our constraints, things look good. We now want to start actually training our model. When I first put this workshop and was first scoping out the book, I was planning to actually use TF-IDF just to match what was currently available with like Autopilot. In speaking with folks like you and with customers and with coworkers, we decided to actually kind of jump forward to modern times, and we're just using BERT. So BERT's awesome. BERT's fantastic. I think I skipped the overview here. Let's see if I have anything in the overview. So this is really what it looks like. We've got data that's sitting in an S3 bucket. It has star rating. It has this review body among many other like attributes, but these are the two that we're really going to focus on. We're going to use a scikit-learn based processing job. So in the previous section with DQ, that was a Spark based processing job, and it was using Scala, soon to be using PySpark. Here, we're going to use Python with scikit-learn. And so these processing jobs are pretty cool in that they can do tricks with S3 and pull data in parallel. They could shard data. So I could actually spin up multiple instances and shard my data across all those instances and operate in parallel. One really cool thing about BERT is it has been pre-trained for us on millions and millions of documents, right? On like Wikipedia, on Google corpus, or sorry, books corpus. And so the training has been done. All we need to do is get our data in a format that BERT can understand. So these are called the embeddings. So let's just call them BERT. Yeah, and so what we're doing is taking this text, we're going to do in massive parallel processing. We're going to take each line and then convert it to that embedding and store it into another S3 bucket, and then that will then get picked up by our training job that we'll do next. So this actually shouldn't say is positive sentiment. This should say star rating, but the values are correct. So yeah, this is like logically what we're doing. Let's physically do it here. So we're basically doing feature engineering. Now we're not doing complex like combinations of features and everything. All we're doing is taking raw text and converting it into numbers. In the AutoML land, we did that with like TF-IDF, or yeah, that's what AutoML chose. One second here, I have to plug in my headphones here sorry, I have to change my headphones. Hang on a sec. Okay, had my one pair of AirPods die, so I put in the second pair. Okay, so here's how processing jobs work. These are just basically Docker containers. We can map an S3 bucket into them for both input and the output. Yes, very straightforward. On the inside, you write to just a folder that's been mounted to that's backed by S3 for both the input and the output. And then the cool thing, like I said, is we could shard data and go across. So each instance, right, because we want to do this in parallel. There's absolutely no reason to do this serially because all of the data is going to get run through that same BERT transformer or tokenizer, BERT tokenizer. So let's look at some of the data here. There's our data. Let's look, just double check. It's the same here. It's the same digital software, digital video games. This is the actual Python file that is going to get run. And I'm not going to show too much about the details here, but just know that we're taking raw text and converting it into these IDs and things that are used by BERT. We're actually going to create a TF record. Now, TF record is a file format. If you think about, like Parquet, right? You typically don't want to store data as a CSV or a TSV. If you plan to do analytics or do machine learning, you want to get it into something like Parquet or some file format that is binary, that's packed, that's efficient, that can be compressed very well, and can be that works really well in memory. Also, okay, one sec. Okay. All right. So at the end of this, we'll actually be creating TF record, and I'll show you that here. So you can take a look at this, but this is really like what it all comes down to. Now we're using a flavor of BERT that's actually very, very good accuracy. I think it's about 96, 97% of the full BERT, but it uses way less memory. It is actually quite fast, and it's still the same tokenizer. Still doing it can still generate the same like file formats. So it's just much quicker. So we'll use DistillBERT, and it's a sort of right, like I guess you would say it's like an applied statistics kind of method or term, right? Like distillation. Yes, you can read about it. We're using this library called Transformers by this company Hugging Face. So let me actually show you real quick because we love this. So this is it here. Let me post it into the chat just so you can all take a look. But all right, so that's so people love it. Okay, good. There's PyTorch support. There's TensorFlow support. Yes, Ansha knows this stuff really well too, so feel free to ask questions there. And all we're doing is just using this Python library. We're passing it to SageMaker, and SageMaker is going to do all the heavy lifting. So I'm just going to get right to it here. I'm saying use scikit-learn. I just picked a particular version in time of scikit-learn. You could use newer versions, doesn't matter. Here I'm telling it the instance type to use. So here, let's use a C5-4XL. Let's use 2 of them. You can set this to 10 to 50. I wouldn't do that here because we don't have the limit set that high, but you can operate in parallel. Because we have 2 files, I'm showing you how we could use 2 instances, and each full instance will come up and and each one will get one of the 2 files. And that's because we're using the sharded by S3 key. So this is probably a little bit more detail, but just so that you're familiar with the term. So sharding will take the full data set and see how many instances you've allocated and just divide up those files and place them onto different machines. That way, like, we're not copying all of the data over to all of the machines. Each instance will receive, in this case, half of the data. And because there's 2 files, each instance will then receive 1 file. we're then telling it where to output. So the output of this job, we're actually creating three separate data sets. We're creating the training data set. We're also creating validation and creating test. So we are taking, I think it's about 90% for the training, and then 5 for validation and 5 for test. And we're doing this because like we want BERT to see lots of data, but we also have to hold back some data so that we can verify and do hyperparameter tuning. And then once we've actually chosen what's the best hyperparameters, we need a third data set called the test data set to then validate those hyperparameters. Okay, so let's kick this off. Let's do a run all. And again, this is one of those notebooks that says, please wait. You will see errors down here, potentially, if you don't wait for this. So wait for this. This is going to take a few minutes. You can look at the deep links here, go into CloudWatch, or go, and then keep an eye on the logs. This should be pretty quick because these files are small and these instances are relatively big. Note that you're only being charged for the time, for the number of seconds that are needed to process this data. So from that standpoint, this is like serverless from that standpoint. Like you're not spinning up a full instance and managing the instance. All I'm doing is saying, I want the instance that has this kind of profile, this number of CPUs. In the training step here in a bit, so BERT has been pre-trained, but we're going to actually fine-tune BERT on our data. And so we're preparing our data to be fine-tuned. So we are going to reuse all the things that have been learned from like Wikipedia, from the Google Books corpus, and that have been built into BERT, but we want to adapt it to our customer reviews data set. And so that's exactly what we're doing here. We're getting this data, and because we're using TensorFlow for the training, we want to use TF record. We don't have to use TF record, but we want to. The training happens much faster. Okay, so the output of this should be 3 S3 buckets. When this is done, give this a few minutes. And this will turn to completed. And we'll then look at the 3 outputs. These 3 buckets will have data that'll be .tf record. All right, and let me look here. So we're running this. Let me just like quickly show you what we could have done and what I was doing about 4 or 5 months ago when we first were speccing out the book. I was planning to do the same thing, but actually generate TF-IDF with Spark. So we've already shown you how to run Spark as a SageMaker processing job in a serverless kind of manner, where we're just paying for the seconds that we're actually running the Spark job for DQ. Now we could take our raw data and create the embeddings for TF-IDF. And really TF-IDF is pretty straightforward. It's finding words that are like unique, or that it's basically squashing out common words, and it's trying to find like an alternate representation, which is typically some vector space of maybe hundreds, maybe thousands of dimensions, something the human can't really visualize, and projecting sentences and words and phrases into that new space. So that's TF-IDF. Now, TF-IDF does require all of the data to be analyzed together. So it cannot be parallelized the same way that we are like currently transforming with BERT. BERT has done that. BERT has already been trained and created their vocabulary and created this vector space. We're going to modify it a little bit in the next section, but with like TF-IDF, we have to basically start from scratch and figure out the vocabulary and look at all the data. And so this is perfect for Spark. And Spark ML does have TF-IDF support, and that's exactly what we're using here. So we're building upon the exact same Docker image, and I'm not going to actually run this, but let me show you and this is pure PySpark, by the way, because I wrote this code, whereas with the DQ stuff, I was reusing the open source code that was out there. This is open source, of course, but I had full control over this and I was not using somebody else's library that was written in Scala. So here's TF-IDF here. So term frequency should be up here. We're using a particular implementation called hashing, like term frequency, and then IDF. And then we're applying PCA. So similar to what we saw with like AutoML. So I was actually inspired when I saw the output of AutoML. I was like, wait a minute, I could probably do this, right? Like, why do I need AutoML to do this? I could do this. So, but I learned the hyperparameters that AutoML found were the best, and I pulled them into my own Spark job. So you'll see some of the hyperparameters here were actually driven by that. And the output, again, we're doing 90% and then 5%, 5% for the different data set types. So I'm not going to run this because like this will like use a couple extra resources, and I'm not really even going to look at it once it's done. But just know at the end it will output 3 separate data sets. This is how you would run it, similar to the DQ stuff and similar to the BERT stuff. Okay, let me go back and look at here. Let's see if any of these have been populated with data. Let me check the progress. Still in progress. Okay. So let me see if there's anything else interesting. Let me get set up on train, and then I think we'll probably take maybe another 20-minute break that we'll call lunch, or maybe 30-minute break. Yeah, so let me give about 8 more minutes up to 11:30, then we'll break until 12. So we'll do 30 minutes for lunch and to kind of regroup and get coffee and stuff. Okay, so let's assume that the data has been fully prepared. It shouldn't be too far off. It doesn't take that much longer, but at the end of it, we will have, if I scroll up to the top here, we'll have the data in a new bucket, or actually physically in the same bucket, but in a different prefix or folder that has our transform data in TF record. Once that's done, where'd I go? Lost my, close some of these. Pilot. And I think I actually have it here. So I have a sample data-tf record, and these are essentially what they would look like. These aren't really human readable. You can kind of crack them open and see some bits and pieces that you might recognize, but we have 3 different, and keep in mind these are very, very small like data sets here. So let's just do, and so this term ad hoc, by the way, means in the notebook. So I saw that there was a tiny bit of confusion in the chat questions earlier, which is, I didn't see too much CPU happening, yeah, what's going on? I feel like this notebook isn't doing anything. And that's the point. The point of SageMaker is that you're not doing things in the notebook, but you're offloading them onto a cluster that can scale out and scale in, and so think of the notebook as kind of a portal into the SageMaker cluster or the SageMaker service. It just so happens SageMaker supports notebooks, but we actually don't want to do too much processing in the notebook. So whenever we do this, it's usually small data, it's usually just very quick, and I typically name it ad hoc on the end. So here's that transformers library from Hugging Face. We're using the latest and greatest stable TensorFlow 2.1. I think there might be TensorFlow 2.2 that finally GA'd, but for today it's going to be 2.1. But just know this is all fully, TensorFlow 2x. Like there's no 1.15 in here, any old stuff. All this stuff has been moved to TensorFlow 2. Fortunately, Transformers does support TensorFlow 2. Just give this a minute. This actually is sort of uninstalling anything that, or it's like upgrading all the stuff that's required for these libraries here. So just let this run for a little bit. I have it on quiet mode so it doesn't fill the entire screen, but sometimes it is confusing because it seems like it's dead. But just let this run. Here's the imports. Again, these are all being imported. So all these are doing are, these are written in TensorFlow. There's also PyTorch. we chose TensorFlow because we, well, that's like mainly what I know is TensorFlow. But I have run with PyTorch, but because we have a pipeline that's already creating TF records, figured we would stick with TensorFlow. So here's that BERT tokenizer, the same exact tokenizer that we saw in the previous like transformer, the SageMaker processing job, sorry. Okay. So what's happening here, by the way, is we're not actually training, and I've gone back and forth on how to rename this. We are actually, because BERT has already been trained, we're fine-tuning BERT specific to our domain, to our data set. And these neural networks are like totally set up for this. You can add layers on top or at the end of these networks, and they can do task-specific or domain-specific things for us. And that's the beauty of these neural networks. They can always take new data. They can continue to train on new data. This glory or this kind of holy grail of being able to do continuous training, right? These neural networks are like totally set up for this. All right. So let's do the imports there. We're going to set up something that is important to note about BERT. You have to tell it a sequence length. And sequence, think of it like a sentence. And you have to use the same length during the pre-processing, which we did in the previous section. That's running here. So if you notice, if we look at max sequence length, this has to be specified. So here's a case where we're doing feature engineering and there's a hyperparameter for our feature engineering. So we've looked at these reviews data or at our, like this specific reviews data set. We see that the kind of a super, so at like 128 is really where our data set starts to kind of trail off. So most comments seem to be, or that number 128 like captures a right, like high percentage of our data. So we chose 128. I've seen other people use 256, 512. Typically binary is good. If you have reviews that are less, they will get padded. If you have reviews that are more, they will get truncated, and multiple sentences will then be generated. This is just how BERT works, but it's very important to note that this is a case where you have to, or if you change your hyperparameter, you actually have to go back and like engineer your features. So this is one of those cases where like AutoML could handle this very well because it is also handling the feature engineering and not just the training and tuning. Okay, so if that didn't make sense, don't worry about it. Just know that this number has to match what we used before. Batch size, we're just choosing 16. I've just like done a bunch of runs and these seem to work. Steps per epoch, these are like neural network terms. Not going to spend too much time here, but this should look familiar. Classes 1, 2, 3, 4, 5. And I guess let's just kind of run through this. And here's some helper methods. This is what's going to convert and pull in our TF records. Here, because we're doing ad hoc in the notebook, I'm actually going to point to this local directory here. This lets me move forward when we're going to take a break and we're going to run O3, which is going to use the data that we created in the pre-processing step, which if I just take another look here. Let's see if this is, okay, so this finally completed over here, that previous step. Let's take a look. Here's those TF records. I have gone ahead and copied these in a prior run into this ad hoc notebook here. Okay, I think I was here. So I'm just using them locally. So this is actually going to do the fine tuning directly here in the notebook. This is pulling down the BERT vocabulary for the distill BERT variant. Now, this is actually our new model. So we've added this extra layer on top to convert BERT into a classifier. We've told it that we have 5 classes. Those were the classes up above, 1, 2, 3, 4, 5. So it's multi-class classification. And now we are actually going to, so here's that extra classification layer that we're putting on top. This is what our Keras model looks like. So again, I'm not going to spend too much time here, just kind of showing you guys how to do it. People come from all different backgrounds, but this is how we're fine-tuning BERT. And the output of this fine-tuning is a new model that we will then use to make predictions. So let's run this. Let's do fit. This is going to run for a little bit. So train for 250 steps. It's going to validate for 50 steps. And then we use our third holdout, 5%, which is test data set. And so this will run for, I think, about 2 or 3 minutes. And then down here, we will actually load the data and make some sample predictions. And yeah, you'll see BERT with a very, very small amount of data actually has very, very good accuracy, ends up, I think, even with this small data being 60% or possibly even 70%. When we do the full data set, it's upwards of 80 to 90%. It can take raw text from the wild and make predictions that are pretty accurate. It can say whether or not it's a 1, 2, 3, 4, or a 5-star rating. And while this might seem kind of weird because we already have the star rating, think of beyond, you know, right, like this specific use case of these reviews. But now I could take comments in the wild, maybe off a customer support email that comes in. I can analyze the text that's in that customer support email and kind of gauge a like temperature. You know, yes, is this customer super mad? Are they super excited? There's other ways we could fine-tune BERT where we can fine-tune BERT on product category. So we could take a review and actually predict the product category. And so like we could do this. That it seems kind of silly because we already have the product category, but that's how we're training and fine-tuning. But now maybe like we want to take an email from our support system and figure out which product are they talking about. Or maybe there's a Twitter comment and we want to route that like Twitter comment to the particular product manager within Amazon and say, hey, there seems to be, you know, some right, like bad reviews about these particular product categories. Maybe lawn and garden products have been, you know, really bad over the last few months. So yeah, so there's lots of like uses for this beyond just sentiment analysis or star rating prediction. Okay, so that's going to train for a little bit. Why don't we also launch O3 script mode? So script mode is this term that the SageMaker folks have coined. It like always kind of throws me off a little bit, but you know, you think you would call your train.py file a script, like typically, right? You have a Python script, so just kind of casually call it script mode. All script mode means is you are providing the .py file. So same kind of thing. BERT has already been pre-trained. We've done the feature engineering in that previous step. Now we're fine-tuning to take our review body, but it's actually going to use the embeddings that we created during feature engineering and then predict star label. So let's go back here. So instead of doing it in the notebook, which is what we're doing in O2, we are actually doing this on the full SageMaker cluster. We're also going to introduce some concepts here like the experiments API for tracking experiments. So here, this is just for like other demos that we do. So just skip that part. Like we don't actually need this data. We're going to pull it from the real data. So we're like wiring this all up, just making sure, pulse check that this is good, that there is data in here. Also note that we're doing sharded by S3 key. So again, the same thing. If we have multiple instances, each instance will receive its own separate set of data. So if we have 2 instances, each instance will receive 1 file. This comes in really handy when you have 50, 60, thousands of files. And so let's take a look at the code. You should see a lot of the same imports. We're going to take a look at what the transformers folks, the BERT folks, call text classification, or these like pipelines. So basically, it's like an inference pipeline. It could take the raw data, it can tokenize it, and then run it through that new classifier that we are about to train. So this really looks very similar and should look very similar to the code that we did in the previous ad hoc, but this is more the kind of server-side version. So I have a lot of extra logging in here. I'm going to skip through a lot of this, but yes, if you have specific questions, you can ask me offline. But this is basically what I would be running on my laptop, except now I'm actually pushing it into SageMaker. So here I'm purposely setting up hyperparameters separately. I could say which instance type. This is a GPU. If I wanted to, I could change this to 2. Yes, you could just use 1 also. P32X large, let me just change it back to 1. A few other hyperparameters. One thing to point out, there's this feature of SageMaker similar to the sharded by S3 key, where we can, right, like that's the whole benefit of SageMaker, by the way, is that it's really tightly integrated with like S3, which is great from a performance standpoint, from a cost like reduction standpoint, from a data movement standpoint. Pipe mode is one more thing on top, which can actually stream just the data that you need. So pipe mode, in conjunction with the sharded by S3 key, can split the data up onto different nodes. So if we have train instance count is 2, each instance will receive half of the data set. And then also pipe mode can stream the data as needed. So if I didn't use pipe mode, if I was using what's called file mode, I would have to physically, at the beginning of my training job, copy all of the files onto that machine. So here, because we only do have 2 files, it's not that big of a deal. But when we have thousands of files, yes, I want to start my training run so right when I click start. And so pipe mode will give me this ability. Also, pipe mode will only pull the data in that's needed. So if I don't actually need all the data, let's say I stop my training early because I've achieved my, like 95% accuracy, then that data will not get moved in. And so this saves cost, saves movement, speeds up the job. But if I do have to copy all the data, there is a little bit of like upfront hit there, and my training jobs take longer. So use pipe mode where possible. I've been working really closely with the SageMaker team to get this optimized for BERT. So that's pretty exciting. And we can, if you're familiar with something like an ML flow where you could track experiments, or with KubeFlow, which we'll talk about after lunch, you can track experiments and compare them. And then we have the same thing within SageMaker. It's called SageMaker Experiments Tracker. So we're setting it up. We're logging all the hyperparameters. This is pretty much exactly what you would do with like MLflow. We're also able to log the inputs. So this is the S3 locations for that input. And then we're creating a trial here so trials are like runs within the larger experiment. This is pretty cool here. So this is, I'm specifying, so because SageMaker has been designed to be generic and to give customers full flexibility to run any kind of model, any kind of framework, the one downside to that flexibility is you sometimes have to provide hints to SageMaker on how to capture things like validation loss, like validation accuracy. So these are the classic metrics. So up here, we were logging hyperparameters right here, but we also have to tell SageMaker how to capture the metrics. So what's actually happening, because SageMaker is all using containers and it's all serverless, all that stuff, what's happening is it is tracking, it's scanning the console of these Docker containers that are running within SageMaker. And when it sees a line that has loss colon something, it can pluck that out of the log line and assign it to a value called train colon loss. This then fully integrates with CloudWatch, and you're now able to, track your like model performance metrics right next to the like GPU metrics and CPU metrics and disk utilization. So yeah, like we'll see this in action here in a bit. But just know that we can basically put in any kind of like regex and call that a metric and then start to plot it. So this will differ from framework to framework, and I've actually seen it break. One time I upgraded from I think it was PyTorch 1.1 to 1.2, and they changed the way that they were logging. They added something in here like model underscore loss, something like that. And my regex broke and I couldn't figure out. So just like to be fully transparent, if you do upgrade, just like maybe double check, triple check that the way that they're logging, and it's super easy to check. Like you would run this in like ad hoc mode like we did earlier. We could see the output of the training somewhere. Yeah, so like right here, for example, this showed me right in the notebook val underscore accuracy. So hopefully here I'm looking for val underscore accuracy. If this changes, you probably won't notice it because you might not be paying attention or thinking that you have to pay attention. You shouldn't really have to pay attention to this stuff, but sometimes this does change from one framework. And certainly between PyTorch and TensorFlow, it's different. Okay, but that's the flexibility. So now I can create my own framework and run it on SageMaker, and I can trap metrics and then chart them with CloudWatch. Okay, this is something called debugger. This is a little bit advanced, so I probably won't spend too much time here, but think of it like TensorBoard, except you could do it across all frameworks. And so here I have callbacks and hooks into my training process. I could do this with XGBoost. I could do it with linear regression, with yeah, so whatever I have with, and we're doing it here with BERT. So let me set that up. We're going to do every 10 steps. Save it to TensorBoard true. Now, here's where we're actually telling SageMaker about our script, and that's the exact .py file that I had catted up above. We're giving it source. This is where I would put my requirements txt if I do have dependencies, which I almost always do. So really, like while this says TensorFlow, this is actually just defining my script that's going to run and which version of TensorFlow. It's Python 3, not 2. Going to give it the size of the disk size that I need for this. There's defaults for all these things, by the way, but I just am showing all the ones that I typically tune or change. And then, of course, all my hyperparameters. We'll do hyperparameter tuning after the break, but and here's input mode, which has been set to pipe mode. Here's the metrics definition, which is that regex up above. Here's my debugger rules. Here's more like debugger configuration. And something I always like to do just to keep costs down. And while my servers are all paid for by Amazon, we're still very frugal. It's a very frugal culture. So I like to set maximums here. Sometimes my jobs run for a really long time because of a bug that I have or some issue with the newer version of TensorFlow or PyTorch. And really, I don't want to take up resources from like other customers or my coworkers. So I'm going to set a max there. These usually don't, this particular run usually doesn't run more than 2 hours. And this is in seconds. So let's see, did I run that one yet? So that didn't do anything except create the what's called estimator definition. Here I'm tying that estimator in with the input data for training, validation, and test. I'm also passing the experiment configuration I defined above, so this will run in the context of an experiment that I can then use later on to compare. And here we're just doing the accounting, and now I think we'll take a break. So at least get up to this part. Some of you that kept going might have seen errors down here. It's because this job hasn't completed. You can use these deep links to keep an eye on these jobs. I like these deep links. They really help me out, especially when I have about 5,000 tabs open. I pretty much know that this notebook and the 3 things after it are what I'm looking at. So the interesting thing is going to be once these logs start showing up, you could actually see the output of this TensorFlow job. You'll see also some sample predictions because we have them buried into the script. Let's take, okay, it's 11:45. Let's come back at 12:15 Pacific. Let's return 12:15 p.m. PT. This is our lunch break. I'll put lunch in quotes because some of us are in different time zones. All right, great. Yeah, just looking at some of the comments. Yeah, okay, we will answer questions during the break, and Ansha and I are gonna get some water and coffee and food. So talk to you in about 30 minutes.
Talk soon.
Okay, we're going to start here in a minute or two. Okay, so I've actually switched microphones here. I don't know if it's better or worse. I've been trying out different audio solutions here since we've been doing a lot more online stuff the last couple months. So, okay, where we left off here, I spoke with Ancha at the break, and it sounds like there's a lot of questions. There were quite a lot of questions, I think, about the max sequence length. Max sequence length usually is something you want to empirically figure out, but you can look at the number of characters in your typical sentence and go a little bit bigger than that, and usually go up to a binary number. Okay, so there's no real like think of it like most other hyperparameters. There's a little bit of intuition, of course, but you have to look at your data set. And the way we did it with our reviews is we looked at the character length of the entire review. And there actually could be multiple sentences in a review, but I think the first pass that we did, and that ended up coming in, I think it was like around 120 or something. So 128 was good. The reason that you want to go up is because you can pad. You don't want to go too high because then you're just padding everything. You don't need to capture long tail. So look at the distribution, the number of reviews that are, and then bucketize and say you've got, so if you can capture a good percentage of your reviews, and they're all below, or let's say 80% are below the 128 mark, then use 128. If your average sentences are 500, you have five, then go to 512. Really, that's kind of the intuition there. But beyond that, you have to tune it like any other like hyperparameter. Why that's a particularly difficult one to tune is you have to rerun your BERT tokenizer, and in our case, it was the pre-processing job with that new hyperparameter too. Okay, yeah, lots of cool backgrounds here. Yeah, people from everywhere, Colombians, a couple Munchins, some FedEx folks, very cool, awesome. All right, so up on my screen right now, I kind of blew through the overview for this, but so this is still section 6 training, and I just want to show the quick overview. I realized at break I didn't show this, but you have lots of options with SageMaker. Script mode is really where I like to be, because I like to have a little bit of control over what's going on. But I don't want to deal with all the managed infrastructure, so I want someone else to manage that. Built-ins, there's like XGBoost built in, and these are super simple. This, you just point to your data, and the SageMaker built-in, kind of like Autopilot, and in fact Autopilot uses XGBoost built-in. But yeah, lots of different options, all the way to bring your own container where you completely don't use any of the SageMaker containers. You actually build your own Docker image from scratch. So very similar to what we did with the Spark DQ processing job. So lots of flexibility, and really, comes down to where you're most comfortable, how much the customization that you have. Also note, this is something that not a lot of people know about, but the SageMaker containers, they're called deep learning containers. These are actually open source, and there's really nothing magic about them. Let's see, I think this packet, this is the deprecated one. SageMaker training toolkit. But all of these things are open source. So you can look in here and I believe, let's see, they call this. Anyway, yes, if you Google for SageMaker deep learning containers, you can actually take one of their Docker containers, the pre-built SageMaker container, and extend it. And I've seen customers do this. They're like, okay, we like some of the things that your containers are doing, but we don't want this particular version of this. And so, yeah, that's fine. Just go in and take this container and customize it. So let me throw the link in here. One thing I've seen people do, I'll talk about more when we get to KubeFlow. I've seen people that use the same container for both SageMaker and for KubeFlow. Okay. So there you should be able to get to the actual source code. Yeah, you can get to the actual source code. Right, okay, yeah, that's right. They actually broke them down into their own separate repo. So PyTorch has its own repo. And you wouldn't normally have to go in here, but if you do have a specific need. Or I've seen people where they need a feature out of TensorFlow 2.2 or 2.3 that has not yet come out or like has not been GA'd, or they need a nightly build. And so they would take an existing TensorFlow 2.1 container and they would pull down 2.2 nightly and then use that. But for the most part, those containers are pinned to stable versions. All right, so last we left off, we were running this training job in script mode. Let's take a quick peek at what we have. So I'm actually in the SageMaker console. That's what this deep link gets me to. The training job page, the CloudWatch logs, and the S3 output. And let's dissect each of these real quick. So training jobs, I could also just come here and try to find the job if I take note of the name. We'll do hyperparameter tuning here in a sec. I ran AutoML earlier, by the way, so we should actually have hyperparameter. Yeah, this was generated by AutoML. Not sure if like Ansha showed that earlier, but when you run AutoML, it's actually building hyperparameter tuning jobs. So this is from section 02. So I'm going to skip it for right now, but just know you can dive deep into there and see what happened. Back to section 06. Oh, and then of course, each of the hyperparameter tuning jobs, by the way, spawns training jobs. And so we'll see earlier these ran. This was the script mode training job. So this is the one that we're in right now. We see how much time was actually billed. So this took 10 minutes. 593 divided by 60 is just under 10 minutes. That's all the time that you're billed for. You would actually have to look and see which instance type. I think we chose a P3, and you'd have to multiply it by 1/6 or the like 10 minutes. Oh, but we did 2 of them, so yeah, don't forget that we have 2. All right. Let me see. I actually didn't use spot training for this, just to speed things up. Sometimes with spot training, the job will stall for a configurable set of time. So you could wait, 30 seconds for a spot instance. You could wait 20 minutes, depending on how quickly you need this job to run. So to keep things on Rails, kept that for the on-demand. Here's the different data sets, by the way. So if you recall, we actually had 3 different data sets. We had train, validation, and test. And note that we use sharded by S3 key. And here's our metrics definition there. These are all the hyperparameters that we passed in, and some of them are passed in by SageMaker, actually. There's something called network isolation mode with SageMaker, and this makes sure that nothing can get to the internet, and of course nothing can get from the internet into it. Also, you can turn on encryption at all layers. You can encrypt, of course, the EBS volumes that are being used by these instances. You can also encrypt the inter-container traffic. So in this case, we had 2 workers. We had 2 TensorFlow workers in our cluster. And I have this set to false right now. Just actually, I should just turn it on. There's really no reason not to turn it on. You can, so the traffic between the nodes in our cluster can be fully encrypted. Yeah, and like, don't worry, these are not exposed to like the internet by default, but this is really if you want to make sure that, for example, a pip install like doesn't pull from some rogue right, like repo out there. So you would essentially have to pin all of your pip installs or your dependencies into the like Docker image and not allow any outbound traffic. So really, it's more for the egress kind of thing for this network isolation. Okay, here's CPU utilization. We should see CPU go down, GPU go up. Let me actually back out here. It's a little easier to visualize. Pretty linear, like we didn't run for that long. Typically, these aren't that linear, but we see memory going up, of course, this utilization GPU going up as CPU is coming down. We can look at more details about the instance metrics in CloudWatch. Interesting. Oh, and then also validation loss and validation accuracy. Now, we only did one epic for the validation, but for training, we actually did multiple, or I think, wait a minute. Yes, anyway, like we didn't train for that long, so we're not seeing that much data. But here we're seeing system utilization right next to model metrics, which is pretty cool. All right, so this is pretty much the single pane of glass for this. Also note input mode is pipe. So our training was able to start much quicker than if we had to copy all the data over. So that's that. I want to take a look at the logs. So click over to the logs, make sure you hit refresh. Here's our two nodes. Let's just hop onto one of them, doesn't really matter. So this is the same output that you would get if you were running on a local laptop. Of course, you wouldn't see all the SageMaker stuff, but really this is our like pip install happening. Here, I'm just doing a bunch of debug stuff while I was creating this. I was debugging some things, so some of that's still in there. If you remember when we did the ad hoc, we dumped out what the fine tuning model looks like, the classifier, and then off we go. So here we can actually drill in. You'll like occasionally see some errors and things. These are typically framework specific and don't, well, if you screw something up and, for example, don't provide any data, or you have a like malformed TF record, you'll see it here, but that's not the case here. So here we can actually look and we'll see, here's loss colon. And then at the very end, we'll see validation. I think after every step we see, or sorry, after every epic, we should see validation. So we had it trained for 1,000 steps. At the very end of that, I thought it says validation accuracy. Here's the remaining. And here it is. So because we defined that like regex to pluck out val loss and val accuracy, we then, these then show up inside of CloudWatch. Okay. So it does that a couple times, does the validation, and then does the test. And then also we just do some sample prediction just as a sanity check. And, similar to the sample reviews from before. I loved it. I'll recommend this to everyone. Really bad. Hope they don't make this anymore. One. And yeah, so notice that we're not just predicting the star rating, but we're also giving the confidence that that star rating is a 5. And this is pretty confident. This is 89, 86%. Saying it's okay. There's really not a lot of words. There's only a couple words there, a couple tokens. So the confidence is low, but relative to the other 4 options, 31% is the highest. So 1, which is bad, is the winner there. That I believe if we had fed it more data or trained for a little bit longer, typically I see a 3 there. And then really bad, that's a very high confident 1. Okay, that's how you interpret that. You could also go over here and click refresh. you'll notice the source code gets pushed just so that like everything is all in the same spot. All these are all tarred up, so you can download a single file. Output, there's our model.tar.gz. This is our Keras model that we had trained. You can pull it down, you can embed it into any application, or you could, one-click deploy it as an endpoint. If we back up to, we should see debug output. This is actually debugger. So this is SageMaker debugger. This is something we chose to turn on. And I think that'll probably be the next section here. So let's show the experiment results. So right now the experiment results show up best in SageMaker Studio. And SageMaker Studio is still in preview. It's still only available in one region. I don't have a date for when it will be supported outside of that single region. But you can get to all this programmatically. And really this is all SageMaker Studio is doing, is just doing it through the web interface, is pulling this data in. But here we can see the different trials or runs, as like a lot of people call them. We can sort it in different ways. We can look at essentially all the same stuff, all the hyperparameters, and then some of these metrics as well. Because training accuracy loss and validation loss are considered metrics, we can then so the experiment tracker will then automatically calculate summary statistics on these, like standard deviation average. Let's take a look. So I didn't spend too much time on the rules up above, but basically I was setting it up to look for a case where the loss maybe wasn't decreasing. So loss not decreasing means we've plateaued. It means our model is not really getting any better. So the more we train, so that was not the case here. Because we didn't train it for that long, it was making good gains and training continued. If we trained for 5 hours and our loss was just sitting at the same level, 0.05 or 0.0005 or whatever, this would actually trigger this rule, and we could then tie that in and call a lambda, for example, that could then stop this job, and then we would early stop. Now, some of this stuff is like becoming easier, and starts to get integrated into AutoML, or yes, into Autopilot. There are some other ways to actually do early stopping that are a little bit more intuitive or simpler, just passing in one argument. We'll show that here in a bit with the hyperparameter tuning. But you could also trigger things based on these rules. So these rules can be tied to like an SNS notification. Someone can get notified. Maybe there's an example where we're overtraining. So there's 2 rules that we set up for, which is loss not decreasing and then overtraining. And yes, overtraining means that we're overfitting. We are potentially, and so this is another case where we potentially don't want to release this model or want to stop training. Okay, and there's no issues found in this, so no issues. If we did trigger one of these rules, it would show up here. This is sort of, this is after, or we are currently like looking at this job, yes, after it's stopped, but like you can actually run this while the job is running. Okay, let's actually pass this. I used to have all this in one notebook, and Ansha got mad at me because the notebook was like 500 lines long. Let's store that away, and let's quickly look at this model. So all I'm doing here is pulling it down from S3 like I described earlier. So I stuffed, yes, one thing about Jupyter, by the way, you could stuff little variables in, kind of like a session scope. Be careful with this. You could sometimes not know that there's already stuff in there or be using old. So I took the job name from the previous notebook and I stuffed it away. I also stuffed away the training job debugger artifacts path, which we're going to use in a second to actually look at more about the debugger. So here it's doing the quiet install, so give it a sec. It's installing TensorFlow 2.1 and Transformers 2.8. What we're going to do is pull down this model. We're simulating as though we're pulling it into an application. Really, we're just pulling it into our local notebook, but there's absolutely no difference here. So I'm going to crack it open because it's a tar.gz. I'm going to look at the contents of it. And then I'm going to actually load it and get it prepared. So here we're using the Transformers library once again, favorite library. We're now considering our model that we fine-tuned to be the pre-trained model. So were fine-tuning, we were treating the actual BERT model that was trained, by Google like 2 or 3 years ago, and we were treating that as the fine-tune. Now we're actually treating our new finely tuned model as the pre-trained model. We then have to override and say, okay, these are the actual names of the classes 1, 2, 3, 4, 5. These are the indexes 0 through 4. But really, we want to make predictions that are, and if we were doing something else, we could call this, for example, quote star rating 1. These don't have to be integers, but I'm just using that to be consistent elsewhere. Okay, so let's do that, this is inference device. This is just a small detail. You could switch it to force it to use GPU. Here's this pipeline concept. So this is actually fairly new. The creators of the Transformers library recognize that all we want to do is make predictions with raw text and get the prediction, and not have to do all the tokenization and all the BERT conversion. So essentially, they've created something, sets of these for either like entity recognition or right, like the various tasks that this Transformers library supports. In like our case, because we're doing text classification, we're using the text classification pipeline. We're giving it the model that we just fine-tuned. We're giving it the tokenizer, which is the DistilBERT tokenizer, telling it it's TensorFlow and not PyTorch. If it was PyTorch, it'd be PT. And then telling it, because this notebook only uses CPU, let's just use CPU. And let's run a sample prediction. So there we go. So really bad, got a 1, pretty high confidence. 5 is 89% confident. I loved it, all that stuff. So that's actually pulling it into what could be a third-party application. All right, let's keep going. Let's take a look at what was actually retrieved by the debugger. So again, debugger is similar to TensorBoard, but it works across all the different frameworks. There's actually a really slick one that we have someone developed internally and then open sourced it, where you can visualize the attention heads of BERT and look in, and this is all using SageMaker debugger, and look at how it's actually learning and which words it thinks are associated, and kind of peel some of these layers back on BERT. And it's all visual, and it's all rendered in fun ways. We're working on getting that into the workshop. It was written for MXNet, and so I have to adapt it over to PyTorch and to TensorFlow. Okay, so this is pulling in. So essentially, I showed you earlier that there's this directory called debug output, and debug output has a whole bunch of stuff that was collected during training. And that's what we're cracking open right here. So we can visualize the accuracy. Here's that thing I was saying, we could actually add a Lambda step. This is a to-do, have not gotten this in here yet, but we can listen for these rules to fire. They come through as a CloudWatch event, and then we could trigger the Lambda. Someone got an example working, so I grabbed the code, but haven't actually gotten it into the workshop yet. Okay, and I think someone earlier was having problems getting TensorBoard working. I think I'm going to take that offline. I'll try to do it this next section when Ansha is speaking, and see if I can get it to work. It was working a couple days ago when I tried it. I thought I tried it last night also, but maybe not. Okay, so at this point, yeah, Ansha, are there any questions I should answer, or do you just want to take over? I want to get to the KubeFlow stuff pretty soon, so.
Yeah, I think I've answered pretty much all of the questions here. A little bit people looking ahead to KubeFlow and looking differences between hyperparameter tuning as part of SageMaker or Katib. What are the differences? We're coming to that in just a bit. Let me see, questions around spot training, what to take care of. So if you're using managed spot training, make sure you're enabling and doing checkpointing. So in case the spot instances get claimed, your training job can pick up from the last checkpoint. Let me see, what else do we have here?
Yeah, and that point about spot training, that's really the framework specific concern. And yeah, like you hit it right on the head, which is make sure that you're checkpointing often. The worst case scenario, it'll go back to the most recent checkpoint and continue from there. But that's that's an attribute of the framework that you're using, TensorFlow, PyTorch, that kind of thing.
All right. So shall I take over for the hyperparameter optimization?
Yeah, and then you're gonna also do the KubeFlow setup, and then I'll take it from there, I think, right?
Yes, sounds good. So you can, if you stop the screen share, I'm not allowed to just grab it from you. All right. So you should be able to see my screen here again. I've also executed those training notebooks, so I'm at the same level than you are. And what we're doing next is actually going to the 07 folder. So we're doing some optimization next. And just as a quick recap, so we started by showing you autopilot and comprehend, and then moved slowly through ingesting the data, exploring the data, to pre-processing at scale. And now Chris showed you how to do training on SageMaker. One thing that actually has been around for a little longer already is hyperparameter optimization within SageMaker. So even before Autopilot that got released in last December, SageMaker already had the capability of running hyperparameter optimization jobs. And this is also triggered by Autopilot, by the way. So what I'm show you in this section right now is actually how we can use hyperparameter optimization to find the best settings here. And we're gonna work out of our notebook, but in general, obviously you can use any client, whether it's the console, an IDE, CLI, etc. And we're gonna define a hyperparameter job, and SageMaker can use two different tuning strategies you can choose from. So we can either do random or Bayesian, meaning if you look at the set of hyperparameters for your models, you probably are familiar with or have heard of. There are different ways to find those in kind of this automatic model tuning. So random, as the name says, it's just you give it a range, and basically we're picking randomly some values and checking and comparing those. And actually there are papers outside. You might think it's not the best way to do things, but surprisingly there are research papers saying it actually yields to quite good results. A more, let's say, research, not research, but a more focused way to do things, or it feels like a little bit more targeted, is Bayesian. And with the Bayesian strategy, you're actually applying regression to that problem. So again, why not letting a machine solve the problem? So why not applying machine learning to a machine learning problem? So that's exactly what Bayesian does. So we're treating the problem of finding the right set of hyperparameters as a regression problem. So those both tuning strategies are available within SageMaker hyperparameter optimization. And then basically we're defining some ground rules, like how many jobs to execute, how many in parallel and things. And we're going to spawn here a couple of training jobs, and we're trying to optimize against this objective metric, which we're telling the job to do. So this is a little bit the outlook of this section. And then after that, we're going to move on to the KubeFlow section. I've seen there were a lot of comments already in the chat that you're all curious and excited to come to that part. So let's actually really finish off here with those hyperparameter optimizations, and then we're going to install Kubernetes and KubeFlow and have some more fun in KubeFlow land. All right, so I opened already the 01 notebook here. So if you start with that, it's the hyperparameter tuning notebook, and start executing that. So again, similar to autopilot, hyperparameter tuning takes a little bit of time. So feel free to start that notebook here, and then we can revisit in a little bit of time. So what I'm doing here, again, I'm setting up the infrastructure here, pulling in the SDKs. I'm claiming again and restoring here my previous location of the features in F3, and making sure here I'm setting again the prefix location for the train, validation, and test data as we've done before, and making sure I find the TF record files in here. So I just do a quick ls command. And then basically here also I'm using the sharded by a3 key, which Chris showed before as well. So again, this is a distribution strategy to make sure when we do distributed training that the instances end up with, in this example, if we do 2 instances, 1 file each. So this is similar as to the training we've done before. Also for hyperparameter tuning, obviously, I need a training script. So we're reusing our same TensorFlow bird reviews Python script again. So no changes really here. That's our code that we use during the model training and tuning. So it's basically the same Python script that we've seen. All right, we have the script. So let's move on to the hyperparameters. So here's a list of pretty much, I think, also the same hyperparameters we've been using before. Chris explained them, like batch sizes, validation, steps per epoch, etc. And we can basically now decide between a mix of static hyperparameters, which we just, pass like this. And then we might define a couple of them that we actually want to find the best settings and apply to this hyperparameter tuning job to have a look at. So it's going to be a mix, right? So those are just defined statically for now. We also want to look and look for the metrics during the training, specifically for training loss, training accuracy, validation loss, and validation accuracy. And again, for this, we need to kind of have this goofy regex expression to scrape that information out of the logs. So we're going to set that up also in beforehand here. And then we're creating the training estimator object. And this is, again, similar to the training estimators we've done before. So we're pulling in SageMaker TensorFlow here. Also script mode, so we're pointing it to this training script I've just shown. In case we have requirements txt, also, again, they get picked up from a source directory, the role. So no big change here, really, setting the instance count, the instance types. Framework version, and the hyperparameters I'm passing in right here are now the ones I want to have static. So everything I don't want to tune, I just want to take as a given. Those are the ones I'm putting in right here. And this is basically my estimator. Now let's actually set up the hyperparameter ranges. So from SageMaker, I can pull in the tuner library. And with that, I can actually define those hyperparameter tuner objects. So let's first define which ones we want to tune. So here I'm saying, let's have a look at the epochs, right? Let's check for learning rate. Let's check for train batch size. And let's actually check whether we should freeze the bird layer, yes or no. And as you can see here, there are different, and let me just increase here a little bit, maybe size. There are different parameter types. So epochs are integer. So here I'm saying the range 2 up to 16, and do a logarithmic scaling in between those. Then for a learning rate, this is not an integer, right? This is more like a continuous parameter. So start with a really small one like 0.0001 and go up to 0.0005 and apply a linear scaling between. And then also in the train batch size, this is more categorical. So here it's really about choose either 128, 256, or 512. And the same with freeze bird layer. This is also just categorical. So I say either true or either false, right? There's no in between. So those are the ranges I set up and the actual hyperparameters I want to tune. And then we also have to pass it an objective metric. So what's actually the metric we want to optimize for? And in this case, let's optimize for the validation accuracy. And with that information, we can then construct the tuner. So again, we're creating this hyperparameter tuner object here. We're passing the estimator, which we defined above, which has the training script and all the other static hyperparameters. The objective type is maximize. And as the metric, we've defined the validation accuracy. We're passing the metrics that we want to scrape and look for. We say run a total of 2 jobs. And obviously, if you want to really have a sophisticated hyperparameter job, you would probably scale higher. We want to have a chance to actually see the outputs here. So obviously, the more jobs you run, the longer it will take, the better the results. But as said, for the workshop, we're just making the attempt to run 2 jobs in total, and we run 1 job in parallel, and we're using Bayesian. So it doesn't make sense to run both jobs at the same time, because for the Bayesian tuning strategy, obviously, we need to have the results from 1 training job, and then given those results, we can optimize and try, to find the next best set of parameters in the next job. So in this case, obviously, we have to have first 1 output, and then we're doing the second job. If you're doing just random testing, you can probably do maybe 4 jobs and 2 at the same time. But in this case, it makes sense that we have the results, so we know how we can optimize better. And yeah, early stopping. If we reach our goal, you can also do an early stopping here. You can set like, okay, I want to optimize for 0.99 accuracy, etc. All right, and with that, we can then start the tuning job. And then you just call really the fit, which you normally call on the estimator. You call the fit here on this tuner object. And you're giving it the path to the training, validation, and test data. And this basically starts the job. So again, if you run through those cells, it will take a little bit of time. So I've actually started this while Chris was talking, so we actually can see the results at least here. In your case, it will run probably 15 minutes for each job. So once we get started with the KubeFlow, we have a good chance to come back and see the results here. In this case, I've just started it, so I can actually show you what's being documented here. So in this case, I checked if the status is completed. And you can also go back in the console and have a look. So if you go here on the left in the SageMaker AWS console to hyperparameter tuning jobs, you can see those jobs running. So the first one here was from earlier, from our autopilot job. And the top one I have here is the one I currently started. So we see here the TensorFlow training job completed in my case took 23 minutes. And we can see here actually the listing. So the first one completed in 10 minutes. So if you started it now in 10 minutes, you should see the first one completed. So as we said, we kicked off 2 of them. So let's have a look at the first training job we ran. Let me just click on that. It's late in Europe, so all the Netflix is happening. So my internet is a little bit slower. Saturday night. All right, so here we go. So we see the first training job, again, training time in seconds. It's the only seconds that you get billed for. What else do we see? took a P3, 8x large here. We have our input data, etc. Input channels, data, everything there. Here's the metrics that we're looking for. We're scraping out of the logs. And we do see here the tuning objective metric passed in, the validation accuracy. And we see the settings that this training job actually took. So this one actually for freeze bird layer tried with a false. It ran for 2 epochs. Learning rate, this was the choice tried. So good set of steps. We can see the metrics here, CPU, GPU utilization, and actually have a look at, let me go back to the overview here. So to see how they performed. So the first one actually achieved 72% of validation accuracy, which is pretty good. And the second one, which got started after that, could optimize even a little bit more. So the second one went up to 73%. So what you can do now, you see here the training job definitions in comparison as well, the metrics and the hyperparameter optimization. And you can also click on the best training job here. And here you see the results from the best training job. So in this case, also 2 epochs. Let me see, bird layer, frozen, false. And those are the settings that were best, right? So back in my notebook here, so that in my case, the hyperparameter job completed. It found a good set of parameters actually. So we can store the tuning job name here. Let me go a little bit, zoom out. And then I can run here the commands. So we're pulling in again SageMaker Analytics and hyperparameter tuning job analytics. So we can actually query those results directly here in the notebook. So we're passing them to a data frame. And then we can actually here just pretty easy call the sort values for final objective value ascending. And we have a nice overview table here from the two jobs. So we can compare here, so learning rate changed and the train batch size changed. And apparently both with freeze bird layer false had pretty good first results. So obviously if you want to optimize further, we can do more jobs in total, etc. to find better outcomes. But I think for a first run, this is pretty impressive, 73% accuracy. And yeah, and then we can also just call for show the best candidate here. So we're doing the head one on that one, and here we go. So pretty straightforward. As said, you can check here in the console, and you obviously also see the training jobs coming in here under training jobs. So a couple of places to check for those in the UI as well. And we also do have a second notebook in here. So the 02 warm start hyperparameter tuning. And this is actually, I just learned actually some time ago that we have the warm start completely. I completely missed that one. So if you're running those hyperparameter tuning jobs with a warm start, you can actually reuse the results from a parent tuning job that you've run before. So in our case, and let me kick this off here. I had to wait for that first one to finish. So I'm doing a run all here as well. So let's say you're running hyperparameter, and in the meantime, you might have gotten new data, and you want to pick up from the learnings from the previous tuning job, but you also want to reuse and fuel in new training data that you received in the meantime, right? So there are a couple of use cases where this might make sense to use. So, or you just want to, like, really from a timing perspective, cut them into 2 different times, right? Maybe do one set on one evening and then run the other set on the next evening or next morning. So you can use warm start for that. And there are actually 2 settings which you can use. So there's one setting is keeping the same data and you're keeping the same algorithm, and you're just really kind of cutting those training jobs apart, like from a time perspective. And the second mode you can run this in is called transfer learning. And with transfer learning, I can basically change the training data, and I can also bring in new training data, but still leverage kind of the learnings and overall settings from the previous tuning job. So let's have a look. So in this case, again, setting up the basics here, we should be familiar with by now. Again, looking where's my training data, setting those channels, making sure everything is in here. Again, I need my training script. It's the same setup pretty much, also defining the static mix of hyperparameters, the metrics I want to look for in the logs. And then also again here, I'm creating my estimator object for TensorFlow. No big change here with the static hyperparameters. So if I use the transfer learning, I could also change the parameters I want to tune actually in between. There are some guidelines what you can do, what you cannot do. If you look up in the documentation, if you choose the option with the same data and algorithm, you have to stick to the same set. If you're using the transfer learning option, you can actually change. But the overall, I think it's the overall number between the static and the tuned hyperparameters have to remain. But you can like swap one for the other or something. So there's a little bit more flexibility with the transfer learning. If you're changing too much, it really doesn't make sense to use the warm start. Then you would just run a fresh hyperparameter from scratch, I guess. All right. So set up warm starts here. It's listed. So the one option, the identical data and algorithm, which is really kind of a strategy if you just want to run them in separate jobs, but still be able to pick up from the previous ones. And then the transfer learning option is then if you want to change a little bit different input data set or algorithm. And yes, so again, in this case now, because there's this relationship to the parent tuning job, let's call it this way, we have to retrieve this tuning job name, which we ran before. And note this will only work once you've completed the previous one. So just start them for now and then 0, 1, and then we'll come back. So here I got the name, and then I'm pulling in from SageMaker Tuner here the warm start config and the warm start types. And I'm defining which strategy I want to use. So in this case, I say the warm start type is identical data and algorithm. And I'm passing here as the parent this previous tuning job name. And then I can, again, similar like before, I define the hyperparameter ranges. In this case, they have to be the same because I'm using identical data and algorithm. So it's again those 4 epochs, learning rate, trained batch size, and the freeze bird layer. And I'm setting up my hyperparameter job here again with a tuner object, passing all of that information. I'm also doing 2 jobs in total, 1 in parallel, Bayesian optimization. And the only thing I'm changing here is I'm adding this warm start config to this tuner object. And then again, I can call tuner fit, and this kicks off again the next hyperparameter tuning job. So this one is still in progress. So if I go to the console and look in hyperparameter tuning jobs, we should see that here, and there it is in progress. So if I click in here, you see it's been training for 3 minutes. This one will probably run a little bit longer again, so 15, 20 minutes per job, probably, maybe a little bit more. So yeah, just make sure you start the first one. The second one is really just similar, and just apart from that warm start config. All right, this was a quick example of how you can use just the hyperparameter optimization. So in case you started out maybe with autopilot and you evolved the model and you just want to run a couple of training and optimization jobs on the hyperparameters, it's a great tool to use. Because again, why not apply machine learning to a machine learning problem? And you can spend your time with more exciting things than doing this parameter sweeping across your models. All right, so let me close the previous training notebooks here to keep a little bit the overview. And this basically concludes the SageMaker part. So if I go back here to our workshop, some of you already noticed 8 and 9 are missing. So after the optimization, obviously, the next step is to deploy the model in production. We had a couple of deploy endpoints in the previous notebooks to test our model, but we're definitely working on a whole section here to have more examples, more detailed notebooks on how to deploy on SageMaker endpoints. We're gonna work on this in the next couple of weeks. So hopefully for the next workshop, we will have 8 and 9 also as part of the workshop here with notebooks. So 8, as I said, the deploy, and then in 9, we're gonna do some end-to-end pipelining examples. All right, let me check back with Chris here. Any questions for the SageMaker part before I jump over to the Kubernetes installation?
Yeah, so I think we're good. A couple questions. Someone asked if they could do distributed TensorFlow with SageMaker, and I want to highlight that we are. Actually, I think we let, yeah, Anshay, can you show the train instance count from 06? All you have to do, so it would be in the script mode, yeah.
Script
And
mode.
if you search for train underscore instance underscore count. All you have to do is change that to 2 or higher, and you're running distributed TensorFlow. That's the beauty of it. And if you were doing all this, this infrastructure yourself, you would have to set up, TensorFlow distributed and have, so just change that value to 2, and now you're using distributed TensorFlow. PyTorch the same, XGBoost the same. The only time you can't is when the framework itself does not support it. Spark, for example, does support distributed machine learning, so Spark is fine. If you're doing like a scikit-learn model, those are generally not parallel and have to or are limited to just one node. I think that's it. A couple people asked about certification. I did the A Cloud Guru, it's called. It's in the chat there, A Cloud Guru. And I haven't done any of the Udemy classes. I think, Ansha, didn't you do the Coursera one?
Yes, we do have a couple of those actually. Yeah, I did the Coursera one. This is actually a little bit more high level. I think, yeah, definitely check for the AWS training part. As a cloud guru, they acquired Linux Academy as well some time ago. So there's a bunch of really, really good courses out there. Yeah, check out Get Practice, hands-on, if you have the capabilities and options there, obviously, to not only see it, but also, play around with it, get a good understanding of how technologies work. Look up when you don't understand something, or ask someone, reach out. But I think apart from that, it's a good mix of doing some hands-on understanding, playing around yourself, and going through those materials.
Cool. Yeah, I think we should get to the KubeFlow stuff. We'll also show a little bit about TFX. People are asking more about the GCP stuff. So yeah, I'll try to dig up a link right now for the most recent one. I think it was October where we were doing it on GCP. And I could send the repo as well too.
All right, then let's move on. So this basically concludes, as I just said, the first part that we're primarily executed from SageMaker. Now let's switch over to actually see KubeFlow in action. So I'm going into the folder 10 here, 10_KubeFlow, and there's a lot of content in here, so don't get lost. Again, we're starting here with a 0, 0 now it's getting like 2 times 00 underscore 00 to set up EKS. So for general understanding, and a couple of people asked earlier in the chat window, like specifically, like what's the different hyperparameter tuning in SageMaker versus Katib in KubeFlow land? And it's really coming back to the bigger question, right? Do I want to run machine learning natively on Kubernetes, or do I want to use a managed service as a platform? So they're basically like good arguments and pros and cons, I guess, for all of the different approaches. It's really coming back to the point, what fits your technology, strategy, and experiences the best, what fits your use case the best. If we look now, and we're going to explore now KubeFlow actually, and we're also going to show you how to run that on EKS. So that's what we're going to do right now. So if we do machine learning on Kubernetes, one of the biggest characteristics is that we have to take care of the infrastructure. As you saw in SageMaker, a lot of those choices and the infrastructure work was kind of, taken care of by SageMaker itself. So yes, sometimes we defined the instance types, whether we want to have a GPU instance, a CPU-based instance, but the actual deployment of the instances and everything was managed by SageMaker, right? So coming to KubeFlow now, the first step we really have to do here, and let me run this here, do a run all. The first step that we have to do is really install Kubernetes and have EKS if you're running on Amazon, but obviously have a Kubernetes installation somewhere where we can then install KubeFlow on. So there's a lot more of infrastructure work that is required. So luckily, we don't have to install Kubernetes and manage Kubernetes if we don't have the expertise ourselves, so we can leverage a managed service. And this is basically what EKS is. So it's Elastic Kubernetes Service from AWS. And if you look at this notebook here, what we're basically doing is setting up, obviously, Conda here, pulling in, again, our iframe. And then we're preparing to install now to create an EKS cluster. So, and you can see the code gets a lot more low level here. So we're going back to the CLI here with this %% bash command. And then in the CLI, basically, which we're jumping into with this command, we're doing a pip install for our AWS CLI, making sure that one is the latest release. And then we're also pulling down here a tool called EKS control. So for those of you who are familiar with Kubernetes, there's a command line tool called kube control or kubectl, however you pronounce it. And to manage EKS clusters, there's a similar tool, actually, I think developed by Weaveworks. So we can pull that one in here, so EKS control. And we're using that to deploy and basically create the cluster. So we're curling down also the official kube control, kubectl command here, changing permission so we can execute it. We need to set up some authentication within AWS. So we're also doing this AWS IAM Authenticator tool. We're pulling that one down, installing some little CLI tools here to do tab completion and things like that. And you should see output here say completed in the first one. Then we need to configure some variables here. So we're exporting our region we're currently in. So that's all for all of us, US West 2. And we're also setting a name for the EKS cluster. In this case, just cluster. Not very creative, but serves the purpose. And make sure when you're executing, you see those completed here. That means that the command run. And then we're also showing here a cluster YAML file. So one thing special in the Kubernetes land, everything is basically described in those YAML files. It's basically how Kubernetes works, how we describe all of our resources, how we define the cluster. Everything is done in a very descriptive way in these YAML files. So here we definitely using that also to define the cluster. So as you can see, we're just doing a cat command here to show what's in that YAML file. So there's the metadata where we're passing in the cluster name, the region. We're setting here some metrics that we use CloudWatch here to log information. And we're also defining here the managed node groups. So for Kubernetes to run, we're defining we want to have 5 nodes. And based on C5 X large instances, so those are compute optimized CPU nodes. And those 5 nodes will then form our Kubernetes cluster. And here again is the cluster file, again with a cat command here. And what we're doing next is that we're running the EKS control, create cluster, -f, and then passing the cluster YAML file. So this is Kubernetes language. So we're saying, okay, create a cluster. In this case, as we're deploying EKS on Amazon, we're using the EKS control tool, create cluster, and we're passing this YAML file. And that will actually also, again, take a little bit of time. So be patient here as long as you see this little asterisk. So when it's done, you should see an output like this here. So don't go ahead yet, wait for this command here to finish. And we can actually have a sneak peek. So if I go to the console, I can have a look at EKS, so Elastic Kubernetes Service. I'm just showing you in the meantime to do a little bit of entertaining here while the cluster is deploying. So we see here in EKS, our cluster name called cluster is currently creating. We have Kubernetes version 1.15, and I can click in the cluster here. It's nothing too exciting, I think, in here yet. So we see where it's set up. The logging is set up. Actually, not so much happening right now, but basically this is where you find your Kubernetes cluster. And basically using this EKS control tool or CLI tool, we're leveraging some CloudFormation stacks as well. So let me quickly jump into the CloudFormation. So somebody asked earlier if we actually use CloudFormation in this workshop today. And I said that we're actually doing pretty much everything from hand manually. This is the only exception to the rule because the EKS control tool itself has those CloudFormation templates, which it uses to spin up those clusters, just to make life easier. So in this case, indeed, you will find a CloudFormation template here. So again, if you want to have a look, you can go in the console, services to CloudFormation, and you can see this stack. And as long as this one is still create in progress, you know that the cluster is still being deployed. So we can actually have a look in that. So we click here, and we see that create is in progress. And you can check out what's happening in those CloudFormation templates. So there's the events. So you can see a couple of resources already got created, like net settings. And it actually gives you a pretty nice overview of how much is being deployed as part of Kubernetes. There's net gateways set up, routing tables being set up, control planes, a ton of resources really, right? Private subnets, etc., ingress, routing groups, control planes. Yeah, a lot of things happening. You can check out here the resources that actually lists all of the resources that are being created. So you can see internet gateways, ingress, internode group, security groups. So the nice thing is that this little EKS control tool already has those CloudFormation templates, and you don't have to, you know, remember all of that things to do yourself. You can really leverage the tool. And this one then again spins up those CloudFormation stacks, and in a couple of minutes, the cluster will be provisioned, and we're taking care of the control plane, and then we can work on the Kubernetes and install KubeFlow next. So this is taking a little bit of time here, so keep an eye on that, but basically it will take a little bit of time.
Yeah, so Ansha, I'm seeing a couple people having that weird notebook error that sometimes happens towards the end of the workshop here, where we have so many resources running, they're getting the can't allocate memory. Can you show the screen to kill all the previous notebooks?
Yes, so if you're going to Jupyter here and you click on running, probably your screen looks longer than mine here. I killed a couple of notebooks in between. So again, go to the Jupyter and click on the top on running, and this shows your running notebooks. So all of the notebooks you don't need to have up and running anymore by now. Click here on the shutdown. This shutdowns the kernel and frees up resources. So in my case, I'm gonna shut down definitely the overview notebook. I've done the train of bird model, so I shut down that one. So basically I can shut down, in my case, 06 here. If you have like notebooks open from like 02 up to 010 right now, clean that up. I can shut down 6. I'll keep, yeah, I can shut down the 7 Optimi overview. I'll keep, in my case, I keep the 2 parameter tuning notebooks open for now. But yeah, make sure you're cleaning up all of the older notebooks here by just clicking on the shutdown. And that should hopefully help in freeing up some resources here.
Okay, so yeah, what were you thinking, Ansha? Like, do you want to take a quick break, or I could even quickly show 08 and 09, the ones that I kept out? Yeah,
Oh yeah, yeah,
yeah, a
let's
couple
do
people
that.
are still asking. Okay, so let me switch back.
And make sure you're not killing the Kubernetes cluster that's being set up.
Yeah.
When you shut down the notebooks.
Okay. So I actually just started the EKS cluster a little bit ago and make sure mine finished. So I could take over. Yeah, looks like mine did. So at the end, by the way, you'll see something like this. It's going to spin for a little bit. You might think it's stuck. Don't stop and restart. Just let it run. It'll take 15 minutes before it even shows anything. So just kind of bear with it. And then after that, we'll finish off the KubeFlow install and then do the notebooks. So while that's running, let me briefly, so I pulled out 8 and 9. They are not working as well as I wanted them, as smooth. There was still quite a lot of like, bounce out to the console and do this. So I didn't, and I know that like right around this time, we're all getting a little bit tired and anxious and want to get to the KubeFlow stuff. So wanted to pull some of the SageMaker content and replace it with more KubeFlow stuff. But while we're waiting, I could show you guys real quick. So let's see, what section are we? Deploy. So I don't even think I have anything useful in here. Deploy REST endpoint and then perform batch predictions. This is actually one of the last areas that we've been focused on for the book. It's the part that we probably know the best. So of course we then procrastinate. But really what's happening here, the same kind of boilerplate. We're setting up roles, regions, all that. One thing I'm trying to do, by the way, is work more with with like the inference pipelines and not just deal with a model. And so that's actually one of the areas I kind of got stuck. I'd gone back to my old habits of just deploying the model and jamming a bunch of code into this inference.py. And I could show you inference.py. I don't even think I finished this, but yes, I didn't even finish this. But there's a couple ways, like you could either write one big, .py file that will make the prediction and do all the feature transformation, or you could do it like what's generated from AutoML or from Autopilot, which is a series of steps that actually end up getting deployed as highly optimized Docker containers that can all talk to each other very, very like efficiently on the same instances. So it's just it's similar to yeah, pipe-based communication or yeah. So that's really, so one thing to take away from a product like a service like Autopilot is when you see things coming out of Amazon and they don't seem like they make sense at first, like there's a reason that they're doing this. So when I first saw Autopilot and what was being generated, I was like, oh, this is crazy. Why are they, creating 4 Docker images to do something I could do in one .py file? And there's benefits. There's ways to do it in a non-efficient manner, right? Where very like sloppy implementation, or there's a nice clean way that all of those containers get like deployed to the same instance, and they can all talk like basically natively to each other. So it's kind of the best of both worlds, where you have little snippets of code running in their own containers. They can be like ensembled in different ways. They could be reused. So nice, sort of isolation. It like kind of reminds me of when we made that shift from like monolith to separate like web services, right? Um, it like doesn't make sense at first, because why wouldn't you just put all the code right next to each other? But there are huge benefits to keeping isolation, having tight contracts, and then sort of mixing and matching, that kind of building block like mentality. So really that's the big changes that are going to go in here, is instead of just slapping in a .py file that can do the BERT transformation and then BERT prediction, I like really wanted to write it the way that like Amazon intended this to be built. So not much to show there, but I do want to show this. So this is using step functions. This is, step functions really would be most similar to KubeFlow pipeline or like Airflow. So let me show you. I don't think I have anything in the overview here either. So this is using the step functions data science SDK, which is actually a subset of the step functions like Python SDK, but really meant for data science. So this is slick. I could actually, with one import, I can create a basically build, train, and like deploy pipeline. So this is a lot of the kind of manual stuff I didn't want to subject you guys to. With roles, you could follow along. These are under WIP, by the way, which is work in progress. And you'll see 08 and 09. So back into 09, go back here. So once you actually get through all the IAM role stuff, what you would do is pull out. So this is, again, the location where we put the transformed TF records for BERT. And we are then going to train the model. And we're then going to deploy the model. So one line of code takes that same exact like estimator up above, passes in train validation test, and will do all of the steps, including, so I don't have it set up, and actually that like would have been nice to capture the images, but it will actually launch a step function, which is essentially a series of, if you think of like Airflow, where you have this graph of like execution, where you have the models being trained, then it's being tuned, and then it's being deployed. And you could see all that happening and then render it, and it all hooks into the Amazon right, like CloudWatch, and you can have SNS notifications and do all kinds of stuff. But you could render the progress, keep an eye on it, and then at the very end, you end up with a deployed model. And so now you could schedule this, or you could trigger it off of new data that lands into S3. Maybe there's new TSV files that are being generated by the application, or there's new Parquet files that are being dumped from another system. When they hit S3, we then trigger this pipeline, push out a new model, do an A/B test, and then promote that model. So for those of you that do come from an Airflow background, there are ways to run Airflow on Amazon. There's also ways to, of course, run Airflow with KubeFlow. We're not showing them today. It was just too much content and too much of a speed bump from our kind of end-to-end flow here. But we will likely pull back Airflow in, maybe like towards the end of the year. So I think that's really it. At the end of it, you could call predict. This actually worked surprisingly well. I was not planning or thinking that this was going to go smooth because it is a fairly new SDK, but yeah, this actually worked pretty well. All right, I think that's it for me. Let me check the questions here real quick, actually, before I. Okay, yeah, I think that's it.
All right, so let me take over. My EKS cluster is completed. Can you stop your screen share? Yeah, thank you. All right, so in the meantime, if you've checked your CloudFormation stacks, you should see both of those. So they've got another one added, the cluster node group actually in the meantime. So both of them need to show the screen status create complete. So if you want to make sure in the console here under CloudFormation that you see both the EKS control cluster and the cluster node group both showing up here, create complete. So this is also reflected here in the notebook. So the cell completed here with this long output, and we got it completed. So make sure you're finishing to run this notebook here. We're basically doing here a little bit of describe the stack to us. So we see the whole formation stacks described here in a lot of text. And in the next step here, what we executed in this notebook, if we executed all the cells already, is that we actually associated our IAM policies with the EKS worker nodes. So again, we need to set permissions so that the EKS cluster and the nodes can actually perform the job. So we're exporting here the stack name, and we're also making sure the instance role name is set, the resource names, the RN names here, and then we're attaching the needed policy here. So you can see here, for example, the EC2 container registry access is needed. And once that is done, we can also see here the completed command. And then we really just need to add our new cluster to the kubeconfig file, which then basically picks up the new cluster. And when we run the kubectl command, it knows which cluster to execute it on. So this is also done here for us. And now we can run the kubectl command. And here we run this kubectl get ns for namespace. And you should all see an output like this. There's the default namespace. And there's 3 more kube node lease, kube public, kube system. All should show an active status. That would be really, really helpful. And if you run the kubectl get nodes, you will see those 5 nodes that we initially described as our C5 instances, I think we picked. So those are the physical instances, cloud instances, which comprise our Kubernetes cluster. So hopefully if everyone gets to this point, I think it took me roughly 10 minutes to get this cluster up and running here. So hopefully same time for you with those 5 nodes showing up here. And then we can really kind of open up the next notebooks here. So 01, 02. So 01, I've opened it here. We're basically making sure we have our S3 bucket. So I'm running all those cells. So just in case, sometimes if we go to the KubeFlow workshop straight, we need to make sure we still have our S3 bucket, our default bucket here available. So those commands really just, export this bucket again, making sure we have access. verify everything is set and created correctly. So nothing big in this notebook. And then you can go ahead to the 0002, and we're starting to install KubeFlow. So again, it's a lot of script here. So what we're doing here, again, we're making sure we have information that we need. So we have the S3 bucket as a variable. We have the cluster name, the stack name, the instance role, and the instance profile are set. And let me execute those cells run all before I start talking here again. So we're running that, and then we're basically pulling down another tool, the KubeFlow control tool. You see there are a lot of those cuddle tools around. So KubeFlow also has a KF CLI tool. We're pulling that one. And then to install KubeFlow, like the rest in Kubernetes, it's all done via those YAML files. And if you run KubeFlow on AWS, there's a specific, and they're called the manifest files. So we're making sure we're pulling the latest release here for the KubeFlow installation on AWS, loading this YAML file here, and setting this as our config URI. Then we're giving it again here a cluster name, the AWS cluster name. We're setting a directory. So it's all pretty much the housekeeping tasks you have to do. Creating a directory, and then basically setting a lot of those configuration parameters, the region and config file. You can go through pointing here to the node group. And then we can basically start installing by calling the KubeFlow cuddle command build, and then calling this config file. So we're building it, and then we're applying it. So a lot of setup needed. You will see here the output, and actually once you execute, I scroll through like crazy here now. There's a ton of resources being created that basically comprise KubeFlow. So just scroll through. Here's a lot of red text. It's all info level, so don't get scared just because of the red background color. A lot of chatty things going on here. And then the important thing here is to wait for the resources to be available. So if we're running here this kubectl command, we're looking into the namespace KubeFlow. So if you remember, initially we had the 4 namespaces. Now there's a new namespace being created for KubeFlow. And we're going to have a look into that namespace. And here you see in this output, like all the resources that get created for KubeFlow. So you see here, a couple of them are still container creating state. Couple are finished, couple are running. So re-execute this until we see all are running. And it shouldn't take too long. Those containers and resources actually get started pretty quickly. So I just re-ran after talking for some minutes here, and you see the status changed to running. It's either running or completed. And you can also have a look in here what's actually being provisioned, right? So you see here admission webhook, the ingress controller, Argo, which is for the workflows, our central dashboard container or pod is running. So Kubernetes has this concept, I sometimes say container, but basically the smallest entity in Kubernetes is called a pod, and a pod can consist of 1 or more containers. So yeah, whenever I accidentally say container, I mean a pod in Kubernetes land. All right, so Jupyter is also being deployed. Khatib, the hyperparameter optimization in KubeFlow is being deployed. Controller, metadata, database. So you see here everything basically that that sets up our KubeFlow installation. Also some services here with cluster IPs are created. So I scroll down here, everything looks like it's running or completed, so we can move forward. Executing the next cell here, and here you should see a link. So we can copy that link here, and open it up in a new browser window. And this takes us to the KubeFlow UI. So hopefully everyone has made it to here. So really executing through the Kubernetes notebook 000102. Move that here. And then at the end of 02, there's a link showing up. And this one you can just open in a new browser window. And Chris added some very clear instructions here. So make sure if you're opening that KubeFlow UI that we are using the default namespace here, the anonymous, just to make sure we're all using the same, and don't change it if you don't have to for now. We're using the anonymous here, and then we can click finish, and this sets up our KubeFlow dashboard. So let's actually do this. So here's the welcome screen. I click on Start Setup. I leave the anonymous namespace to the anonymous. If you already called it Peter, we will work around it, but if you can, keep it here to the anonymous and click finish. All right, so we're in KubeFlow. Welcome. So you saw already by the installation, Kubernetes itself, and we already used a managed Kubernetes service with EKS, but in general, back to the comparison of the services, the decision is really whether you want to maintain and manage the infrastructure in one way or the other with Kubernetes, and then install KubeFlow, or if you want to just consume a managed service that pretty much takes care of most of those steps for you. All right, so we're now in KubeFlow land. At the top here, make sure there's select namespace, that you're actually selecting this anonymous namespace here again. So sometimes you will see that it's missing again, so make sure when you click around that you see the anonymous here on the top. All right, let me close my 00 notebook, 01, 02. And there's a couple of more setup steps, so don't yet go crazy in the KubeFlow dashboard. We do have a couple of more setup steps here. So I do open the 003 notebook, which will set up a couple of more things we need, for example, credentials. So again, let me just do a run all here. So we're making sure we're using the namespace anonymous. And then we're actually creating a couple of credentials. So our AWS credentials, we're basically storing as secrets in the EKS cluster. So to make sure that the cluster has permissions to execute tasks. So this is happening here. So with the IAM attached policy, we're creating a user, and we're giving the user a couple of privileges here: access to S3, access to SageMaker, and also access to EC2 container registry. We will see in just a bit in the notebooks where we will actually require that. And then, yeah, we're creating this JSON file, and then we're basically also making sure that those secrets are in EKS cluster as secrets. So this is happening here. So again, we're creating those YAML files, and as the output, you see that the secrets got created. All right, we need to add a couple of more policies. So also for Kubernetes KubeFlow to access SageMaker. So we're creating one more role here, the SageMaker KubeFlow role. Pretty much the same workflow, and also attaching it. So make sure you're running through that notebook. Otherwise, we're going to have some permission issues later. So make sure you're running that. And then basically, I think that's pretty much it. So yeah, we're creating a notebook server next. All right, so make sure you're getting through those setup steps up to 003. And then there's going to be a little bit of confusion moving forward, because we're going to next also spin up a notebook server in KubeFlow. So that's a good time if you had anything left over in SageMaker land. If you want to revisit, maybe have a quick look. Otherwise, make sure you're not getting confused because we're starting a new Jupyter environment as part of KubeFlow. So let me check here. Any questions up to here?
A couple people, were saying that the link wasn't showing up, and oh, have you launched the notebook server yet?
No, not yet.
Okay,
Just next.
yeah, people are jumping ahead to that. So
I
yeah,
might
the
just go.
cluster will fix itself. There's going to be lots of errors if you're poking around at the Kubernetes cluster. You'll see things failing and restarting, and that's okay.
All right. All right. Okay. If you're ahead, I'll speed up as well a little bit here. Just want to make sure everyone catches up. I'm actually closing my my previous SageMaker notebooks I had open, just for the sake not to get confused here. So quick intro maybe on this screen here. I've opened up the KubeFlow documentation website here. So we have this image in one of the notebooks later as well, but just as a quick overview before we jump into the KubeFlow part here. So KubeFlow is really kind of bringing machine learning natively into the Kubernetes world. And KubeFlow, as you've seen during the installation already, it's not just a single application, right? It consists of a lot of different projects. Some of you already know them. I've seen Khatib being mentioned before. So one part is also a Jupyter notebook server. So this is what we're going to do next. We spin up the Jupyter notebook instance, and then we're going to git clone our repo again, like similar to the beginning of this workshop this morning, and then execute those KubeFlow notebooks. So that's why I said don't get confused, because you will have two Jupyter notebook environments open, and you will see errors if you try to run a KubeFlow notebook in the SageMaker Jupyter. So if you can, if you've revisited the SageMaker things, close down those tabs. That helps. And yeah, so in the next couple of notebooks here and in the remaining time, we will see a lot of examples. We will do fairing and fairing example, which basically is a project that gives an easy way to deploy the code you develop in a notebook straight away as containers on the Kubernetes environment. Pretty interesting project. We do have a sneak peek into the metadata, which, as you can tell by the name, stores metadata about your models. There's also a very popular project called Pipelines, which also by the name helps you in creating those more combined pipelines where you can, build more complex steps and execute them together. It's also coming with a really nice UI. And we will do, distributed training on KubeFlow as well, etc. We will talk a little bit more about those projects when we come to the notebook. But let's actually, as the next step, as a couple of you already jumped ahead, create this notebook instance in KubeFlow land. And I'm just gonna, again, keep the instructions here in a split screen and actually open up my KubeFlow notebook dashboard, sorry. So a little bit confusing here maybe on the visuals, but on the left I have the instructions, and on the right I have my KubeFlow notebook. Make sure you're in the anonymous namespace. And in this top left, you see those three, Chris calls it the hamburger menu. So this menu icon top left, the three dashes here, looks like a hamburger. Click on that and you can see notebook servers in the menu. You can click there. And this brings us to the notebook server, which we have to create. So click on create a new server. And we're going to give it a name. We're going to call it notebook. And we're going to do a custom image. So this is why I need to copy it from here. So copy that image name, which starts with pipeline AI / kubeflow notebook CPU and the versions. And copy that with as a custom image into this Jupyter environment here. And we're also increasing the CPU from 0.5 to 1.0 to give it a little bit of more power. Don't do more than that, because otherwise the resources are limited and it won't be able to provision. So make sure you're not giving it, I think one time somebody put in like 16 gigabit of memory, and we actually don't have a node that fulfills that. So keep it to that simple, just increase the CPU to 1.0. And with that, I think those were the settings. Make sure you're in the anonymous workspace, otherwise this will error out here. So call it instance notebook, for example, and make sure the namespace is anonymous. Don't change any of the volume claims. Everything you can leave as default. Just put in the custom image. And then let me make this big here, otherwise I don't see the button again. Click on launch. And this spins up really quickly. It's a small container here, a small pod. So this will just take maybe 20 seconds, something, to spin up. And yeah, and the next step, once this is ready, we're going to jump into this Jupyter instance. And then, like in the beginning, we do a terminal and we do git clone our repo again. So I'm already copying that git clone command from the instructions. And then we're ready here to run the notebooks. So just giving Chris a hint as well that he executes the notebooks here to be prepared. It's always when somebody answers the questions, but we have to get along here with the notebooks as well to be in the same state with you all. Just double checking the 04 is this one, and then the 05, I think. You can run the 05 in the meantime if the instance is still deploying here. It's really just poking around in the underlying Kubernetes. So if you're curious to see what happened here, you can run the kubectl get namespace commands, and you see that KubeFlow already got deployed here. If we look into our anonymous namespace that we created, you can see our notebook server here is running. So that should be coming up here in a second. You can look into logs of containers or pods here. So with this command, so this is just like a little bit for those of you who are a little bit interested more in the underlying infrastructure commands. Nothing too crazy in this one. So I can close that notebook, and then the 06 basically just gives you another hint. From now on, we're executing the notebooks in KubeFlow land. So also nothing to run in this one here. That's just giving you the reminder that we're in KubeFlow land. All right, and you can see the notebook server here is started. I connect. And whenever you get confused in which Jupyter you are, you can see here in the URL, whenever it says something istio system and gobbledygook, this means you're in KubeFlow. When you're in the SageMaker, you will have a much shorter URL saying something like workshop dot, etc. So make sure if you see the istio system, you're sure you're in the KubeFlow environment. Then I'm clicking here, new terminal, going a little bit quicker here. I guess that's clear for everyone. And do the git clone command to have our notebooks inside of this Jupyter environment as well. Should be done here in just a second. All right, that is cloned, and I go back and I see the workshop here coming up. And with that, you see all of our notebooks. Again, we don't have to rerun the first part, go straight into the KubeFlow part. And we're done with the setup. Congratulations. And we can basically now start with the first KubeFlow notebook. And I'm going to hand back over to Chris to walk you through those KubeFlow notebooks, basically starting with the first one here on fairing. And with that, I think, do we need to do a quick break, maybe a couple of minutes, Chris, or how's everyone doing?
Yeah, I think, let's do 5-minute break and then let's get into this. Couple questions, EKS. Amazon does not have managed KubeFlow. It's something I've been asking for quite a while. Since like before joining Amazon, actually. So hoping to see that at some point. Don't have any specific details on that, however. When you pay for KubeFlow, you're paying for the EKS instances beneath the covers. So yes, you're actually paying for EKS, not for KubeFlow. KubeFlow is the open source. It's just an application on top. A couple people asking about how to lock down the credentials. Yes, we should be locking these things down very, very tightly. Right now, they're a little bit broader. These accounts are isolated accounts, and they'll be torn down right after the workshop. So, but yes, I fully agree that these like credentials should be locked down to specific S3 buckets to specific resources. So let's talk offline about that. I want to keep the workshop moving forward and get you guys seeing all the different types of things you can do with KubeFlow. Okay, someone pasted in the image there. Yeah, we're using custom image. That's because it has some things pre-installed, and I have to keep this workshop on Rails. Sometimes KubeFlow, the default Jupyter notebooks aren't installed with the right stuff, so it takes a little bit longer to run. So let's take about let's take a 10-minute break. A couple people are trying to get caught up, and so let's return. Actually, let's do an 8-minute break. Let's return at 2:05 p.m. PT. Thanks. Okay. Oop. It looks like we're a couple minutes over. Sorry, I was reading questions there. Okay. Yeah, so good questions about secrets. Some pretty good um, things there. Yeah, let's be very clear that you should not be running these in your, if it says workshop up here, then that's the wrong place to be. You should be in this goop, um, uh, this host name. And so you should have followed this. So this is confusing. This is that weird handoff point. No matter how many times we say it or try to make it clear, it's always a little confusing. If this says workshop, you're in the wrong place. So typically what I do is I have both of these open side by side, and I look and I see, okay, I'm following these instructions. And then at some point here, we're going to completely cut over to this. This is the KubeFlow one, okay? So let me make sure I ran all these. Also, if you go back to the one that says workshop, you could actually inspect the Kubernetes cluster, which is kind of neat. So I'm in 0005 over here, so workshop down here, and I go to explore Kubernetes, and I can actually see what's going on. Now, I can't do this from within KubeFlow because this has been namespaced to one particular namespace called anonymous. Also note that the word anonymous doesn't mean this is any different than any other namespace. It's still locked down. It's just called anonymous. Probably could have called this notebook or workshop. What we've noticed every time that we give this, people just click, 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 and we found more people that ended up with anonymous than were following instructions to change it. So we just complied and followed the path that the attendees were taking us, which is sticking with anonymous. So this doesn't mean it's public or it's any different than any other. We can also look at let's see, container notebook. Oh, you know what? I called mine workshop instead of, okay. Yeah, anyway, so you could do that. You could also, okay, so here's where it says switch to the KubeFlow notebook server. That means you should not be here, you should be over here. All right, so let's go back to 10. It's telling us here to start from 10 up here and then down. So now we're in 0100 fairing. So just hit run all on this and let's see what it, so I'll explain what's going on here. So Anshik, I think I already gave the intro here, so I'm not gonna spend too much time, but this is KubeFlow. Lots of components. The original KubeFlow was really TensorFlow, or it was Kubernetes plus TensorFlow. There's something called KubeFlow pipelines, which is really what most people are talking about these days when they just say the word KubeFlow. And KubeFlow pipelines is really the competitor to Airflow. The KubeFlow community has not really embraced Airflow. They are putting all their bets into KubeFlow pipelines, which is based on something else called Argo, which was an open source project out of Intuit, people that bring us TurboTax. And I guess the other part of KubeFlow people talk about is these Jupyter notebooks. But that's just kind of a given. So we're installing everything. Also note that we're doing some tricks here where we are programmatically restarting the notebook. If you do the run all, it will always halt right at that point. So you have to kind of keep going because it's basically restarting the kernel. So what's happening here is I'm first training in the notebook. And so again, this is not a pattern that you want to follow. If you're doing small data or just doing quick little models, then this is fine. But just like we saw with SageMaker, SageMaker really wants big data and wants a cluster. So doing it in the notebook isn't always the best. So this is just doing simple model here. It trained, that's the final weight, final bias. Like we're not even really looking at the accuracy or anything. Now we're going to run that same function, and fairing is a sub-project of KubeFlow. Fairing was not one of the original projects. Fairing, the whole goal of fairing is to make this transition from the Jupyter Notebook code that we're all used to into and get this code to run on a cluster. And so that's exactly what's happening here is we're going to, but in order to do that, so KubeFlow, the kube part of KubeFlow means that KubeFlow is Kubernetes native. Kubernetes is Docker native. So at the end of the day, if we want something to run on KubeFlow, it has to run or it has to be presented to like KubeFlow in a Docker image. That then lets KubeFlow hand it off to Kubernetes, and then Kubernetes can then distribute it and run those Docker and run those containers, and then gather that data and then send it back or write it out to S3 or wherever. So we have given this user, the user, when we created the S3 user in our credentials section before, we created this user with access to ECR. So ECR is the Elastic Container Registry. We create a private one for each account, and that's what we're doing here. So we're going in, we're then going to create a Docker image. And this sounds totally crazy, I understand. And this is one of the reasons I like SageMaker script mode, by the way, is I don't have to deal with this stuff anymore. I just give my or like training.py with my Burp code in there, and SageMaker takes care of everything. So in a sense, right now, I feel as though KubeFlow, I'm actually taking a step back, right, like relative to SageMaker. Now, I didn't want to believe this. I spent 3 years building a company around open source and around, pure like do it yourself, build your own. And I spent 3 years not really progressing in my machine learning skills, but progressing in my like Docker command line skills. And that's not really what I wanted to spend 3 years on. So now I'm back into machine learning like world again. And I'm just doing my models, and I push them to SageMaker, and I get the results, and I continue on with life. But for the next hour or so, we're going to step back and get deeper and hands-on, and hopefully tooling does catch up. I mean, that's people I saw on the chat were asking, what's the difference between KubeFlow and SageMaker and Airflow and MLflow, and really all of these things are tackling the exact same problems. It's just different conventions, different configurations, different ways to build the Docker image, different ways to manage, how these Docker images talk to each other. Yes, after many years of this, I don't really care anymore. I just want to focus on my machine learning problem. But here we are, we find ourselves building Docker images, pushing them to the Docker registry. The tooling here, fairing is a step in the right direction in that it can do some of this for me. I still have to tell it a base Docker image to use. Okay, it has to be TensorFlow 114. Has to, and then here I actually give it the Python function that I defined up above. So this is the exact same train function, train and then parentheses, that ran in the notebook and ran successfully. But I want to get this function and that code into my Kubernetes cluster via this Docker container. So I run a bunch of magical fairing commands. Out comes a Docker image. Some of you might recognize this. This is pushing it to a private Docker repo called the Elastic Container Registry within Amazon. Here, it is a first-class Docker repo. It's just like Docker Hub, but it's private. It's locked down to your IAM roles. And kubectl get pod. So at the end of this also, it's not only creating the Docker image, it's actually launching that image on the cluster. And we'll see here in a sec, when this recovers, we'll actually see, okay, so here, this is actually showing the logs as well too. So this is executing it and then gathering the results. And it's basically tailing the logs of that. And so there it is. This gave us, pretty close. So again, not the exact same because like machine learning is stochastic and not necessarily deterministic. And here is our pod. And so actually looks like we're not even seeing it because it got cleaned up here pretty quickly. And this is back. So mine, I by accident named my notebook workshop, by the way. This should be called notebook in yours. Okay, so let's keep going. Let's do a slightly more complex one. We'll do a little bit XGBoost here. Same thing, we're gonna pip install fairing. We're gonna actually this time write out a requirements.txt file and pip install that. So this is gonna pull in some other stuff here. And then doing the same thing. We're just logging into our ECR. We have a slightly more complex model here. Actually, it's not any more complex or less complex. It's just different. The first one was a TensorFlow model, I believe, and this one is XGBoost. Now we're going to train it here in the notebook, and now we're going to do the same thing and train it. This is a slightly, so Fairing has actually changed their API quite a bit actually since it first came out. So I'm showing a slightly different way to do it. But at the end of the day, you have to tell it to use a base Docker image, and then it's going to pull in your source code. It literally pulls in this string that makes up this function and this class. And this ends up running inside of a Docker image. And so the only difference is that you haven't, so you aren't actually running these Docker create commands yourself. Okay. And this ends up getting deployed, so let's run it. We also give it the requirements txt, which it'll slurp in. We give it this data set. I think the first example, maybe we were pulling the data set from somewhere. So these are very, very primitive ways, but just know that the Fairing project really is meant to take your notebook or some function inside the notebook and run it on the cluster. There's also another project called Kale that I'm particularly interested in. I actually haven't gotten this installed yet, but it's actually pretty slick. So check out Kale. I'll paste it into the chat. This is really, to me, the closest thing I've seen to something like Databricks, where you could take your notebook and really deploy it, onto a cluster. Let's see, automated Jupyter Notebook deployments. And I think it creates KubeFlow pipelines out of these things. Maybe every cell becomes a node in the pipeline. It's pretty slick, though, from the demos I've seen anyway. So check that out. Yeah, that's pretty cool. All right, so let's keep going. So again, keep an eye on where you are here. We're in the gobbledygook, which means that we're in KubeFlow. If this says nice clean workshop up here, you're not in the right place. All right, let's pop into TFX. And yeah, let me give you guys a little explanation on TFX. TFX is really what Google had in mind when they first open sourced TensorFlow. It just took them 3, maybe 4 years to finally explain it to us. So TFX is extended. That's what the X stands for, TensorFlow extended. And the extended part means we're not just training a model. There's actually quite a lot more going on than just training the model. So as we've all probably seen, 10% of machine learning is the actual fun stuff, and 90% is the Docker images and the scaling and the cost savings and the feature transformation and the reproducibility. And so really TFX kind of brings all this together. This comes out of Google. Works very, very well with TensorFlow and doesn't really work outside of TensorFlow. I believe that's changing, but really if you're not using TensorFlow, you probably won't benefit very much from TFX. You can spend a whole lot of time writing custom adapters for your XGBoost, and just as long as it supports Python, you could probably get by. But really, if you're not using TensorFlow, probably like other tools out there. Similar to DQ, right? So someone asked earlier, is DQ similar to TFX or one part of TFX? And really, it would be the feature analyzer, which is the second column here. So feature loading, pretty straightforward, just pulling in data, and then statistics generation. So these are all kind of logical steps. Now TFX straight out of the box has demos that work on both KubeFlow and Airflow that take you through all these steps using sample data sets. I've been working on one with BERT. There's a sample that actually comes from Google. It's totally broken, but it's TFX with BERT. And I'm super excited to get that working. I can't seem to get a response from the TFX team to figure out why it's not working, but so yeah, that'd be cool. It will basically do all the same steps that we did with the SageMaker notebooks, but do them within TFX. And this is another reason why I chose TensorFlow for our BERT examples instead of PyTorch for right now, because at some point I eventually do want to get TFX and be able to show the comparison there, both in the book and this workshop. So so feature loading is pretty straightforward. Feature analyzing is really what we were showing with DQ. And so DQ uses Spark for this. The TFX component actually uses Beam, the Apache Beam project, which is pretty much just Google. But I believe there's a way to run Spark with Beam and some other things you could hack together. But yeah, so Beam will let you stream data through, and don't necessarily think of streaming as like streaming like we're used to, where we're sending in data and process. Like really, it's just the ability to look at all of the data, and you don't necessarily have to do heavy processing, but you just want to look at the overall maximum, the overall minimum, maybe like a running mean, something like that. So that's what statistics gen and feature, and so this is a way also to find anomalies, to compare from run to run, which is what we saw with DQ. And so I actually had learned and used TFX before joining Amazon, and when I found DQ, I was like, oh, this is beautiful, right? Like this actually lets me use something I know, which is Spark, and I can run it on basically any data, not just TF records and not just TensorFlow stuff. So TFX is purposely written to be extended. So while right now it's very TensorFlow native, you can certainly customize it. It's just that's a lot of extra work and maintenance. There's also then feature transformation and schema generation. So as we're analyzing all these features, we can then generate schemas and say, okay, every time we've seen this particular field, it's always been a float. So we're going to make a guess that this is a float. Very similar to how Spark can generate schemas when it sees a whole bunch of JSON files or a whole bunch of CSVs, whatever, Parquet. Yes, actually Parquet has the schema built in, so you wouldn't typically use it for that. And then, but feature transformer, so this is in the TFX BERT example, this is where we're actually transforming raw data, so the raw text, into those like word embeddings, those like BERT embeddings. And so I think we have a just really small sample here where we're just doing simple transformations, but it's actually like super powerful. So this would be the equivalent of doing like a SageMaker processing job. Now, actually scaling these out separately and independently, like we did with the SageMaker processing jobs, where you can specify the number of instances and scale it out, I'm not quite sure how to do that. With KubeFlow, you could do it. If you're running TFX with KubeFlow, you could tell it, because each of these becomes a pipeline component. And then there's training the model. That's actually probably the simplest and most studied and most straightforward and most understood, and sort of less systemsy. And then so after that, after the model's trained, we want to actually validate the model. We could potentially compare it to previous versions of the model and choose whether or not we want to push it or not. And pusher is pretty straightforward. We could push into a browser. We could push into a Docker container running TensorFlow serving. We could then do further optimizations. We can run it through TensorFlow Lite, which I will actually show an example here at the very end. And this really opens up kind of I'd shown with step functions, for example, how you could tie all these together. You could also use KubeFlow. You could also use Airflow. So I've even seen, actually, for some of the most mature machine learning shops that I've worked with, they actually still use Jenkins for their machine learning pipelines. And I mean, all these like solutions aren't perfect, but I mean, Jenkins actually works really well, and there's tons of plugins, and you can do retries pretty well, and other stuff. It's not the most natural use case for this. Jenkins is like mostly like building code, pushing things out, but at the end of the day, like you're just writing Bash scripts and Python code or like Jenkins plugins anyway. So yeah, so all of these are possible. And the cool thing about TFX is TFX doesn't really care how you coordinate these different steps together. Just as long as you can write to some like database or some file system and then pull the data back up from a subsequent downstream component. And so I should highlight metadata store down at the bottom. This has been a very active area of development over the last, I'd say, 6 months, 8 months. If it was basically TFX, like when it first came out, had its own metadata store, which is a way for these components to kind of communicate with each other, to write data, write the output so that the next component can then, that becomes the input for the next component. And then at the same time, KubeFlow had its own metadata store. Currently, if you use MLflow, they have their own metadata store. So today we'll actually show kind of the unified one between like TFX and then like KubeFlow. Okay, so the first component here would be TensorFlow data validation. That's really part of this, that's that's like before the model has been trained. So this really is data quality, data validation, similar to DQ. So this is the Chicago taxi trips data set, pulling in some data. Let me just run through this real quick. This is the part that if you are using Jupyter Lab, might not work. You won't see some of the visualizations, so if you use Jupyter, you should be okay. But basically, what we're doing here is kind of analyzing this data, seeing if there's any skew, and then we can actually display and do some slicing and dicing directly in the browser. So that's one of the cool things is, let's see, where'd it go? Yeah, and sometimes you have to refresh. I've noticed if you hit refresh here, I think then they show up. Maybe not. Oh, I was supposed to hit save first. So let me run it all. Yeah, so just do like another run all, save the notebook, and then refresh. So TensorFlow, so I've described like conceptually what this does. So probably won't spend too much time here, but you can look at the statistics that we've gathered and then detect any anomalies. And so this way, from run to run, we can stop the pipeline before we get too deep. And let's see this show here. So let me hit save. Usually it like shows, and then there's an interactive widget that's part of it. Huh, it's not showing up here. So usually that means there's some kind of JavaScript bug going on. Been having pretty good luck with that one recently, but not working for me today. Okay, let's go to the next phase here, which would be the transform. So that's this kind of middle, still before training. And so here's a very simple example. This is actually disconnected from the taxi sample. But here, what we're going to do is scale. So first we're going to calculate the mean, then we're going to scale it between 0 and 1. There's also things you could do here where you're computing vocabularies. If you recall, I had mentioned TF-IDF earlier. When we're creating those embeddings, we need to first gather the entire, well, not first gather, but as we're building this feature space where we're projecting those words into numbers and into vectors, right? There needs to be some kind of vocabulary that we can express and use now from like one run to another run. And so this vocabulary has to get built up. And so you could do this with a transform step. So as you're transforming, and yes, like I said, this is using Beam. There's some pretty ugly like Java code that's embedded here. It has its own goofy syntax and everything. But at the end of the day, you're streaming through all this data, making one pass through all the data. This is where you can build up vocabularies and find means and all that stuff. So yeah, And one thing though about BERT, of course, is that BERT already has its vocabulary and you're just reusing that. So that's one big difference between a like transformer type of like architecture like BERT's and then some of the older stuff like TF-IDF. Okay, so let's actually just jump right into serving. Now, some of you might notice that we're missing the model validation. And I kind of skipped ahead to training the model and then deploying the model. I'm waiting to get the full BERT sample in before I invest too much more time. This TFX stuff has changed quite a bit, but just know that there's a step after you train the model that you can compare and see, did we get a 1% lift in accuracy from the previous run? And if that's the case, then push the model out or fail the pipeline. So one thing I've noticed, right, like working with pipelines over the years is we live in this world of our pipeline stopping, right? Like we live in fear of the broken pipeline. And there's no escaping it, so there's kind of a good broken pipeline or a good stopped pipeline. And then there's a bad stopped pipeline, which is a broken pipeline. A good stopped pipeline is we've caught something upstream and we need to fix it, and this has to get fixed. Broken pipeline is we like messed up an S3 bucket name or something got out of sync, right? So, all right, so that's transform, but let's just jump ahead and let's say that the model's been trained and now we actually want to deploy it. So these are like a little bit disconnected samples here. This is Fashion MNIST. This is the Zalando folks in Europe. They got tired of using the MNIST data set, so they created Fashion MNIST, which is more like appropriate to their domain. These are images of boots and purses and all kinds of things that I personally would never buy. I like my conference t-shirts, which I guess are probably rare items these days. So this is training the model here, and then it's going to package it up into the save model format. We're actually going to do something crazy here, which I've been discouraging doing things in the notebook, but like this is so ridiculous that it's kind of fun. We're actually going to install TensorFlow serving right here in this notebook, doing a pretty low level. Not recommended for the faint of heart here. And then running TensorFlow serving, similar to like how we would run TensorBoard, for example. And then we will actually make a call to the local TensorFlow model server. Now this is crazy. This is more of an ad hoc type of situation, just as like a smoke test to make sure that our model is being trained properly, that we're creating the proper signature for the trained model, for the saved model, and that we can make a prediction. This saves us the pain from having to go out and deploy the KubeFlow pipeline, get the model into production, and then hit it, and we like realize that we specified something as an int and it was supposed to be a float. So this is kind of smoke test. This is in-browser ad hoc fun. All right, so that trained 86%, 87% accuracy. We're saving the model. We're looking at the signature. For those of you that aren't familiar, there is a way to look at the signature of these models. Some of you might not have, I guess, gone this route with your model, with your machine learning experience. Maybe you're just training models and doing batch predictions. Here, we're actually getting this model prepared to become a REST endpoint. And there's ways to actually look at the signature. This has always been a sore point of TensorFlow. It's way too complicated to get to this stuff. They finally added the CLI command. There's also a like Python way to do it. And you can look and see, okay, the input has to be called this. It has to be this size. If you see -1, that just means basically any size. So there can be, yes, any number of rows. They have to be 28 by 28 by 1 matrix. Okay, and then this is the output is going to be softmax. So it's essentially going to return 10 values that have been normalized between 0 and 1. And these end up becoming then probabilities that it is one of the 10 items In the like MNIST case, it was 0 through 9 digit. We were trying to detect handwritten digits. In fashion MNIST, it's going to be these 10. There's going to be 10 of like whatever these are, shirts and shoes and things. Okay, so let's get this installed. Note that TensorFlow model server, and so yes, actually, like TensorFlow serving, so the reason this shows up, some of you might be asking, why is this showing up in TFX? TensorFlow serving was actually part of, or is part of TFX. It was just never sold that way or like marketed that way. When TensorFlow first came out, they wanted a way to serve them, or to show the public how to serve models and not just train them. And there was lots of focus on like productionizing models and like getting them out of the notebook and into production. And so TensorFlow serving, if you see in the bottom right over there, was really the very first way to deploy your models. They just kind of skipped everything in between. And it's very likely, of course, that, excuse me, it's very likely that Google had something, or had like this whole system, right, that was internal, that was all connected and couldn't really be sort of easily split out, right? But and so they've gone ahead and like split these out into clean layers and like named them something pretty normal, like statistics generator and schema generator and right, like model validator. But like TensorFlow serving was very natural. So really, they gave us TensorFlow, which was at the beginning. They gave us TensorFlow serving, which was at the end of the pipeline. And then 3.5 years later, they gave us everything else that was in between. So that's kind of the evolution there. So back to TensorFlow serving. I think it's installing. And then from this point, and so note too that TensorFlow serving supports gRPC and the like classic HTTP REST endpoint. This was also a sore point with TensorFlow when it first came out. It only supported gRPC, and that's because that's all Google ever uses. They don't bother with just regular REST. It's just not efficient enough. And then 2.5 years later, they finally supported the classic HTTP. And then before that, people were doing all kinds of like adapters. They'd spin up a like right, yes, like an Nginx server in front of the TensorFlow model server. And then okay, so let's see. So here's a picture. This is just an example. Looks like trousers, and that's converting the trousers into a tensor that can be read. And now we're actually we're doing the request.post. And it thinks that this ankle boot was actually, so I thought it was passing in, looks like it generated another random one. So this correctly classified the ankle boot as being an ankle boot. You could run this a couple more times. I think it's going to randomly generate some images, or it's just always going to use the boot maybe. Let's see. Maybe we could change it up here. Okay, so maybe it's just always using the boot there. Okay, and it's doing a few more, so it seems to be getting these properly classified. Okay, and then we're like moving towards actually building the pipelines. I'm just setting up sort of the base for the next few more advanced sessions. Okay, and then I'm doing pkill here just to stop the model server. I'm just trying to reduce the amount of resources so we don't get bunched up later on. Let's talk about KubeFlow pipelines. And
maybe to prepare for that notebook, I have a question here coming up. Maybe you can touch on that in that notebook. What's your opinion on when to use KubeFlow pipelines over Airflow and vice versa?
Yeah. So let's see. I think it's going to depend on where you're at in your current pipelines. Of course, if you already have Airflow, there's like no reason to just ditch it. Keep building it that way. If you're comfortable with building Docker images and kind of operating at that level, then one thing that's nice about like Airflow is that it's just Python snippets of code. And there's, yes, every, I'd say 10 years or so, I see this like huge push towards trying to simplify pipelines and create like a sort of an intermediate representation for pipelines. You can go from one tool to another tool. And I used to get excited about that, and now I just get excited about what's actually working for me today. So if I had to start from scratch, I would very seriously look at KubeFlow pipelines, of course. One downside to Airflow is getting it to work on Kubernetes has always been a little bit weird. It kind of works. You really have to kind of know what you're doing. The downside to KubeFlow pipelines right now is it really requires quite a bit of code and knowledge about systems, and we'll get into it here in a bit. There is tooling that's currently yes, in development. There's a KubeFlow pipeline API and an SDK that give you this fairing-like simplicity, or trying to, where you could just give it functions. It's still pretty early, and you still end up writing data out to an S3 bucket and then pulling it in from another KubeFlow pipeline component downstream. One downside to Airflow is there's not really good experiment tracking. You have to build that yourself. There's certainly nothing inside of the stock UI. I've seen demos from the Airbnb folks where it's just completely not the same Airflow that they open sourced 5 years ago. It's totally customized. It has all this machine learning stuff built in. It has experiment tracking, experiment initialization, and they've built all that custom. And that's not going to be open source ever. And if you're really going to start today, KubeFlow pipelines does have some experiment tracking. It's a little bit wonky, but really depends on where you're at with your current pipelines. If you're starting from scratch, yeah, then give KubeFlow pipelines. I'm sure like the ops guy would love to, get her hands right, like dirty with the like Kubernetes. It's just a lot of infrastructure. Whereas with something like Airflow, I could just get it going. I actually like the project out of Databricks called MLflow. For me, I want to track my experiments, and I don't want to deal with Docker images. And all I want to do is take my train.py script and add in experiment tracking and log my parameters. And so if I, for like whatever reason, don't want to work or focus on SageMaker, but I want to keep it completely open source, and I want to do all the infrastructure myself, yeah, then I would seriously look at like MLflow. Actually, very, very simple. It's a from scratch project, so it's not 5 years old, 10 years old, and it has super native integration with Keras and TensorFlow and PyTorch and scikit-learn, and it like really hits the pain points. Whereas so Airflow comes from a data engineering background. KubeFlow pipelines is very, very Docker heavy and Kubernetes centric, and not necessarily tackling my like machine learning use cases, specifically the experiment tracking.
And now we open the door for all the flow projects.
Yeah.
So any opinion on Metaflow, and then I think we move forward here.
Yeah, Metaflow comes out of like my other old company, Netflix. Yeah, I actually don't know too much about Metaflow. I know the team, I know the people working on it. I have very, very good things to say about the people, about the concept. I get nervous when I see projects come out of Netflix or come out of Airbnb because it's not their core competency. And this is just my personal opinion, not my employer's. This is not Ansh's like opinion. My personal opinion is I've seen projects come out of these teams, and then there's one hiring freeze that happens, or someone leaves, and that project goes dormant for 5 years. So so I hope like Metaflow is different. There's also a project out of Lyft called Flyte, Flyte. and people get very, very excited. You go to a conference, get super excited, and then come back and I realize, well, actually, Flight's really similar to KubeFlow, so why would I use Flight? They're constantly battling that, or trying to differentiate themselves from KubeFlow, and potentially talking about like integrating Flight with KubeFlow and vice versa. At the end of the day, these companies are moving people, from they're taking their supporting drivers, right? And like Netflix, for example, they're like helping us stream. They're not really. Their goal is to not, help the community with our machine learning use cases. So yeah, that's my personal opinion on that. I think KubeFlow has the best chance. You've got Google backing it. You've got us like promoting it, right? Like Amazon's promoting it. Yeah, so we love it. And we have this interest in seeing this go forward. And yeah, so that's my concern. And then with Databricks, yes, I think Databricks, yes, obviously very strong company. I think the like MLflow project is being run by some of the best people at Databricks, and they have a vested interest in seeing that project flourish and follow the same path. So yeah, that's my personal opinion there. Yeah, but these are all open source. At the end of the day, they're not going to go away. They are going to be there. It's just a matter of how much do you want to invest towards these projects, and if you do have to switch off, what would you do? Yes, I think KubeFlow is the best bet right now. Yeah, even though some of the features aren't there. All right, so let me jump back. I'm going to go to intro here. KubeFlow pipelines. So there's a KubeFlow pipeline SDK. This is like all of KubeFlow has been changing pretty rapidly over the last year, and I believe is due for another round of improvements before these hit 1.0. So, but let's take the one of the later versions here, more stable versions. We're going to pip install it. Here we're going to build a simple pipeline. What we're going to do is add two numbers, and then we're actually going to make it slightly more complex and add two sets of two numbers. And then we're going to reduce or then aggregate the result of those two parallel adds and come up with one sum for all of it. So this is kind of a silly use case. I'm keeping it simple because I want to show you what is needed to get the simplest thing possible done in KubeFlow. And so if you're using the DSL, which is short for domain specific language, this is built into KubeFlow pipelines. You'll notice you have to build this container op. Now, it's called container op because, again, like I said, KubeFlow is very Docker native. And we're basically building containers. We're building Docker images that get deployed as Docker containers. So of course we have to give it a base Docker image. I think typically by default it's some sort of Python version, typically Python 3.6. Here we're explicitly saying go to Docker Hub, pull down Python 3.6.8 base Docker image that has Python 3.6.8 pre-installed, so I don't have to install it, and then run this command. So Python-C will actually run a string, and we're just packing it with this goofy string here that's literally going to add the two numbers and write the results to a file. We're then going to add a tiny bit of complexity where we're going to echo that result. So echo doesn't need Python. All echo needs is bash. And we're then going to echo the results. So these are two container ops, which we're then going to reference inside of our pipeline. So we're actually using, here, we're using Python decorators, which is basically annotating this Python function to say, this is the definition of my KubeFlow pipeline. And this is similar to Airflow, right? Like you can annotate with Airflow and say, this is my Airflow DAG, and right, like my directed acyclic graph of execution. And this is how things should be done. And this is how things get wired up. So I'm going to name, even with the misspelling here, so that you know that it's not hard-coded or that there's no tricks up my sleeve. I keep meaning to change exit That like drives me crazy. So we're going to add two numbers, KubeFlow realizes it can do this in parallel. And then we're then going to add the result of these two, which then get um, like reduced into the final sum. And then we're going to echo that. So let me make sure I ran this. I sometimes zip ahead. Okay, so here is this compile step. And just like, yes, any compiler, if you step back and think about what a compiler does, at a very high level, it's taking something that's human readable and it's converting it to something that is machine readable. And so that's basically what's happening here. And I'll show you guys some of the details here, but we are compiling this and then we're deploying it. So this is pretty much as simple pipeline as we can create. I do want to take a sec and I believe there's a, well, actually, let me unzip. So I'm kind of hacking here. Unzip. I want to crack this thing open and show you what's inside of here. So even the most simple pipeline you can think of, summing two numbers and summing the result, generates this monster KubeFlow and basically Kubernetes definition. We got secrets here and we have all kinds of stuff going on. But this is the like compile step. So instead of us creating a template or doing something where we have to copy this and fix it, I can express this through my like annotations and through Python code. At the end of the day, though, check this out. So it's essentially running Python with this string as an argument. And that's really all it's doing. It's a base Docker image with Python. It's calling -c, and it's passing it this string. And then these parameters are being defined there, and these parameters have to be fulfilled when we run. So that's what's happening there. There's a CLI version right there. And this is cool. This is a deep link that I couldn't believe works, but it actually does. And this will take us to our KubeFlow pipeline. We can drill in, and here we see the parallel sums, summing, and then the echo. So let's kind of like break this down a little bit. So we have calculate sum and calculate sum 2. They end up in calculate sum 3 and then echo. I can click on here. If you notice, there's a bit of gobbledygook up here. This usually means Kubernetes. And if you looked at your Kubernetes cluster right now, you would see this pod running with the misspelling and everything. We can look at the logs. This particular pod or this code didn't actually write any or print anything to the console. It certainly did write the output though, and the output ended up, so it was adding 4 and 7. This got 11. It created an artifact. I thought it created the text file. Anyway, let's look at this one. Also did the same. There's no logs. Now we're going to sum them. Nothing very interesting here except the inputs become different and then the output and then echo. This one actually does write to the console because it's doing an echo. So very, very simple. Each of these has its own pod that's running. And KubeFlow is the coordinator, or sorry, KubeFlow pipelines is the coordinator that makes sure this thing runs once, this thing runs in parallel, this thing can't run until it gets the results from those. Yes, each of these can be scaled independently. That's always like the next question someone asks. All you have to do is specify the number of workers that you want to fulfill this task. So let's go on to a little bit more advanced. Let's start. So this is really cool. I actually didn't have this in the workshop. Like initially, I wanted to keep this whole section purely the open source. And then as I've been kind of warming up more and more and finding SageMaker to take away all of the pain that I had for the last few years building all this infrastructure, I realized I could actually continue to use KubeFlow pipelines, but I could also call into SageMaker, which is super nice. So you know, we built, by the way, right here, a custom KubeFlow component. We did that using this annotation, and then, you know, represented it using these two Python functions. We have pre-built components that let you call in to SageMaker. So here's a particular GitHub hash that we pin to, just like we would pin to pip installs to a specific version. Here we have train. We have creating a model endpoint, or sorry, creating a model and then creating, this is for a SageMaker endpoint, and then doing batch transformations. So these component.yamls have been pre-built by Amazon, by us, and you can use them in your, so there's like multiple ways to create these ops. You could do the container op like we did before, where we're actually slamming in Python code into a Docker image, or we can reuse somebody else's Docker image, and the metadata is all specified. So if you wanted to, you could actually copy one of these and put it in your browser. And you'll see the first thing you should search for, image. The word image, this is the first thing I do, like whenever I'm handed anything in KubeFlow world, or yes, even Kubernetes world, is I search for the word image. And there has to be an image. If not, it's not a KubeFlow or like Kubernetes native component. And so here it is. This is one of my coworkers. He's created this Docker image. He's versioned it so he can go back to old versions or like upgrade. And he's written all the code that's needed to do the SageMaker instance type, the SageMaker instance count. So all these come in as parameters. And this is how you would define, or this is how you define a KubeFlow component. So when you asked earlier about should I start with KubeFlow? Should I start with like Airflow? Yeah, how do I choose? If you're willing to build all of this kind of stuff and the supporting Docker images, then I think you should use KubeFlow. If you just want to write some Python code and then move on with your life, then you can go back to using Airflow. That's fine. Or even just use MLflow. Or just use a notebook. I see people that have very complex pipelines that they use this project called Papermill. Papermill actually is used pretty heavily at Netflix. It's not a Netflix project, but it sure seems like it. Let me paste this in here. I see people coordinating. This is how you can convert a Jupyter notebook directly into a cron job, basically. So very, very active project, a couple days old. This is one, it's small enough in scope where I have confidence that if this does go dormant, that I could either extend it or keep it the way it is. It's not a super large project like Flight or like Metaflow, where if that thing goes dormant or parts of it go dormant or get rewritten, that I'm in jeopardy. So like this Papermill project, really, really solid. And you can actually, you know, set up and pass parameters into your Jupyter notebooks. And so, you know, this really is kind of an open sourcey way to do something like Databricks, where you take a notebook and then place it onto the cluster and then schedule it. So pretty cool stuff. But yeah, anyway, back here. So let's get these components in there. Here, we're actually going to set up a 4-node component, or sorry, 4-node pipeline that's going to do MNIST, and it's going to use SageMaker. So I don't even have to use the EKS, that cluster that we spun up. I could actually offload this to the pay-as-you-go SageMaker, get the results, put it into S3, and then continue on with my KubeFlow pipeline doing like whatever else I'm doing. So this is really where you kind of bridge, you know, if you're not willing to use step functions, or you want to stay open source for your pipelines, but you still want to reuse SageMaker on the back end, just to do the training and just to serve the models or hyperparameter tuning, certainly do that. There's also, I believe, let's see, AWS KubeFlow components. There's also Athena like integration, which I was pretty excited about because I love Athena. And there's also, these are all the components here. There's EMR like integration as well too. So there is all the components. So you have EMR, you have Athena, and you have SageMaker. And I think within SageMaker you could do You can even do ground truth if you're familiar with the ground truth, which does data labeling. So you can, hyperparameter tuning is supported. I don't see processing jobs. I should probably contribute that actually, because I know quite a bit about processing jobs. That'd be super useful. Okay, and so let's get back here. So let's run this. This is going to actually reuse that same secret that we created before. We're going to then compile this pipeline the same exact way that we compiled the other one. And in fact, I want to crack it open and show you what's in there. So this seemingly simple four node, generates all of this YAML here for the KubeFlow cluster. Okay, and then if you run this, let's deploy it. Again, this will show up. So this will start doing some SageMaker-y things here. If you keep an eye on it, click it. Yes, I have to say the KubeFlow pipeline UI is actually pretty stable. I, for some reason, didn't expect it to be, but usually backends are stable and then UIs have a lot of JavaScript issues, but this is actually a pretty stable UI here. So let's hold off on the artifacts here real quick. I'll explain those in a bit. But so this is going to take a bit. This is basically doing what we were doing in those notebooks earlier, where we were walking you through each of the steps of the pipeline. So again, this is going to train the model. It's going to create what's called a model object, and then deploy that model object, and then do a batch transformation. We really haven't talked much about batch transformations. That's actually, like I said, one of the last things that we're focusing on for the book. While that's running, let's do an advanced. So let's go through here. Essentially going to do the same. We probably don't need to keep doing the pip installs there. All right, let's make sure we got the S3 bucket. Let's look at this KubeFlow pipeline. So I was working with the folks here at Amazon from the EKS team, and I really wanted a non-SageMaker example. And what we did was take basically the same thing that we're doing with SageMaker, except we're now doing it purely with Khatib for hyperparameter tuning, and then training, and then deploying. And then actually they went one step further. They created this sample UI, this like web app that will let me actually test the model that we're deploying. So this actually runs pretty quickly. So let's continue on here. Make sure you don't get stuck at that restart. Let's keep going this way, this way. The good thing is that it's using open source, but it's using my data that's in S3, and that was very important to me. So I didn't want to muck around with public data sets only and that kind of thing. I wanted to use my S3 bucket. So click here for the experiment. So now we have a third pipeline running. So let's keep an eye on this one. This one actually runs pretty quickly, maybe only a couple minutes to deploy lots of stuff. So, again, this is called the end-to-end pipeline. Each of these is a Docker container or Kubernetes pod. Once that runs, we can make a sample prediction. And then we could actually go to the UI down here. So let that run completely. Go back, check on the SageMaker ones, still chugging away. Okay.
And while the pipeline is running, Chris, maybe a quick question here. So how can we actually monitor how much CPU and memory each of these tasks are using?
Yeah, you would. So probably 80% of the questions that people ask about KubeFlow end up being Kubernetes, or the answer comes from Kubernetes and not KubeFlow. So how do you scale it out? How do you monitor? This is all done. So this is the biggest benefit about KubeFlow is if you are completely dedicated to Kubernetes and you've got everything set up, you're like monitoring and auto scaling and triggering off CPU load and like GPU load, then you're in good shape to run KubeFlow. If you don't have that in place and don't want to like deal with that, then KubeFlow is probably not the best choice. One thing I could do, I can bounce out. So now I'm back in workshop. This is SageMaker land over here. So in SageMaker land, I'm going to look at my pods. And okay, the fairing pod. Oh, actually, these are going to be in a different namespace. So one thing I should mention, KubeFlow 1.0 kind of tricked us a little bit, is the harsh way to say it, which is I was led to believe that KubeFlow 1.0 that just GA'd back in March would be completely multi-tenant. And I highlight this because there were a lot of people that thought this. And when they got their hands on 1.0, so lots of people waited, the trick was only the 1.0 projects are multi-tenant. And Jupyter, or the KubeFlow notebooks, they have been graduated to 1.0, and they have multi-tenancy through the use of Kubernetes namespaces, such as the anonymous namespace, which is just an arbitrary name that we chose. KubeFlow pipelines, however, still run in the shared KubeFlow namespace. So KubeFlow pipelines have not graduated to 1.0. So while KubeFlow 1.0, the milestone was met, there were a lot of other projects that didn't actually make it. And unfortunately, the most noticeable was pipelines. So KubeFlow pipelines currently are shared, and they run in a single shared namespace called KubeFlow. And I'm actually going to look for something called, and well, you know what I'll do? I'll take the most unique right here. And there it is. There's end-to-end. So this is a pod, and this pod has been running for a few minutes. So what I'm going to do is I'm going to grab that name of the pod, change the namespace, and I'm going to look at what's going on. Okay, I got to do one more -c main. This particular pod has 2 Docker containers, so when you do logs, you have to specify which container that you're talking about. So the reason I'm showing you the logs from this container is this is a bridge between KubeFlow, which is just an application running on top of Kubernetes, and me and the sysadmin who wants to actually look at the resources and the logs and what's going on. So the short answer here is you would use all of the things that you use to monitor your Kubernetes cluster. You would label these things so that you can track them and keep an eye on how much resource they're using. You also, if you notice, when we cracked open some of these, you'll notice you can specify in the pipeline YAML how much CPU and memory and all that your pod needs, or that your pipeline needs on a per component basis. So sorry, I'm clicking around so much. I want to find. Okay, so, oh wait, is this the Sage? No, this isn't SageMaker one. Anyway, from KubeFlow, you can specify and tell Kubernetes how much CPU, GPU, and memory that you need. And so, yeah, that's ultimately how you would monitor. But there's nothing built in to KubeFlow itself. I believe, I thought I saw somewhere where KubeFlow could show you system resources back in the hamburger mode. I can't seem to find it right now. Okay, so here's the completely open source pipeline that's using S3. And I can look and see logs coming out of each of these. So, pretty interesting stuff. This was doing some hyperparameter tuning, found a good learning rate and a good batch size. And then, let's see, it then deployed the service, it like deployed the MNIST model. And then also, like I said, they went one step further for me and gave me this fancy UI that I can actually test. So now that this pipeline is done, let's actually go to the next step. And this should make a call and give us a response. So this was the input. It was first downloading some data to set up the data set, the test data set to try. And I can run this multiple times and hopefully maybe give me, looks like, yeah, it's like randomly choosing 3, 3, 6, 6. So, this seems to be pretty good accuracy. This seems to be predicting pretty well. Let's take it one step further, and actually, this part's going to be slightly confusing, especially because it's late in the day here. But launch a new browser, put that in your browser, replace the Istio endpoint with the gobbledygook from up here. I didn't get this right the first couple times I tried it. They showed it to me and I still didn't get it right. And put the gobbledygook in here. And make sure you put the colon in there. And that's not right either. You'll at some point get to this. Okay. So follow these instructions here. The Istio endpoint is going to be everything up to this .com and the beginning, and make sure that you get all this right, only a single slash. It has to have a trailing slash. Follow this pattern. If you get there, you can then hit refresh, or there's even a thing down here, a button, and it's showing you the image 7 and the probability, the confidence that it is that value. So just kind of a fun little UI. This is total extra credit bonus. Really, if you can get this to work where it's calling the service, that's fantastic. And note that this is using port 9000, which is the gRPC port, not the HTTP port. Here, we're using port 8500 for our sample prediction. This tripped me up. That's why I'm pointing it out. But right here, this is 8500. This is using the REST endpoint. Here is port 9000 gRPC. Okay, let's keep going. So advanced. All right, let's get in. This is the final stretch here. Let's see. Okay, so distributed training. A couple people asked about this. And yeah, so this is us using KubeFlow to do distributed training. So in SageMaker, this was literally changing one field to be train instance count equals 2 or 5 or 10. Here, we are actually going to use Kubernetes, the power of Kubernetes to do distributed training. But we also need a framework that can support it. So fortunately, we are going to use TensorFlow. We also have a PyTorch example. These are fully distributed and can take advantage of the distributed nature of Kubernetes. So I do want to point out well, it's not subtle. It's actually very, very distinct, but model parallelism versus data parallelism. Model parallelism is the less common, and these are just different types of distributed parallelism. The parallelism that we all know probably, or are more familiar with, or have more experience with, is data parallelism. This is how Spark works. Spark is data parallel. The term is confusing because you're actually splitting the data. Well, yes, I guess it is somewhat intuitive, but we're parallelizing the data and using the same function or the same code or the same model on different data. And so each node in a cluster, if we have 2 nodes, each node gets a separate piece of data, just like we saw with the sharded by S3 key. And the same model is going to train on each of those nodes. They then learn on little batches of data, and then they aggregate the data back to what's called a parameter server. There's other strategies like all reduce and MPI, things like that. But this is very different than model parallel. So model parallel is really what I kind of term like the advanced shops are using. Like Facebook has very, very large graphs, and they can't fit a single model, the whole model, onto a single GPU, for example. This is oftentimes limited by GPUs. Back in Sparklands, we were limited, by how much RAM or how much disk on a single machine, so we had to distribute. That was data parallel. Now it's to the point where I can't actually fit my neural network, the definition, the actual graph of my neural network onto a single GPU, because my model, my neural architecture is so large that 16 gig is not even enough. So we have to split this across. This is much, much more complex than data parallel. With model parallel, you have to be very, very conscious of how the different nodes are communicating with each other. So if there's one layer talking to another layer very, very frequently, or parts of each of those layers, they need to be on the same node, or at least in the same data center. If they're spread across, we'll have lots of communication issues, and there's a lot of just sort of extra things that you have to pay attention to when you're dealing with model parallelism. So let's just talk about data parallelism today. We've already shown it with SageMaker. We'll do it again today. Some of these terms are not really the most intuitive. In-graph, between-graph, really means the same thing as data parallel and model parallel. The other one is asynchronous versus synchronous. So let's take model parallel, for example. Each of these is a separate node that has a subset of the data. So there's 2 workers here. They each have 50% of the data. They operate, they send, they like calculate the error. They then can do the backpropagation and then make changes and pass that learning back to the parameter server. Each of these workers has to do that before they can both start up again. That's a synchronous training job. When you start to get very, very large clusters and you start to get heterogeneous like setups where you have different size GPUs, different size like memory caches, all kinds of stuff. What's going to happen is each of these workers, one might slow down, or a whole cluster will slow down, and now we've got some nodes that are speeding ahead and able to keep up. Or let's take a case where a GPU burns out, and now we have a node that has only 7 GPUs and not 8. And that node is then relatively slow to all the other nodes in the cluster. So when you're dealing at scale, you oftentimes need to switch to asynchronous. Yes, asynchronous will naturally let these other ones charge ahead and not slow down the entire cluster. There are chances where things might not converge, extreme cases like that. Some people celebrate the randomness of this. If one node is slow now, maybe it'll be faster in the future, and there's some natural randomness and stochasticity, right, that's involved with that kind of setup. So yeah, treat it as you will. But in most cases, people are doing model parallel and they're doing synchronous. But when you start getting into the big use cases and the super large scale, you may have to switch to model parallel and asynchronous. All right, so let's run through these. Some of you probably see this error and posted it. Just give it a second here. Let these things complete, and you'll see the logs. So what's happening here is we've created a distributed TensorFlow cluster of 4 workers and 2 of these parameter servers. So essentially, it's going to be kind of like this. There's going to be 4 of these workers and 2 of those PS. And So the reason that there's two PS is it's really bad when a parameter server goes down, because parameter server is storing the state. If a worker goes down, let's say we have a spot instance cluster and that worker goes down, that's okay. That worker will then get replaced. It'll when it starts up, it'll ask the parameter server what's the latest set of values that have been learned by the cluster, the weights that have been learned, and then it'll start getting new inputs, and then everything chugs along. If a parameter server dies, that's a stateful component, and what you want is some kind of replica or some checkpointing going on that you can restore. And so someone asked earlier, what happens if I lose a node? Well, it depends. Is that worker, or yes, was that node performing worker tasks where it was just taking stateless, it's taking just data that's coming in, calculating, comparing it to the predicted value to the actual value, and then, or is it actually storing the state from the entire training run? And so in some cases, losing a node, and so I see people oftentimes actually where they will make the parameter server run, that cluster run on like dedicated on-demand instances, and then workers they would run on the spot instances, and that way you are way less likely to lose your stateful parameter server, and it's okay to lose the worker. And the way that you do this is, as like I said, as 80% of the KubeFlow answers are because of Kubernetes. It's because Kubernetes lets you label nodes as either on demand or spot. And when I then allocate work from my application, which is KubeFlow, down into my Kubernetes cluster, I can say, put these on a particular node that's been tagged with on demand, which means it is not going to get taken away, and place the worker nodes onto the cheaper spot instances, knowing that I might lose one and then have to replace it with an on demand. So that's the scoop there. Okay, so this is running. Let's go check it out again. Let's see. Whenever you see container creating, by the way, that usually means it's downloading the container from Docker Hub or from somewhere. It usually doesn't take that long to create, but it does take a long time to download. Okay, so here's the logs. I don't think I'm going to get all into that. Let me clear that output. Let's do a PyTorch one, show you the same kind of thing. So here we actually just have two workers, one master. So PyTorch calls these things masters and then workers. TensorFlow, they started calling them master worker, master slave, then they changed it to chief and worker, and that was just as bad from a political correctness standpoint. And then now I think they just call everything a worker. But okay, so one thing to highlight, so this is PyTorch distributed. We can specify, GPUs here. We're not actually deploying on a GPU. And so once again, like I said, whenever someone hands you any YAML file, search for the word image. And if you want to track down, just literally go, copy and paste that, paste it into Google, and you will almost always end up at some GitHub repo that's creating this Docker image. That's just how it has been for the last few years with Kubernetes development, and I don't see that really changing. It would be really nice if there was a link to the GitHub repo here, directly. I can go look at it and build it myself. That's almost never the case. But yeah, that's how you can work backwards from that image. And this is typically some, either ECR or like Google Cloud or Docker Hub. All right, so let's launch it. And we should see the same thing here. This is the one master and the two workers. And once that thing settles down, we can look at the logs. All right, I'm going to shift gears here slightly and show you the metadata tracking. So we talked earlier when I showed TFX about how there's that layer let me see if I can get this metadata store layer. So all of these components have to write somewhere, and then so that the next component downstream can pick it up. Well, that's a really nice place to store and track the lineage of how you got from one, or how a model came to be. So this is a somewhat newer API, KFMB, KubeFlow metadata. Once again, we're installing it and then restarting, so don't get caught up on that. Continue right below it. Here, there's a metadata tracking service. We're pointing to this. This is very similar, actually, to how MLflow works, where there's kind of an experiment tracking that's separate, just something popped into my head. And here we're going to, so this is basically simulating, this is not real data, this is pretty new code, simulating tracking the lineage of a training run. So here I'm just kind of putting in sample data. Here's a S3 path, I'm logging the input. Very similar to what we saw with the SageMaker tracking, where this will give us a place to, we can even specify query here, which is kind of nice. Versions, give it some labels. Here we're tracking the hyperparameters. And this knows about this concept of a model and can track the owner, maybe a GitHub repo, the S3 bucket. Okay, and let's take a look. So this is a programmatic way to look at the data frame of the data that we just logged up above. So let's go one step further here. Let's actually, not quite sure what happened there. Okay, let's take a real world example. This is actually doing some training here. Yeah, this is doing kind of just a simple Keras model. It's just logging some dummy data here, giving it like a fake S3 bucket. Really, I think it's just pulling data down inside. And then it's going to log all of that into. So if you go back to hamburger mode, which actually I can't call how to get there. Let me let's go back to this. Oh, is it right there? One sec here. Link it to the hamburger. I can go to artifact store, and this will show me all of the things that I just logged. So this is pretty new, pretty bare bones, but I believe they're working in kind of a graph-like way to show this. But so here we have like the input data set, we've got the output metrics, and then we've got some of the model characteristics here. So you can drill into these and look at the actual hyperparameters. Yes, if you notice, there's a little bit of like overlap here with experiment tracking. You have to drill into these to look at the hyperparameters instead of being able to look at them side by side like we could in like other tools. All right, I'm going to let's kick off the hyperparameter tuning stuff. This is actually going to take I believe maybe about a half hour or so. So we're not going to stick around for it, I don't think. I think a lot of us are getting, or want to get on with our day or our night. But let's launch that, and let's launch the neural architecture search real quick. So I'm just going to do run all, and then I'm going to step back here and explain what's going on. So we've talked quite a bit about hyperparameter tuning. Ansh did a really good job earlier explaining the features of SageMaker, and I put this in the chat also, which is at this point in time, we have all concluded that hyperparameter tuning is the way to go. There's really 5 or 6 ways to do hyperparameter tuning. There's this paper called Vizier, is how I say it. And this project Kati was actually inspired by Google Vizier. So Google's very famous for putting out white papers and then kind of letting other people build the open source implementations. This is a case where Google actually, under the guise of KubeFlow, created the open source version or an open source implementation of this paper. And you can do hyperparameter tuning on basically anything. And yeah, with any framework, when you're in KubeFlow land, PyTorch, TensorFlow, XGBoost, yes, MXNet, these are all pretty much what people are using. But you could just do a simple scikit-learn as well too. All right, so everything in KubeFlow is based on YAML files. And so here, the hyperparameter tuning is no different. Of course, when, just like we did ranges of values, categorical and doubles and things within SageMaker, there's a way to configure this, right? So like I said, all of these frameworks and all of these tools essentially all do the same thing. It's just different configuration. It's different UIs. It's different syntax. And so that's what's happening here. We're just defining different min and max. We're doing optimizer. So this is actually, we're changing the strategy that we're using to do the numerical optimization, which is really cool. That just becomes a hyperparameter that gets passed into, and so really this is generic, right? Like I could define, yeah, so any parameter here, and this will get passed into my train.py file, and I can then use it. And I just say, okay, the hyperparameter tuner chose 0.02, so I'm going to take 0.02 and I'm going to train my model. And I'm putting the results somewhere, and I'm letting the hyperparameter tuning system choose which one was best. And so if I'm trying to minimize my loss or I'm trying to maximize my accuracy, it's up to the hyperparameter tuning system to sort, basically, and then highlight the top 3 candidates or top 5 candidates. So there's not much magic here. It's just doing runs and then tracking them. So Katib has a nice UI. It's changed a little bit. I actually like the older one better, but they are getting better. At the end of the day, I just want to see what is the most accurate and what were the hyperparameters that led to that. Here's a really cool visualization if you haven't seen it, and this actually is in both Katib and in this is also in like MLflow also, and this is called parallel coordinate plot. And what we're looking at here is the metrics on the left. So there's validation accuracy. I go to the top one, and I can actually back into the hyperparameters by going to the right that led to the highest accuracy. Now, this is just a screenshot. It's not the interactive version that you would get within Katib or within MLflow. But you can actually highlight over and then follow these with your mouse, or just click on it and then it'll tell you, or just go down here and then click and then maximize accuracy, and then it'll tell you the top like 3 or 4 candidates. So pretty cool. But yeah, parallel coordinate plots, they basically let you show different size coordinates and in the same chart. All right, so here I think we do a random search. I think Anja talked about that. Grid search is the brute force. If you're like me and you're a little bit OCD, you don't really trust random to find the best hyperparameters, even though empirically this does a really good job. I always feel like there's probably one combination that it missed that I really want to try. So if you have enough compute, you would shift over to do grid search. This is also more expensive because you have to do every single combination. Okay. Then there's Bayesian. And yes, Bayesian uses prior information to influence future runs. So yeah, so again, this is where you want to make sure that you have some sequentialness. You can do a bunch of trials or runs in parallel, but you want to learn from prior and carry that in. So the term Bayesian, yeah, obviously stems from Bayesian statistics, which is an alternative kind of statistics to the classic frequentist, if you're looking for something to read about this weekend. Neural architecture search. Neural architecture search, to me, is a form of hyperparameter tuning. Some people, or actually people will argue that that is not exactly true. Neural architecture search, really, if you consider the choice of architecture or how the layers are stacked and how the nodes are connected and those layers are connected, I consider that to be a hyperparameter because I can change and try different variants. And at the end of the day, all we're doing is um, we're training a model, seeing how it works with the hyperparameters and the architecture, and then feeding that back in and trying new versions and finding the best candidate possible. Neural architecture search can use reinforcement learning. It sort of takes it one step further and can use reinforcement learning to like dynamically create and figure out what is the best architecture. I was just listening to a podcast last night on AutoML Zero, I believe it's called, by Google. And they basically started with 64 Python functions, and that's all that they gave this like neural architecture search basically, and said you have 64 functions, you can do linear algebra and figure out what's the best way to optimize or to learn a particular task. And of course, it found that doing dot products helps. That yes, adding in nonlinearities helps. It discovered batch normalization on its own. It discovered all the things that we have figured out yes over the last like 30, 40 years about neural networks, and specifically last 10 years. And then also hinted at new things that we've explored but not really given enough attention. So like one of the cool things about sort of starting from zero, from scratch, and then seeing how these like neural networks learn is we can then see sort of into the future on things that maybe we should be paying more attention to. And I believe one of the things they found was yes, obviously linear algebra is crucial, and you want to multiply your weights, your like weight matrix by x, and then doing another another like matrix multiply after. So it would be x wx instead of just wx. So doing kind of two sets of like matrix multiplies. I can't remember the details, but like there was something pretty clever that some of the Google researchers had stumbled upon kind of empirically, but didn't really pay too much attention, and then moved on to other things that the human brain thinks our sort of intuition like leads us to. But yeah, check it out. It's called AutoML Zero, and was pretty cool. It took like a really long time and like a whole bunch of processing to get to the point that it's at, but by letting it run and then could like continue to discover better ways to optimize. So that's neural architecture search. Of course, reinforcement learning is a way to kind of try out different things and then refine and right, like provide rewards for doing the right thing. And yeah, so that's like pretty much how the like AutoML Zero works, where it started from nothing but was like rewarded for doing certain things. All right, this is the last section here, TF Lite. I keep this section in because I think it's cool from a conceptual standpoint. It involves systems, like optimizations. It helps you go from just thinking about Python to also thinking about C and the CPU registers and the like GPU and cache lines and things like that. So one thing to note is when you train your model, and let's say you've done all the hyperparameter tuning and done all the crazy stuff, at the end of the day, there's still more optimizations that can be done. And this was something that like we explored quite a bit at my previous company, Pipeline AI, which is we didn't want to just end with model training. We felt that there was actually hyperparameter tuning possible on sort of target specific like optimizations, right? That if I could target a specific GPU type or a particular CPU or small device, there's actually more optimizations that can be made. And maybe I should continue to hyperparameter tune, but not in the classic sense that I've been doing sort of offline in my training phase. So what we were doing was putting out models of different, so for example, we could take a model that's been trained in full float 32 and quantize it down into 16 bits. So all the weights that we learned, all the floats that we learned during training, we could either chop the last 16 bits off like you do in bfloat 16, or you can shrink it down into float 16, and think of still being able to capture the dynamic range of these values, but and still sort of keeping them statistically so yeah, so being able to quantize these down to still represent all of the values and not lose too much of our accuracy, but shrink down the size of our model. So A, this opens up smaller devices that we can deploy to, but B, this speeds up our predictions because now we're doing matrix multiplies on 16-bit floats and not 32-bit floats. So huge matrix multiplies with half the size, that gives us a 2x speed up. Because now we can actually put two matrix or two 16-bit floats onto one 32-bit CPU and do things in parallel. And so there's lots of optimizations that are possible when you do this. The question, of course, is how much do we lose? And so there's ways, depending on the type of model, the type of matrix multiplies that are happening, the type of hardware, there's ways to really only lose just a couple percent in our accuracy, but we can speed things up 3x, 4x, and in some cases 8 to 10. So I've seen people quantize from 32-bit down to 1-bit, which is absolutely crazy, but the deeper your neural network, the more you can represent. And so there's this, there's kind of the extreme thinking, which is, well, if I get each float down to 1-bit, I can now run, thousands of these matrix multiplies in parallel that I couldn't used to. So people have explored this with some really good, and so the things that have bubbled up that 3 or 4 years ago were very, very unknown and not well developed or well engineered. These things are now built into TensorFlow. For example, there's a runtime called TensorFlow Lite. TensorFlow Lite is more than just a post processor. So I call them post-training optimizations. This model's been trained. Now, after training, we're going to optimize it, quantize it down. And then at the same time, it's nice to have this runtime that can also do a little bit of optimization during the runtime. So here's an example. So I'm just going to show you this, and then we'll wrap it up here. So this is a little bit more low-level TensorFlow than you're probably used to. This is the stuff that I like. So here, we're just generating some random data, just doing simple linear regression. It's kind of crazy to be doing linear regression with what is considered to be a neural network library, but TensorFlow is a numerical optimization library. It's not, it just so happens to have libraries and support for backpropagation and auto differentiation, all that. But here I'm just doing simple linear regression. We see the first run out of the gate with very little training. We were able to get a pretty decent fit to the data. So let's just roll with it. What I'm trying to show you here is, and then here's the graph, by the way. This is after a simple linear regression model has been trained. And this is really what inspired my previous company, which was, this is not optimal for production. And as much as TensorFlow was geared towards production use case and getting models into production, they were still pushing out models that had all of the necessary operators to do the backpropagation and to do training. And when you're ready to deploy the model into production, you don't need all of this training specific operators. This is just bloat. These are, for example, these are if statements that are not needed. This is taking up not only space, but this also requires that my runtime has to be able to support all of these just in case. And so there then became ways to prune this graph and to travel only the path that's needed for the actual inference or for the prediction. That was hot for about a year. Those were extra things that you had to run on your graph afterward, and they were very command line. And you had to freeze the graph here. Freezing the graph like burns it in and tells TensorFlow that you're not going to change it. Make some optimization. So some of that stuff popped up. And so look at the size of our graph here is 12K. So not huge, but think of it, this is just linear regression. Let's then, so that's our frozen graph. Let's see, where do I do this here? Let's then cut over into TF Lite land, and let's quantize this model and simplify it and prune it. Okay, actually, here's the saved model. So this is the newer TensorFlow saved model format. This whole thing is 20K. Let's take a look. This is that CLI I was telling you about before you could run to inspect the model. Here's the inputs. That's the size of the input or the shape. Pretty simple. It's just, single vector going in, single vector coming out. So this is with, if I'm just doing a simple Python prediction from that saved model, here's the time, 5 milliseconds. Okay, this doesn't seem bad. Yeah, so I could probably handle that. It's a pretty simple model though. It, in like milliseconds seems to be okay, but when I'm doing these at scale, it's not so okay. What we want to do is take that model and shrink it down, and we can also then use this TF Lite runtime, which can look and only supply exactly what's needed to fulfill this prediction. And this then lets me shrink down not just my model, but the runtime characteristics. So now I can run this on a tiny camera, on a small little sensor. So some of you might be thinking, okay, I don't really deal with cameras or sensors. Why do I care about this? Well, I'll show you why. So we're still in the notebook here. We're not on a sensor. So look how small we made this. So here we're actually converting that 20K model that we saw before down into the TF Lite format. So there's a way to convert it. And let's see what it got down to. 600 bytes, 656 bytes. This is the same model, but shrunken down and quantized. And we turned on quantization, post-training quantization, set to true, converted it, shrunk it all down. Fantastic. Okay, but I'm still not working on sensors. I have lots of memory. Even my phone has more memory than my first computer. But now let's take a look. Let's do a quick, so now we're down to 23, what is that, microseconds? We went from 5 milliseconds down to 23 microseconds. Now, of course, the question is how accurate. Yes, I don't have those, so those details, but what I'm showing you here is there are things you can do after you've trained your model. And so like these are the things that we were doing where we would push these models into production as canaries and do A/B tests on these things. And then what we were even doing was shadowing traffic. We were using Istio for this, shadowing traffic to those models and then collecting these metrics in the back to do real-time comparison between the slower models and the faster like TF Lite models. And we can then tell from a predictive standpoint, how much accuracy have we lost? Is there any skew throughout the day? And then when we were ready, we would switch over these models to become the primary model. Yes, if they passed. Okay, we didn't really take too many breaks there. I wanted to get out sooner than later, get you guys back on. I do want to share one poll before we lose too many people. Launch this poll. Basically, would you recommend this to other folks? I realize this workshop is probably more advanced than you're used to. and certainly understand that feedback. We've actively chosen to be more technical than most. Also, yeah, how likely are you to use AWS for AI and machine learning after this workshop? And how likely are you to use KubeFlow after this workshop? And then Ansha, if there's any themes of questions that you want me to respond to, otherwise.
Yes, so we had a lot of questions in here. One that just came in recently, and I haven't even thought about that yet before. So how does TF Lite compare to the Neo project?
Yeah, I believe TF Lite supports Neo. Or sorry, Neo supports TF Lite is how that would work. Let me double check. So SageMaker Neo, for those of you that don't know, is an open source project by the SageMaker team. It's actually very dear to my heart because it was a lot of the same optimizations that we were building and focusing on. Neo is available as open source. Let me put the link in here. But I believe Neo is basically where all of this stuff is supposed to end up. And it's target specific optimizations and post-training target specific optimizations. Some of you might be familiar with something called TensorRT. TensorRT is also part of Neo. Just double check here. It's a relatively active project. It's pretty low level, so these days I don't spend too much time in here. But if anything, you would use Neo to get down into TF Lite or to convert into the TF Lite format. I'm 90% sure that TF Lite is in here. Let me see. Yeah, test. There's even like unit tests for this. Yeah, this is one of my favorite projects. TF Lite model, model impl. So at some point, Ansha and I are spending the next month working on the deployment chapter, and we'll be spending quite a bit of time. I'll probably be working on the Neo stuff just because it's fun for me.
Great, and maybe one last follow-up question, and then I guess we were scanning through the questions. If we might have not gotten to each and every of those here, we had a really good discussion here. Thanks for that. Was there a drop in accuracy between the TensorFlow and TF Lite?
I don't have those numbers. Like I said, I know it's like leading up the story and then just kind of dropping off. I would need to run more tests, but my point was to show that and there's lots of benchmarks and things on TF Lite. If you search for TF Lite benchmark, that can go into much more detail than my little rinky-dink sample. My point was to show you how the model shrunk and how much faster it became. Yeah, in fact, there's even a whole TF Lite benchmark tool. Cool. Hey, thanks so much, everyone. This went a little bit longer than even we thought, and we even cut some material. All the material is there, by the way, and we'll be posting this in the next couple days. If you want to go back and then like rewatch anything, we love the feedback, love the questions. That's my favorite part is when I'm not speaking and I can answer questions. Okay, yeah, everyone's asking how do I save the files? Let me walk you through. Since I have the mic here. So again, you have two Jupyter notebooks here. You have the SageMaker notebook and the KubeFlow. So on the right, I have the KubeFlow. It's the same for both cases, by the way. What you do is you go new terminal. So on the right, so this is KubeFlow. This is SageMaker. And the reason I have to point that out is because these are in different directories. And do tar cv blah 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 workshop.tar.gz and something like that, right? Now keep in mind, this is going to tar up this, like lots of data sets and models that we pull down. And so it might not necessarily be what you want to do. Same command over here, cv workshop.tar.gz star. I'll paste it here. Yeah, it's going to be a couple gigs. So, I mean, I wouldn't do this. The whole reason that we have this open source is that you don't have to do this. Reminder, you can just git clone this. I'm the same way. Like when I spend a lot of time in a workshop, I want all the assets. But at the same time, I don't want to fill up my hard drive with a bunch of code that I'm probably not going to look at. So here, like just go to the GitHub repo and you can search everything here. Yeah, that's a good point. So Darren points out on KubeFlow side, you could just do the KubeFlow directory. All right, thanks for the feedback. Awesome. And let's see, let me end the poll. And to leave you, like reminder, not to keep giving you polls, but we love the feedback that comes through this. So here's the same GitHub repo that we've been using all day. There's also the book survey. If you want to fill this out, this will help us. It's a simple, I think 6 or 7 questions on how you're using machine learning and which of the Amazon services you would like to see in this book. So lots more detail coming in the book, and look forward to seeing you all in the future. Thanks, Ansha. Thanks, everyone.
Thanks, everyone, for staying late.
Yeah,
enjoy the rest of the weekend.
Yeah, we'll keep these up for 1 more hour, 5 p.m. PT. Then we have to kill them. We have to kill them just for cost, Okay, thanks, guys.
Thanks, everyone. Enjoy the weekend.
Bye.